Hi all, welcome back to our digital. I'm your friend Harshit. I'm very delighted to tell you about a special course that we are bringing for our viewers. For this course, IT professionals easily give up from 25,000 to 1.5 lakhs. Yes, you heard it right. It is no less than a complete hands-on course in which our expert will take you on a journey of understanding Big Data Hadoop framework along with Spark and Scala. By the end of it, you will be confident enough to crack interview questions for Hadoop relevant job roles. So please watch the complete video to understand more about this course.
So in this session, I'm going to cover below topics: why data is required and why we have to store the data, what is the use of data, and what all are the companies that are providing big data Hadoop support, and what all are the use cases is there in big data. And in present market, big data Hadoop or Spark really good? Is there any growth for big data Hadoop or not? So these topics are today I'm going to cover in this session. So first we'll discuss about data. So why we have to store the data? So here, if we see Facebook, Twitter, YouTube, and telecom domain companies, okay. So these all are the big companies. They are generating more data. For example, if we take Facebook, so Facebook worldwide, millions of customers are there. So daily, more data is generating for Facebook. For example, you can assume I'm using Facebook. Today, maybe I will post 10 videos or 10 photos. Also, once I post, my friends will like, and same time they will give some comments, right? So these kind of data Facebook has to store. Why Facebook has to store my data? Why means after 5 years or 6 years, in case if I want to see the old data, my old data 4 years back, what exactly I posted, or 3 years back old data I want to see. At the time, compulsory if I want to see old data, compulsory Facebook has to store my data. So here problem is initially when Facebook entered into market, for Facebook company less data generated, but slowly customers increased, and now for a day almost it is generating worldwide 1,000 terabytes of data. Only Facebook company is generating for a day 1,000 terabytes of data worldwide. So how Facebook will store this data? So before coming to big data Hadoop in market, earlier only RDBMS is there, but RDBMS is supporting to store only structured data. But here Facebook is generating different varieties of data. Varieties means, for example, images, and sometimes audio files, sometimes video files, and sometimes unstructured data also. Unstructured data means whenever you will post some photo, your friends will give comments, right? Maybe some smiley symbols or some comments. In comments, they will add some special characters. So this type of data will generally call as unstructured data. All this kind of data RDBMS is not supporting. So RDBMS is supporting only structured data. So that's why Big Data Hadoop came into market. So here, Big Data Hadoop will support to store any kind of data, even if it is structured or unstructured or semi-structured. It will support you to store your data in Big Data Hadoop. And here, even if you consider Twitter also similar to your Facebook, right? So Twitter also millions of customers, and per day it is generating more data. Also here SMS. So SMS also, for example, if you send your message to some other family member or friends, so telecom domain company, they have to store your data. Also here if you see telecom domain companies, generally they will store call data records also, and same time MMS messages also. MMS means multimedia messaging service. So why telecom domain companies they have to store our personal data? As for the telecom regularity rules, they have to store data. For example, if I call to someone, they will record my data. Why they have to record? Why means, as for the government rules, they have to store data in case some scenarios, okay, if any incident happened, so that time maybe court or police, generally they will ask telecom domain companies, they will ask to submit so and so phone number related call detail records or maybe SMS records related data. That time compulsory telecom domain companies they have to provide that information, or else they will cancel that particular telecom domain company license. So if you purchase new SIM card, later if you call customer care and if you request them, I received new SIM card but my old SMS message is deleted. So if you request all old SMS messages, they will send to your mobile all those old information. So just these are the two examples I am giving. So data, each and every person life, data storage is important. Even if I'm teaching here, maybe I'm working in some software company, so I want to store data, right? For example, previous company related pay slips or maybe documents or maybe my certificates. These are required for future purpose. So compulsory I have to store my data in my personal laptop. So same way, it's not only related to social media companies or telecom domain companies, it is required in all the domains related companies nowadays. So each and every company, they have to store their data. If you go for software companies, they have to store their data. If you go for airlines companies, they have to store their data. If you go for retail domain companies, they have to store the data. Retail domain companies, they have to store data. Some people generally they will ask this question: what sir, you are telling all the data we have to store, why retail domain companies they will store our data? Why means sometimes to grow their business they have to store our data. Why means, for example, today or maybe tomorrow some festival is coming, okay, so 1 year back you purchased some item in maybe more mega store, okay, again they are planning to give some offers coming festival. So at the time generally what they will do, they will take all the old customers related data phone numbers and they will send SMS messages. So coming Tuesday or Wednesday due to festival we are giving so and so discounts, electronics 10% off, or vegetables 5% offer, like that they will give free advertisement. So they will generally use our data for free advertisement purpose. So that's why each and every company generally they will store a data. And not only retail domain companies, if you come to insurance companies, even insurance companies, health insurance companies also they will store our data. Why means, for example, you have only 1 lakh limit to claim for a year, but already you claimed 80,000 rupees. Again suddenly if you're trying to claim another 1 lakh rupees after 10 days, so they have to check your old history, right? Whether you are eligible for 1 lakh. If you are eligible for 1 lakh, already how much you utilized for this year? So you already utilized 80,000 rupees. So compulsory they have to store the data. Then only they will come to know, right? Already you utilized or not. That's why even health insurance companies also they will store customers' data. So nowadays different companies, different types of varieties of data it is generating. So they are storing all kinds of data. So to store all kinds of data, existing technologies are RDBM is not supporting. That's why big data came into picture. So here before big data Hadoop coming in our industry they faced many challenges because existing technologies not supported a high volume related data. So generally RDBMS, if you consider RDBMS, yes, it will support kilobytes, it will support. If your data is there in MBs, it will support. If your data is there in GBs, it will support. But what about terabytes and petabytes of data? If your data is there in terabytes and petabytes, your RDBMS will take more time to store the data. So that is one major problem in RDBMS. So this high volume related data issue solved by big data Hadoop. And coming to high velocity. So velocity means you have to store very fast your data near real time. For example, you done one transaction in ATM. So that transaction immediately you have to store. So that much faster, there is no technology to store that much faster data. So here near real time or real time data we have to store. So for example, if you consider some WhatsApp, if you send a hi message immediately in live, it will reach other person. So that kind of real time and a fast processing kind of technology is required. So very short time, fast processing, only big data Hadoop is supporting here. And coming to next point, variety. Existing technologies is not supporting different varieties of data, like unstructured data. Yes, your RDBMS doesn't support to store unstructured data. And what about images? Yes, RDBMS supporting images. One concept is there, globes and blobs. It is supporting, but it will take more time to store that data. Which technology will support to store different varieties of data means only your big data Hadoop will support to store the data. It will allow you to store structured data, and it will allow you to store semi-structured data, and it will allow you to store unstructured data and images, videos, audio files, any kind of data your big data Hadoop supporting. Fourth point, complexity. So complexity means here see you just assume unstructured data is it will not like structured data, right? Unstructured means generally some special characters or some smiley symbols, or it is not in format, it is a completely different, like a paragraph kind of. So even that kind of unstructured data also using big data Hadoop, we can align in some order, we can process and we can store in big data Hadoop. So these are the four challenges existed. So these four challenges big data Hadoop resolved. That's why nowadays most of the companies they started using big data Hadoop. Big data we already discussed about social networking related and telecom domain related, and even this health insurance related also we discussed, and retail domain related also we discussed. Okay. So coming to some facts and big data market, how big data market is growing. So 2011 worldwide it generated 7.60 US billion dollars, and coming to 2021 it is going to generate a 66.11 billion dollars. So as for industry they are expecting 2026 it is going to generate worldwide 84.69 USB billion dollars revenue. And here I'm going to give some big data examples. So why data is growing? So here left side, if you people see data initially in KBs, after that MBs, after that GBs, after that terabytes, after that petabytes. Now we are in position terabytes. Why data is growing like this? So for example, here I will give one small example. 10 years back, if you send one SMS message or one mobile pic if you take. So that time most of the people they used only VGA cameras in mobile, Nokia mobile or Samsung, small VGA cameras. So if you take one picture, it will generate that file size, that picture size, only KBs it will come. But in present generation and the current situation, each and every mobile 100 megapixel camera or 48 megapixel or 60 megapixel camera. So if you take one pic, it is coming almost to 10 MB size. And if you record one 4K video, if it is coming 1 minute recording, 1 GB file size it is coming. So that means technology is growing day by day. Same time data size also increasing day by day. So initially only SMS concept is there. So that time data size is very small size. Later they introduced the speech to text concept. So instead of messaging, you can speak and you can send audio message. Even nowadays in WhatsApp we have that feature, right? You can record and you can send. So here also data size increased. And later in mobiles, previously there is no HD video recording, but now they introduced completely HD video recording and UHD concepts and 4K video recording also. So automatically data size increased because quality increased, same time data size also increased. And the business data fits. This is any kind of business related data. And external demographics. So here external demographics means generally if you take one video of for example marriages or some engagement functions, generally photographers they will capture video, right? After that they will do some they will apply some graphics on top of that, they will add background music and they will add some text quotations. Okay, so automatically there also size increasing. And coming to next, GPS coordinates. So if you consider Ola Uber cabs, they are using GPS system. So for Ola Uber also per day it is generating more data. How it is generating? For example, if you take cab from one location to another location, okay, so it will calculate. First, it will take your phone number, user data, how many kilometers you traveled, how much amount you paid, whether you paid via some UPI or you hand over the cash, total how much bill generated, complete all the information, even driver related details also it will capture in system. So in GPS system also it is generating data. So for Ola company, not only single cab, right? Each and every big city almost if you consider Hyderabad, more than 500 cabs are running only for Ola company. And Uber, if you consider Bangalore, almost 700 cabs are running. So all the 700 cabs related data daily, maybe multiple trips, one location to another location, from there again another location. So all this information, this kind of data they have to store for recording purpose or future purpose. So that's why even wherever GPS system is there, there also it is generating more data. And the social interactions. So social interactions we already discussed, right? Like a WhatsApp chat related data or Facebook chat or maybe your MS Teams related data. So not only this, earlier people used R code and Twitter, nowadays Twitter. So all social networking sites, there are also more data it is generating. So that data also they have to store. And user generated data. So in case if you generated your own data, so that data also we have to store. So left side data initially in KBs, after that MBs and GBs. Now situation is in terabytes. In future maybe petabytes also it will generate. Okay, and right side I given reasons. So technology increased. So initially SMS concept, later they introduced speech to text, and again later they introduced full HD video and good quality images. and GPS system and social networking systems. Now more customers, that's why more data in social networking. So these are the reasons, and at the same time these are the examples for big data. And coming to Hadoop, so here why elephant symbol and why Hadoop? Who kept this name as Hadoop? Why elephant symbol? Initially big data Hadoop implemented by Doug Cutting. So he is the guy who implemented big data Hadoop. Earlier he worked in one multinational company. After that, due to some issues with management, he left from organization. Almost 2 years he spent in home, and finally he implemented his own big data Hadoop. When he was implemented big data Hadoop, the time he was a kid. That kid, 2 years old kid. So daily that kid was playing with a toy. So the toy is this elephant symbol. So that is the one reason to kept this elephant symbol. And another reason, this technology basically to store large data, big data files. So elephant also looks like bigger. So due to these two reasons, he kept that elephant symbol. And why he kept name as a Hadoop? Why means that kid, whenever he was playing with the toy, so the toy nickname is Hadoop. So daily kid will call Hadoop, Hadoop, Hadoop. That's why he kept for this technology name as Hadoop. Okay, so this is the meaning why he kept Hadoop and why elephant symbol in front of Hadoop. Also, basically, this is open source technology. Big Data Hadoop is completely open source technology. So later, this guy hand over this Big Data Hadoop technology to Apache Software company. So now Big Data Hadoop is from which company means Apache Software company. And what are the advantages? How big data files Big Data Hadoop will handle? It will handle if your data is in terabytes and petabytes also it will handle. Even if it is a structured or unstructured or any varieties of data, Hadoop is supporting on commodity hardware. So commodity means cheap quality hardware also you can store your data. You no need to use supercomputers for storing your data. You no need to use supercomputers. You can store your data on cheap quality hardware machines also. So your big data hardware is supporting, and it will support to read and write operations and also high performance. How it will give high performance? Because here completely distributed your data, it will distribute. Maybe later classes I will give more explanation about how it will distribute. So compared to other technologies to store your data, here it will give high performance. Here which technology is more growth? If you see here servers, so servers overall growth between 2010 to 2015, any kind of server, it is Apache Tomcat or Java server, whatever, 27.3%. And storage, data storage, 61.4%. And networking, any networking, 42.4%. Softwares, in market we have different softwares, right? 34.2% growth. Services, 39.5%. So which one has more growth though? Data storage. So data storage 61.4% growth. How your data will generally store in Hadoop servers? In real time, here we are seeing this is server room in a Yahoo company. So in this server room, Here we are seeing some racks, rack 1, rack 2, rack 3, and number of racks available. So inside each rack we are seeing some disks, right? Here small disks. So in real time, whatever data Yahoo company is generating, all the data it will store inside this hard disks. So for example, you logged in a Yahoo mail, you sent one mail to your friend. So sent items it will show you that body and content too, right? So that all the information in real time it will store inside this racks and inside this hard disk. In real time, big data Hadoop related all the data it will store generally in server rooms like this only. This is just one example how in real time data will store. Understanding about big data. So till now few topics I covered and I will see remaining topics now. And BI tools related already we discussed, and BI related tools also not supporting high volume related data, and different varieties of data also not supporting. Also velocity also different like fast performance related also existing design or architecture not supporting in BI tools. Also it is very expensive to handle complexity related data. So these are the some challenges existed in BI tools also. Those challenges are resolved by Big Data Hadoop. And what are the advantages is there in Big Data Hadoop? So one is this is completely Java based framework. So Big Data framework implemented by using a Java code. So that is completely they implemented using Java code. Also, it is supporting structured, unstructured, and semi-structured data, and it will allow you to process large data sets or large data files. And completely Big Data Hadoop is open source technology. Also, can handle rapidly changing the data. See, can handle rapidly changing the data means, for example, one person is processing structured data, another person processing unstructured data, and one more person processing semi-structured data. Even multiple different varieties of data, structured, semi-structured, unstructured, continuously, if it is coming also, your big data Hadoop will store your data, any varieties of data, any kind of data, it will allow you to store. Hadoop uses not only the storage, so big data Hadoop not only for storage purpose, okay, even Hadoop having processing capability also, not only data storage, it is having processing capability also. Also, Hadoop framework are scalable and fault tolerant. So scalable means, for example, uh, you have only 1 TB storage limit. So maybe that storage is going to full tomorrow. So yes, if it is going to full also, you can buy 1 more TB and you can add into existing cluster. So you can increase that capacity, or you can add more capacity or more storage. So that is called scalable. Increasing or decreasing is called as scalable. And fault tolerant. Fault tolerant means you stored your data in one server. Okay, maybe that server is crashed. What about backup? How about your data? So here each and every data it will store in three different servers, three different places. In case if one place, one location, that particular cluster or server is down also, your data it will read or it will retrieve from different location server. That is called fault tolerant. And also Hadoop enables you to process petabytes of data also. Okay, but at present in most of the companies only till terabytes it is generating. Maybe in future if it will generate petabytes also, your big data Hadoop will support. And also evaluation of Hadoop. So here three things we should know. One is hardware, second one is data, and third one is software. Hardware related mainly 40 years back, it is very expensive, right? So even not only 40 years back, 15 years back, if you want to buy one laptop, okay, just 2 GB RAM and some 250 GB hard disk, 40,000, 50,000 rupees. But now same 50,000 rupees, you will get 8 GB RAM and 500 GB hard disk. So now technology improved and some competition is there between all the manufacturing companies. That's why prices also reduced now. Also coming to second point, data. So data is very important nowadays. So each and every company they have to store data and it is very valuable. And coming to software, here two things. Mainly coming to big data, we have different models. HDFS basically to store your data, and for processing capability, MapReduce model. A little more about the Hadoop. So Hadoop is completely open source project and it is from Apache software company. And basically Hadoop is a framework. So what is framework here? Even we heard right Java also some framework, Spring framework, Hibernate, and different frameworks. What is framework here? Generally, framework means some built-in code, built-in functions, or built-in functionality. 50% code it will come with your software, and based on that remaining 50% we have to implement. That is called a framework. They will define some built-in functions. For that built-in functions, we have to pass our parameters so that it will give results. That is called framework. So Hadoop is a framework here. Basically, here we have two important concepts. One is HDFS. HDFS means a Hadoop distributed file system, and the second point is MapReduce. So HDFS basically it will allow you to store the data. A set of machines running HDFS and MapReduce is known as a Hadoop cluster. Even in one cluster, if it is single node or multiple nodes also generally will call as cluster. Cluster means single or more number of machines. In one server room, you can keep one rack or multiple racks. Each rack contains some nodes. Each node will store some data, whether it is 5 terabytes or 1 terabyte, whatever. Also, HDFS allow you to store data. Basically, to store data back they implemented a Google file system GFS. Based on Google file system, they implemented a Hadoop distributed file system. Based on Google file system, they implemented a Hadoop distributed file system. So basically HDFS, you, you can store your data one time and you can read n number of times. Also MapReduce, it is just allow you to process your data and it will allow you to store inside HDFS. So on top of HDFS, they implemented a MapReduce model. So Hadoop can run MapReduce programs written in various languages such as Java, Ruby, Python, and C++. But usually Java is preferred. Why Java is preferred means they implemented Big Data Hadoop using Java framework. That's why by default Java is preferred. Also here we have some examples of big data that already we discussed, and what is big data or Hadoop? So Hadoop we discussed, it is a open source framework and it is came from Apache software company, and it is allow you to write a large amount of data. Also it will allow you to store your data in large clusters which could have thousands of computers on the clusters. So coming to examples of big data, we already discussed. So Facebook is generating 500 plus terabytes of data per day, and also New York Stock Exchange also it is generating 1 terabyte of data per day. Even Jet Airlines also collecting 10 terabytes of data every 30 minutes. Why Jet Airlines collecting that much data? See, Jet Airlines they have multiple flights, right? So peak hours, maybe Bangalore to Hyderabad, Hyderabad to Chennai, Chennai to Mumbai, or Mumbai to US. So many flights, apparently many flights will run. So each and every flight they have to store customers data, right? Which customer is traveling to which location onboarded. Okay, so whether for him in flight they provided breakfast or not, what kind of ID proof he submitted. So everything they will capture. So that's why it is generating 10 terabytes of data. And characteristics of big data. So high volume, high velocity, variety. So Hadoop is supporting to process high volume related data. And velocity. Velocity basically to analyzing the records, identifying the reason for losses. For example, you consider one retail company is there, maybe Big Bazaar. One customer purchased maybe one item. He paid 600 rupees. So generally, all the cashiers, end of the day after 9 o'clock or 10 o'clock before closing the store, they will give updates about transaction details and the cash they will hand over to store manager, right? So that store manager he will calculate. In case one item 600 rupees it is showing, but the actual price 650 rupees. So generally what they will do analysis why that 50 rupees mismatch happened, whether that is cashier miss or cashier problem, or maybe on top of that item instead of 650 rupees price tag, by mistake they tagged a 600 rupees. So these kind of analysis they will do. So reason for losses, they will do this kind of analysis. So next time they will generally to to resolve these kind of issues. Next time they will conduct a meeting with all the cashiers. So you people are doing these kind of mistakes. So due to these mistakes, we are getting losses. So based on these guidelines, next time they will not repeat, so that slowly this kind of losses it will reduce. So velocity basically to do analysis for business losses and varieties. Varieties already we discussed. Your Hadoop will support any kind of data. And a brief overview of Hadoop history. So initially 2002, dog cutting created an open source. After that 2004, Google published MapReduce based on a GFS papers. GFS means Google File System. In 2006, dog cutting developed the open source project, and initially only MapReduce and HDFS, only these two models came into market. So HDFS it will store your data and MapReduce a processing capability. In 2008, Yahoo company they did one setup in a cluster room. They installed 4,000 machines, 4,000 nodes, and they tested that it is supporting to store data in all 4,000 nodes, and same time it is giving fast performance or not. That kind of testing they done. After that, successfully it, it is reached benchmark within sort of time. After that, slowly most of the big data companies they started using big data Hadoop from 2009 onwards. So in 2009, again Facebook launched a SQL support related module, that is Apache Hive module. So Facebook company implemented one Hive module in Big Data Hadoop. So Hive module generally it will allow you to process semi-structured data. And what are the domain companies they are using a Big Data Hadoop? Social networking companies, airlines companies, banking domain companies, e-commerce, mailing, telecom domain, retail domain, healthcare domain related companies also. So nowadays there are many domain companies, but here I specified only few domain related companies. And coming to companies that are using. So earlier only 50% companies used Big Data Hadoop, but now almost 90% companies they are using Big Data Hadoop. So these are the main companies I just specified for your reference. Also here these are the different components in Big Data Hadoop. One is a HDFS, your data storage purpose. On top of HDFS, these are the modules implemented: Hbase, MapReduce, Hive, Sqoop, OG, Hue. This is about big data introduction. So what is a HDFS here? So HDFS means basically Hadoop distributed distributed file system. So what is the meaning of this Hadoop distributed file system? So distributed means your data or your data files, it will distribute to different systems. So it will not store in a single system. It will distribute to different systems. So file means generally in Big Data Hadoop, your data it will store in a file format. Backend always it will store in a file format. So system means here our data generally it will store in hard disks or machines or nodes. Okay, so all these three same meaning only: system or node or machine. Okay, so HDFS means Hadoop distributed file system. So in HDFS, now we'll discuss about Hadoop architecture. Okay, so first we'll discuss about Hadoop 1x architecture. Okay, so in a Hadoop 1x architecture, we have few drawbacks in Hadoop 1x architecture. Okay, so I will explain now what are the advantages in Hadoop 1x architecture and what are the disadvantages is there in Hadoop architecture, because initially when Apache Software Company released Big Data Hadoop in market, most of the companies they haven't used Big Data Hadoop technology because initial version, okay, in 1x version, few drawbacks they were found. That's why they didn't use the Big Data Hadoop technology. But in later, they they released the upgraded version, that is a Hadoop 2x. So what other drawbacks is there in 1x? All those drawbacks they resolved in Hadoop 2x version. After that, slowly most of the companies they started using this Big Data Hadoop technology. Okay, so now I will explain about Hadoop 1x architecture. You can assume here one user is there. Okay, so he is the user. You can just assume he is the user or I am the user. Maybe if I am trying to store my data, then I am the user. Or if you are trying to store the data, then you are the user. Okay, so now this user having some data file. So here maybe you can assume a data file name customer.txt. So this data file size you can assume 100 MB. This user having one data file, that data file name is customer.txt, and this data file size we are assuming 100 MB. Generally in the real time data file size will get like GBs, terabytes or petabytes. But here, just for better understanding, I assumed data file size as 100 MB. Okay, so now this user want to store his data inside Hadoop. So how it will store that particular customer.txt file. Okay, so to store this data, so who this particular user has to contact. Okay, so here I have one more node. Okay, that node name as name node. Okay, so here this is the name node. Okay, so what is the purpose of this name node? Why we need a name node? Okay, so here generally this name node, it will work like a manager for entire Hadoop architecture. So who is the manager for Hadoop architecture means name node is the manager for Hadoop architecture. Okay, so what it will do? So generally it will store metadata it will store. So where it will store is it will store inside hard disk or RAM memory. So it will always store metadata inside RAM memory. Okay, so what is metadata here? Okay, so generally metadata means here we have file, right, customer.txt. Okay, so that particular file name it will store, file size also it will store, and file is in which location, that particular location or path also it will store, and the user requested to store the data, so that particular username also it will store inside metadata. Also here which date that particular user requested to store the data, also timestamp, so exactly which hour and which minute which second that particular data file stored. Okay, not only this, here block id also it will store, and a block size also it will store. So what is block id and block size? For example, in our laptop generally we'll store our data, right? So where it will store? Inside hard disk it will store. So hard disk means a small chip, right? Okay, so that chip contains some storage capacity, whether 1 terabyte or 2 terabytes. Okay, so inside that chip small blocks available, each block having some storage capacity. Okay, whether that is a 64 MB or 1 GB, whatever. Okay, so that particular block id also, that information also here it will store, and the block size also, each block storage related capacity also it will store here. Okay, so all these generally will call metadata. Okay, metadata. So this information will call metadata. This metadata inside name node, inside RAM memory it will store. Okay, not in hard disk. So why it will store only in RAM memory? Why not in a hard disk? Okay, generally this name node has to interact with multiple users in real time or live. Okay, because now one user requested, parallelly maybe n number of users will request or n number of users will connect with the name node. So for each and every user parallelly name node has to give response. So if parallelly in very fast it has to respond means compulsory name node has to store this metadata in the RAM memory. To read data from RAM or to read data from hard disk, which one will be more faster means only RAM memory. Data reading from where it will be fast means only if you read data from RAM memory, then only it will be fast. Hard disk means it will take time. Okay, so that's why here always name node they will use high-end configuration machines. Okay, because it has to interact with multiple users or multiple nodes same time. High-end more RAM also they will use here. More RAM is required because to store metadata. Okay, so this is about metadata and name node. Now this particular user will connect name node. Okay, hi name node, I have one data file, I want to store my data, could you please allocate me some space so that I can store my data? Okay, now name node is received request from user. Okay, so in that situation compulsory name node has to give response back to user. Okay, so now what name node will do? Okay, so before going to response, we'll discuss about some other node. Okay, so here I'm assuming I have some data nodes, okay, maybe I have three data nodes. Okay, in real time maybe a number of data nodes or thousands of data nodes or thousands of systems or thousands of machines. Okay, so first one I'm just calling as uh, data node 1, and second node I'm just calling as data node 2, and third one I'm calling as a data node 3. Okay, so now I have total 3 data nodes. Okay, so what is the purpose of this data nodes? Okay, your actual data, so your customer.txt file contains some data, some content, or maybe some data. Okay, so that the entire data and the entire content where exactly it will store means inside data nodes. Only data nodes having a storage capability, name node having only metadata storage capacity. Okay, but the actual data always it will store inside data nodes. Okay, so in real time n number of data nodes they will use based on a project requirement. Okay, so each data node capacity may be 1 terabyte or 10 terabytes. Okay, that is based on requirement. Okay, so now here each data node contains again some blocks. Okay, because each block it will store some piece of data. Okay, here I am assuming total 3 blocks available in each data node. Okay, so even my data node 2 also 3 blocks, and also data node 3 also 3 blocks. Okay, so here first one I'm treating as B1 block, and the second one I'm treating as B2 block, and the third one I'm treating as B3 block. Okay, so same way here also uh, B1 block, and here also B2 block, and here also B3 block. So like that, if you have n number of missions, each mission n number of blocks. Okay, in real time n number of blocks. But here I am just assuming each data node I have only 3 blocks. Okay, now you can assume this is completely new cluster. This cluster, all the data nodes and all the blocks completely space is free, completely entire space is free. Now who is having this information? Okay, so which data node contains space is free and which data node completely occupied. So that particular information only name node should contains. Okay, so what other data nodes is full, what other data nodes is space is available, that information only name node having, because name node is the manager for entire Hadoop architecture. Okay, now this name node has to give response back to user, right? Because user requested for storing the data, so name node has to allocate some blocks. Okay, so here just I'm assuming, so randomly generally name node will pick up data nodes and blocks. Okay, randomly it will pick up. So here data node 1 it is assigned b1 block, data node 1 b1 block it is assigned. So here 64 MB data we can store, and again we can assume randomly data node 3 here, maybe you can assume b3 block assigned, and 36 MB we have to store. Okay, so name node now giving a response back to user. Okay, for you I assign total 2 blocks. Okay, how many blocks? Total 2 blocks. one block inside data node 1 b1 block and another block that is inside data node 3. So you can go and you can store your data like that name node given response back to user. Okay, and here maybe few people they will get confused, why 64 MB in b1 block and 36 MB in a different block. Okay, Hadoop 1x architecture, each block default storage size 64 MB. Each block default storage size 64 MB. That's why name node allocated two blocks because this data file 100 MB. So for to store 100 MB data, how many blocks is required? Two blocks required. In real time, not 100 MB, terabytes. Okay, if it is terabyte means n number of nodes and n number of blocks it will assign. Okay, so now what user will do because user got response. Okay, so here I have one more node that is called a job tracker. So what is the purpose of job tracker here? Okay, so generally job tracker having a processing capabilities. Okay, so in entire Hadoop architecture, who is having a processing capabilities means only job tracker having a processing capabilities. That's why when you want to store your data, you have to contact job tracker. Again, whenever you want to retrieve your data, compulsory you have to contact the job tracker. So via job tracker only we have to read our data or we have to store our data. Okay, now this particular user will contact job tracker. Okay, hi job tracker, for me name node assigned so and so a data nodes and so on so blocks, could you please help me to store my data? So this is the request got from user. Okay, now what job tracker will do? So job tracker again it will contact the name node. Okay, hi name node, so and so user requesting me to uh, process data, so could you please let me know, can I proceed or can I wait? Okay, so based on that, here again name node will give a response back to a job tracker. Okay, you can proceed whatever user requested, that is correct. Then now what job tracker will do? Okay, so here now job tracker will split your data file. So who will split your data file means only job tracker. So Hadoop framework will split your data file. Okay, so your data file name is customer.txt. Inside that some content is there, but here it will split. Okay, so split one 64 MB data it will. So 60 first split 64 MB data, split to two remaining data 36 MB. Okay, if it is 200 MB means how many splits? Four splits. So by default name node will assign four blocks because each block storage capacity 64 MB. Okay, so these split one split two. Okay, now it has to process. Okay, so before discussing about the processing concept, here I have one task tracker. Okay, so generally each and every data node contains one task tracker. Each and every data node contains a task tracker. Okay, so what is the purpose of this task tracker? Okay, what is the purpose of this task tracker? Okay, so generally task tracker, whatever job tracker will assign work to task tracker, that task tracker it will execute and it has to complete that work, and again it has to give response back to job tracker. Like for example, you can treat job tracker is the a lead for task tracker, and generally in real time what we'll do in software companies. Okay, so lead will assign some work to developers, right? Okay, again end of the day or maybe next day status call, all the developers they have to give status update like that particular task is completed or it is in progress or he is unable to do. Okay, this kind of progress developer has to give lead, right? Okay, so here also same, job tracker will assign tasks to the task tracker. Task tracker has to complete that work, and then again it has to give progress report back to job tracker. Okay, if it is successfully completed, then successful information it will send. If it is failed, failure information it will fast, and it will in progress means in progress information it will send to a job tracker. Okay, so this is about the task tracker. So task tracker is not separate node. Data node, each data node is separate nodes. Each data node contains task trackers. So task tracker is a small kind of Java process. Okay, inside that machine itself, one small process will run, that is called a task tracker. Okay, now this job tracker parallelly split one, it will send to data node 1, and split two related data, it will send to this task tracker, because here node, so inside data node 1, data node 3 only it is allocated, so parallelly distributed. So your data file is very large also, terabytes, petabytes also. Hadoop framework, it will split into small chunks. Those n number of chunks or n number of small files, parallelly it will distribute to multiple systems. So parallelly it will execute all your data files and it will store inside Hadoop. Okay, so here also job tracker, first split it sent to task tracker, and second split it sent to another task tracker. Okay, so inside data node 1, b1 block it is assigned, right? So here half of the data 64 MB it will store here, and remaining 36 MB inside b3 block data node 3, right? So here 36 MB it will store. So parallelly both the task trackers will execute and it will store the data inside the task trackers. Okay, now, okay, sir, you said each block size 64 MB, but here you stored only 36 MB. What about the remaining space? Okay, in a Hadoop 1x architecture, once you store some data, it is less than 64 MB, like 30 MB or 40 MB. Once you store some data file, remaining space completely it will be waste. It is not possible to store another data file in same block. So this is one a drawback in Hadoop 1x architecture. Okay, so remaining space completely it will be waste. So your block size is 64 MB, but you stored 1 MB data file. So that means remaining 63 MB it will be waste. Okay, so this is drawback in 1x architecture, but 2x in 2x they resolved that issue. How task tracker will give status updates to job tracker? Okay, because job tracker assigned one task to task tracker, so that task tracker executed and it is stored data inside b1 block. Okay, but after storing data into b1 block, task tracker has to give updates back to job tracker, right? So how it will give updates back to job tracker? Okay, so here we have one concept, okay, that is progress report. Okay, how task tracker will send a progress report to a job tracker? Okay, so here task tracker to job tracker. Okay, basically, in a Hadoop 1x architecture, we have heartbeat signal concept. Okay, so generally, every 3 seconds, each and every task tracker will send heartbeat signals to job tracker. By default, every 3 seconds, task tracker parallelly all the task trackers, each and every task tracker will send heartbeat signals to the job tracker. So what is the use of this heartbeat signals? Okay, so first point every 3 seconds, but second point, what is the use? Okay, so use means if task tracker is sending heartbeat signals to job tracker, that means this particular job tracker will assume that this task tracker is alive. Okay, if it is continuously sending status to job tracker means then job tracker will consider task tracker is alive or not. Okay, if it is continuously sending, then job tracker will assume, okay, this is alive, this task tracker is working with a good health condition and it is alive. Now for example, this task tracker 3 seconds happen, so heartbeat signal not sent to job tracker, you can assume, and again after 3 seconds also it is not sent. Then how job tracker will consider this task tracker is not alive or not with a good health condition? So job tracker will wait till 10 attempts. 10 attempts means each attempt 3 seconds, right? So till 30 seconds, job tracker will wait. Even 30th second or 10th attempt also, task tracker not sending any heartbeat signal to job tracker means then this job tracker will consider this particular task tracker is crashed or not with good health condition. Okay, then further tasks it will assign to different task trackers. So job tracker is assuming this task tracker is dead or crashed, so whatever further tasks will be available, those tasks it will assign to other task trackers because this task tracker is not working, first task tracker is not working. Okay, so this is about your second point. Okay, and third point, progress report. Okay, progress report. Okay, so job tracker assigned one task to task tracker. So task tracker has to execute that job and it has to store data inside block, right? So once that task is executed, then task tracker will send a status to job tracker via same heartbeat signals. Every 10th attempt, every 10th attempt, it will send a progress report to job tracker. That means every 30th second, it will send a progress report to job tracker. Okay, so and so task is successful. If successful means successful information it will send to job tracker, or still it is in progress means in progress status like 30% completed, 30% in progress, or 40% in progress, or 70% in progress. So that information via heartbeat signal only every 30th second it will send to job tracker. Even if it is failed also, failure information, if it is failed also, failure information, this particular task tracker will send to a job tracker. So this is the use of heartbeat signals. Okay, so make sure that these 3 points very important. Okay, only these 3 points, due to these 3 points only job tracker will come to know task tracker, work related, progress, or task status. Okay, so first point, every 3 seconds heartbeat signals it has to send to job tracker. If it is continuously sending means then job tracker will consider that okay, this particular task tracker is alive. If it is not sending means it will wait till 10 attempts. Even 10th attempt also, if task tracker didn't send any heartbeat signal means then job tracker will consider task tracker is dead or crashed. And the third point, every 10th attempt, task tracker has to send a progress report to task job tracker. Okay, progress report to job tracker. Okay, so now job tracker got a response back from each and every task tracker, and then same job tracker will give update to user. Okay, whatever task you requested that is executed successfully. But now my doubt is, here we have 3 data nodes. Data node 1 3 blocks, but one block is full. Data node 3 we have 3 blocks, but third block is full. So how name node will come to know these 2 blocks is full? Because name node should have that particular information, or else if different user will request again name node, right? I have one data file, I want to store my data, could you please assign some blocks? But name node should know, right, what are the blocks is already full and what other blocks or space is available. That information up to date name node should have that information. So now how name node will come to know this particular block is full or not. Here also each and every data node it will send heartbeat signals to name node. Each and every data node will send heartbeat signals to the name node. So what is the purpose? What is the purpose? Okay. So now again heartbeat signals concept only, but a heartbeat signals between data nodes to name node. Earlier task tracker to job tracker, but now heartbeat signals concept between data nodes to name node. Okay. So here also every 3 seconds, this is by default 3 seconds. Okay. By default 3 seconds. Every 3 seconds each and every data node will send a heartbeat signals to name node. That means name node will consider, okay, this particular data node is alive. If it is sending continuously heartbeat signals to name node means then name node is considering that particular data node is alive. Okay. In case if this data node is not sending heartbeat signals to name node, then it will wait 10 attempts. Even if 10th attempt also data node didn't send any heartbeat signals to name node means then this name node will consider this particular data node is crashed or not with a good health condition. Then what name node will do? Then further user requests, the name node will consider to assign blocks to only data node 2 and data node 3 because this data node is not responding. This is crashed or maybe not with good health condition. Okay. And now here it will send block level report also. Block level report means data node has to give updates to name node. What other blocks, how many blocks are there? What other blocks is full? What other blocks or space is available? So while sending heartbeat signals to name node every 10th attempt, each and every data node will send a block level report to name node. Okay. So I have 3 blocks. B1 block is full and B2, B3 block space is available. So this information data node will send to name node. Then name node will update inside metadata. So data node 1 only 2 blocks available. That information it will capture. Even B1 block also full. That also it will capture. Okay. Whenever some other user will request, then name node will consider only B2 and B3 blocks because only B2 and B3 space is available. And same time this data node also parallelly it will send heartbeat signals to name node. So here also B3 block full means 36 MB. Okay. And the remaining space it is not possible to use for other data file because remaining space completely it will be waste. So this data node also it will give update only B1 and B2 block space is available. So all this block level information each and every data node via heartbeat signals it will give updates to name node so that the name node will update metadata. Okay. So this is how name node and job tracker getting updates from data node and the task tracker. Okay. Now I have one doubt. So this particular data node you can assume crashed or not responding. But here user trying to read the data. Maybe user executed one query, read query, select star from employee or select star from customer. Then how it will read the data? How it will read? Because this this particular data node itself crashed, that machine itself not working. Then what is the backup? Okay. So Coming to backup now, generally in Big Data Hadoop, each and every piece of data it will replicate in three places. Okay, now we'll discuss about the factor replication factor. Okay, so replication factor by default your data in Big Data Hadoop, three different places it will replicate. That means you can assume same data, maybe same data, it will be replicate in maybe another block. Okay, so same data now you can assume here also available 64 MB, and same data it will replicate here also. So that means here also 64 MB available. Okay, so now you have backup, right? If first data node 1 goes down, name node have information that same copy of data it will be available in data node 2 and data node 3. So from here it will read another copy of data and it will show to user. So this is what about replication factor. If one copy not available, other replication copies related data available in Hadoop cluster, from there it will read your data. So even now data node 1 is crashed, maybe third also crashed, but still data node 2, inside data node 2 one more copy available. Okay, so by default replication factor, by default three copies of data it will store, but you can increase replication factor, you can increase or you can decrease also. Okay, you can decrease also. So if your data file size is 100 MB, with replication how much space is required? 300 MB, because replication factor 3 means 300 MB. Okay, if it is 10 terabytes means 30 terabytes of space is available. So replication factor by default 3, but you can increase or you can decrease. Okay, if you want you can make it only 2 replication factor, that means only 2 copies it will store. Or if you want 10 copies each piece of data, if you want 10 copies you can specify that also. That is basically configuration where they will do this replication factor configuration. Means in backend we have one data file hdfs-site.xml file. Inside that XML file basically Hadoop admin team they will do configuration like heartbeat signals configuration, and the same time they will do uh, a replication factor configuration also. Okay. See, by default here every 3 seconds, and here also by default of 3. In case if they don't want 3 means they will in configuration file they will make it a 5, or maybe they will change it to 2. Okay, here also instead of every 3 seconds they can make 10 seconds, or maybe they can make 2 seconds. It is based on maybe a traffic or maybe a project or requirement that is configurable. If you don't want to configure, by default it will consider only 3 seconds and replication factor 3 copies. Okay, so this is about backup or replication factor. Now you can assume all these nodes are there in only one location and one server. So if you keep your data center in only one location and one server, if that particular server or location maybe something happened, means your entire cluster will be down. At that time data backup not available, and even you are unable to access. So that's why in real time, generally what they will do, they will maintain multiple servers or multiple clusters, like maybe in India one location, okay, maybe Bangalore one data center they will maintain, or maybe some different location US you can assume another data center. Okay, so whenever name node will assign blocks to user, what it will do, nearest data center two copies, okay, nearest data center two copies it will assign two replication factor, but the longest distance server, maybe in a US server, it will assign third replication factor related block. That means you can assume data node 1, data node 2, you can assume that only these two nodes in India server, these two missions. But the third mission or third data node, it is available in USA. So if India server is completely down also, data available backup in a USA server. So from there it will read. Whenever user trying to read the data, then it will read from USA server and it will show. That's why most of the multinational companies, they will maintain data centers in different locations, because if one location, if one server goes down or crashed also, data backup will be available from other location. Okay, so same way even here, this 36 MB size also it will replicate in uh, different nodes. So to replicate also here, okay, basically 36 MB, okay, 36 MB. So same, this also third replication, okay, third replication required, okay. So here third replication, here also 36 MB, okay. So whenever name node will give response back to user for space allocation, name node will assign blocks with replication. Okay, initially we discussed like here only two blocks, right? So basically if I tell about a replication starting itself, you people will confuse. That's why generally if your data file size is 100 MB means how many blocks required? 64 MB one block, 36 MB two blocks. That means total two blocks with replication. With replication, how many is required? 2 into 3 replication factor. Total 6 blocks it will assign. Your name node with replication factor, 6 blocks it will allocate. So user can contact job tracker. These are the 6 blocks for me assigned, so that job tracker will help to store the data, same data in 6 different blocks. So this is about replication factor. Okay, so if one data node goes down, we have backup another data node, or maybe from different location server or different data center it will read. But my doubt is, if a job tracker system or node goes down, what is the backup? Okay, so then there is no backup. Okay, so here 1x disadvantages or drawbacks. Okay, drawbacks. So first point, space wastage. This already we discussed, right? Out of 64 MB block storage space, if you store only 36 MB, remaining space will be waste. And the second point, if job tracker goes down, again we have to wait till job tracker is up. There is no alternative. No one will do job tracker work here. Single job tracker, only job tracker having processing capabilities. to read your data or to store your data, compulsory each and every user compulsory has to contact only job tracker. So there is no backup for job tracker. If job tracker goes down means we have to wait till it is up. We don't know when Hadoop admin team will make it up. Maybe if this particular job tracker, if some power suppliers some repair means they will do immediately within half an hour or one hour. Maybe they need completely, maybe that particular mission or node is crashed means again they have to replace, right? So they have to buy that particular node or system or hard disk. It will take time, right? So we don't know within half an hour or 2 or 3 days. So that till it is up we have to wait. That is one major drawback in Hadoop 1x architecture. Okay, now if name node goes down, what is the backup? Without name node it is not possible to contact data nodes, or even for retrieval also it is not possible. Data retrieval also not possible and data storage also not possible, because to read your data or to store your data, user or job tracker compulsory has to contact name node only, because name node has to give information. Your data stored in so and so data center and so inside so and so data node and so and so block. So that information only name node is having, because name node is the boss for entire Hadoop architecture. So now this name node goes down means there is no alternative or backup. If name node goes down, here I have one FS image. Here I have one FS image, and you can assume here I have one more node, that is secondary name node. Okay, now I will explain about FS image and secondary name node. What is the purpose of FS image and secondary name node? First we'll discuss about FS image. Okay, this FS image, what it will do generally, each and every data node will send progress block level report to name node, right? Every 30th second. Okay, that means every 30th second name node is updating metadata, always latest metadata. Okay, so whatever metadata, latest metadata, generally it will come, it will be same, it will be available in FS image also for backup purpose. Okay, so it will keep that every 30 minutes till 30th minutes FS image will keep metadata backup, and it will send to secondary name node. So that means FS image always latest metadata, it will keep till 30th minutes. After that it will move to secondary name node. Again next 30 minutes whatever latest uh, block level report or metadata it will update in name node. Again it will keep next 30 minutes, it will keep latest metadata in FS image. Again it will send to secondary name node. So secondary name node is backup for name node, only metadata backup. Okay, just please note down this point. Okay, only metadata backup. That means if your name node goes down means your secondary name node will not work like name node. That capabilities secondary name node doesn't have. Only metadata will be available backup in secondary name node, but secondary name node will not act like name node. So if name node goes down means we have to wait till it is up. Then what is the use of secondary name node? Why secondary name node is required here? That means in case if this name node completely crashed, Hadoop admin team, you can assume they replaced with the new mission or new node. Generally what they will do, first they have to install Linux operating system. On top of that they have to install HDFS Hadoop softwares. Once the system is ready, then entire metadata they will copy from secondary name node to new name node. They will make new name node up. So once name node is up, then entire old metadata like which user related data is there in which data node or which block or which data center, that information again new name node having, right? Because secondary name node having always latest metadata and old metadata also. That entire metadata Hadoop admin team they will copy into new name node. Then new name node will work like your old name node. Only that is the purpose secondary name node available. But till name node, new name node is ready, everyone has to wait. So this also one major drawback in Hadoop 1x architecture. So this is about Hadoop 1x architecture. Okay, and next session we'll discuss about Hadoop 2x architecture. So 1x architecture, what are the drawbacks we have noted here? Those drawbacks Hadoop 2x resolved or not. So those things we'll discuss in next session. Okay, so before going to Hadoop 2x architecture, here generally task tracker will execute, and here your data it will write, right? Whatever content is there inside data file, that content who will write inside block. Okay, inside block who will write your data. So here we have two classes. One is a data streamer Java class, another one pipeline Java class. These two built-in Java classes, it will come with the Hadoop framework. Okay, so data streamer Java class, what it will do? Whenever task or tracker will start executing this data streamer Java class, it will write content inside the B1 block. Your data file contains some data, right? That data who will write inside block means data streamer Java class. Okay, but what is the purpose of pipeline Java class? Your only first copy data, first replication copy data, only your data streamer Java class will write, and the second replication and the third replication copies of data your pipeline streamer class will take care. Pipeline Java class will write second copy and third copy replication copies related data who will write means pipeline Java class, because all the three copies only data streamer has to write means it will take time, right? That's why only data streamer class first copy of the data it will write, remaining second and third copies of data pipeline Java class will take care. So internally other data nodes will interact each data node. So for example, first copy this 64 MB. So this data node 2, it will connect with the data node 1 B1 block, and it will copy the data into B3 block. So second replication copy. Same way third replication copy. This is how about 1x architecture. Okay. Before starting 2x architecture, few things we want to understand about 1x related. So here in this slide, we are able to see 5 important nodes. That is, first one name node, second one secondary name node, and third one job tracker, and fourth one data node, and fifth one task tracker. So whenever Hadoop admin team want to install Hadoop software on top of Linux operating system, compulsory they have to set up these 5 nodes. Okay, so here Node means you can assume as a system or you can assume as a hard disk. So Hadoop perspective, always instead of calling system or a hard disk, we have to call here a node. Node means one system. So here all these five nodes, they have to configure Hadoop admin system. Okay. So who has to configure all these five nodes means Hadoop admin team has to configure all these five nodes in a cluster. So we have one concept here. What is a single node cluster and what is a multi-node cluster? So single node cluster means same mission. If it will work like name node, secondary name node, job tracker, data node, and a task tracker. So all these five processors are running in same mission means that is called a single node cluster. What is a multi-node cluster? Multi-node means each processor will run on different missions, like a name node separate mission, secondary name node separate mission, job tracker also separate mission. So each and every processor running on different nodes means that is called a multi-node cluster or fully distribution mode. So generally in Hadoop interviews, uh, they will ask like what is the difference between a single node cluster and a fully distribution mode. Okay, so we have to explain. Single node means all the five processors running in same mission means that is called a single node cluster. If all the processors are running on different missions, that is called a multi-node cluster or fully distribution mode. In all the real-time projects, generally they will use a multi-node cluster. But in personal laptops or most of the training institutes or organization means educational institutes, they will use a single node cluster. So here in Hadoop 1x architecture, we discussed about block size, right? Okay. So 1x default block size 64 MB. This we discussed, okay? But we can increase up to 128 MB. Okay. So by default with the Hadoop software, it will come like 64 MB, but we can increase up to 128 MB. So even you can increase up to 90 MB also, but the max limit 128 MB only. And coming to 2x, Hadoop 2x, default block size 128 MB, but you can increase up to 1 GB. Okay, so this also sometimes in interviews they will ask, okay, what is the uh, block size in 1x and what is the block size in 2x and up to what level we can increase the block size. Okay, so this is about Hadoop 1x and 2x block size, and based on block size your split also Hadoop job tracker will take care, right? If block size is 128 MB means each split also your Hadoop framework will split into 128 MB only. And about the replication factor, we already discussed, right? Okay, so each block it will each copy of the data it will replicate into three different blocks. Okay, and about name node, we already discussed that it will store only metadata. Okay, but without consulting the name node, it is not possible to access the data files in HDFS. Okay, so if you want to access your data, compulsory first you have to approach only name node, because name node knows that where your data stored. So for reading purpose or writing purpose or delete purpose also, always each and every user has to consult only name node. Okay, so here five important nodes. This we already discussed. A name node only to store your metadata, and a secondary name node that is only for backup purpose. Whatever data is there in name node, same metadata always it will keep a backup in secondary name node. And data node, your actual data files, it will store inside data nodes. And coming to job tracker, so processing capabilities only job tracker having. And here all these five nodes, they divided into two categories. Okay, so master nodes and slave nodes. Master nodes, name node, secondary name node, job tracker, these three will call as master nodes. And task tracker and data node will call as slave nodes. And in this diagram, client means you can assume user, or I am the user, or I am the client. So I want to process some data, or I want to store my data. So processing capabilities, so who is having means only MapReduce having processing capabilities. And the storage capabilities, which component having means only HDFS component having process storage capabilities. So under MapReduce, job tracker will take care about the processing capabilities, and storage or space allocation name node and the secondary name node will take care. So all these three nodes will call as master nodes, and a number of data nodes and the task trackers will call as slaves nodes. So here if we see, each and every job tracker and task tracker sending heartbeat signals, right? And even data node to name node also heartbeat signals going on. So heartbeat signals we already discussed. Okay, so whatever tasks job tracker will assign to task tracker, so that work task tracker has to complete, and again it has to give progress report back to the job tracker. And here also each and every data node has to send a block level report to a name node. And about the name node, so first point is name node is a master node. And the second point, name node will call as a manager for a Hadoop architecture. And the third point, name node always it holds only metadata. Metadata means file name, file size, block ID, block size, file location, and the username, timestamp, date. So these all will come under metadata. And next point, for name node we need more RAM is required, right? Because it has to give fast response to each and every user or each and every data node. That's why more RAM is required for name node. Also in 1x we discussed, right? Name node is the single point of failure for the Hadoop cluster. We have to wait until it is up. So we don't know when Hadoop admin will make it up. Okay, so this is one major drawback in Hadoop 1x architecture. So in maybe later slides we'll discuss about the 2x architecture. At the time we'll see whether this major drawback is resolved or not. Also here I have two data files. So foo.txt, bar.txt. So foo.txt name node assigned three blocks, and bar.txt name node assigned two blocks. So here I have three data nodes left side, another three data nodes right side. So you can assume this is a first rack. Rack 1 contains three data nodes, and the rack 2 contains another three data nodes. So 001 block, how many places it is replicated? So data node 1, one copy is there, and here also 001, that means second copy is there. and the third copy it is there in a different rack and a different data node. So why third copy it is placed into different machine and a different rack means if that copy also if we keep in the same rack, if this rack goes down means all three copies of the data it will impact. So that time it will be problem to access the data. That's why Hadoop framework always third copy of the data it will place in a different rack or different node or different data center or different location related server. Coming to secondary name node, so we know about secondary name node, it is just a backup purpose. So whatever metadata, latest metadata always available in a name node, same metadata, this FS image every 30 minutes it will send to secondary name node so that the secondary name node will keep a backup. And coming to job tracker, so job tracker first point will call as master node and who is having a processing capabilities means only job tracker having processing capabilities, that is called second point. And third point, always job tracker will coordinate with the task tracker. Okay, so what all are the tasks assigned to task tracker, those tasks completed or not, so that tracking also your job tracker will take care. And about data node we already discussed. Okay, so data node only your actual data it will store, and uh, data node always it will send a block level report to name node. So like what other blocks is full and what other blocks space is available, that information via heartbeat signals it will send to name node so that the name node will update metadata information inside the name node. And the task tracker, we know task tracker generally will call as a slave node. Okay, so this slave node, whatever work a job tracker will assign, same work it will execute and it will give progress report back to the job tracker. Like if it is success message, if it is failure message, if it is still in progress means it will send like 20% progress or 30% progress like that. Coming to Hadoop 2x architecture, in 1x architecture we have 4-5 drawbacks. Those 4-5 drawbacks in 2x there is allowed. So remaining all architecture everything same only. Okay, so first point here if we see name node. Okay, so name node Hadoop 1x we have only one name node, but in 2x we have multiple name nodes. So they introduced a multiple name nodes concept, but max number of name nodes you can keep in a cluster only 4 name nodes. Okay, but in real time projects they are using only 2 name nodes instead of 4 name nodes. They introduced multiple name nodes. Okay, so name node 1 and name node 2, name node 3 and name node 4. But here if we observe all the data nodes are sending heartbeat signals to the name nodes. But who will give response back to the data nodes or who will give response back to the users? Okay, that means out of 4 name nodes, one name node will be in active mode. Remaining all 3 will be in standby mode. So the active mode name node has to take care about responses. Okay, so now this active name node will take care everything. In case if this active name node goes down means immediately your name node 2 will up. So this will it will move from standby mode to active mode and this will work like your first name node. So again if second name node goes down, third, if third goes down, fourth, if fourth goes down, obviously your secondary name node available. So generally in real time if one name node goes down means Hadoop admin team immediately resolve that issue immediately. Okay, so they will not wait till 4 name nodes goes down. Okay, so this is a name node issue, one major drawback in 1x architecture because single name node is there. So that issue they resolved in a 2x architecture. And coming to second point, Hadoop 1x, we have space wastage in a block, right? Instead of 64 MB file, if you keep only 30 MB file inside a block, the remaining space it will be waste, right? Okay, so in 2x, there is no space wastage. Even if you keep 30 MB file in one block, remaining space we can use for other files. You can store other files in the same block itself. So there is no space wastage in 2x architecture. Okay, so that is second point. So that issue also resolved in Hadoop 2x architecture. And coming to third point, Hadoop 1x, for one cluster, it is allowing only 4000 nodes. Okay, in server room, you can keep 4000 nodes. So for one cluster, it will allow to configure only 4000 nodes, but not more than 4000 nodes. But in a 2x architecture, you can configure for one cluster n number of nodes, but they tested with only 10,000 nodes, but Apache software company is telling that it is supporting a number of nodes. Okay, so that is a third point. And coming to a fourth point. Okay, so fourth point, we have in the 1x architecture we have task tracker, right? Each and every data node contains one TT. TT means a task tracker, but in 2x that TT they renamed as NM. NM means a node manager. So task tracker they renamed as a node manager. So each and every data node contains here a node manager. Coming to fifth point, Hadoop 1x we have job tracker, right? So that job tracker here they renamed as a resource manager. Okay, so except these five changes, there is no difference between 1x and 2x. Okay, so when they released a Hadoop 2x in market, after that onwards only most of the MNC companies they started using a big data Hadoop, because when initially they released 1x, there are many issues and drawbacks in 1x. That's why most of the companies they haven't used big data Hadoop. But later, after releasing 2x, most of the companies started using a big data Hadoop. And here coming to Hadoop cluster. One cluster I have a number of racks, rack 1, rack 2, rack 3, rack 4, rack 5 like that. So rack 1, one name node remaining all data nodes. Rack 2, job tracker remaining all data nodes. And rack 3, secondary name node remaining all data nodes. And here remaining all the racks only data nodes. But here why they kept name node, job tracker, secondary name node on different racks? Why means these three nodes generally will call as master nodes. So if you keep all the master nodes in the same rack, if the track goes down means it will impact for all the master nodes, right? So that's why all the master nodes in real time Hadoop admin team they will configure in a different racks and different missions. So that is the meaning of this slide. In real time projects they will use only two name nodes. So instead of four name nodes, they will use only two name nodes. One is active name node, second one is standby name node. But all the data nodes will send a latest metadata via heartbeat signals to the all the name nodes. Okay, so if this name node goes down means immediately this standby name node will move to active mode and it will work like your first name node. Okay, here I have one server name node, secondary name node. Rack 1 contains three data nodes and rack 2 contains only two data nodes. So I have a data file here. You can assume this data file size is 94 MB. You can use a Hadoop command, or you can write a Java program, or you can write a SQL query using anything. If you try to store your data, it will split into two copies, right? In one X 64 MB first split and remaining second split. So 64 MB, how many places it is replicated? Data node 1, data node 2, and the third copy it is placed different rack and inside data node 4. Even if you see a blue color related two copies in rack 2, but third copy in a different rack. Coming to heartbeat signal, we discussed, right, every 3 seconds each and every task tracker has to send heartbeat signals to the job tracker, and the same time data nodes also it has to send heartbeat signals to the name node. But task tracker to job tracker only progress report, but data node to name node block level report it will send. And now you can assume I have 5 nodes, but I have to configure like I have 5 systems. Which system has to work like name node, and which system has to work like secondary name node? So, so that kind of configuration Hadoop admin team will take care. Okay, so by default with the Hadoop software, we'll get these XML files. So master.xml file. If you configure a specific mission related IP address inside this XML file, then that mission will work like a secondary name node. And we have one more XML, that is core-site.xml. So whatever mission related IP address you will specify inside this XML, so that mission will work like a name node. And slaves.xml, inside this XML file you can configure n number of IP addresses. Those n number of missions will work like data nodes. And we have one more XML file, that is mapred-site.xml file. So here if you configure specific mission related IP address, that mission will work like your job tracker. So basically these configurations Hadoop admin team will take care. For just knowledge purpose, I am explaining here. And the types of installation we already discussed, right, about a single node cluster and a multi-node cluster. Also, your Hadoop it will support to store your data. That means write operations it will support, and read operations also it will support, and delete operations also it will support. Okay, and in HDFS model, all the configurations, if you want to do any kind of configurations, backend we have one XML file that is called HDFS-site.xml file. Inside this XML file, you can configure your block size, you can configure replication factor, and you can configure heartbeat signals and trash interval also. Block size means default 64 MB. If you want, you can increase up to 128 MB in 1x. So that here value is there, right? Here they will change. And replication also by default 3, but instead of 3, if you want to increase up to 10 or 7, you can change that value here. And also heartbeat signal by default 3, but you can increase a 4 or 5 or 6. Okay, so these configurations generally admin team will take care. Okay, but just for knowledge purpose I am explaining here. Okay, and we have block level report. So block level report, we know each and every data node will send block level report to the name node. And a safe mode, okay, this is one important point. A safe mode, generally, for example, you have one Java server. If you start that server to up that server, it will take 1 minute or 2 minutes time, right? So same way in a Hadoop also, if you start a Hadoop server to up that Hadoop server, it will take some time, 1 minute or 2 minutes. In that 1 or 2 minutes, your Hadoop server will be in a safe mode. If server is there in safe mode means it will allow only read operations. Once a server will come out from safe mode to normal mode, then it will allow write operations, read operations, and delete. All these three operations it will allow. Okay, so here I have given some Hadoop comments to check a safe mode status. Maybe once I will start practicals, I will explain how to check server is there in safe mode or not. That I will explain later. And the next concept, types of scaling. Okay, so we have two types of scaling: horizontal scaling and vertical scaling. Horizontal scaling means, for example, you have only 10 machines. Those 10 machines almost data is full. So what you have to do, whether you have to buy new machines or you have to increase existing machines capacity. Okay, so if you add new machines into the cluster, means that is a horizontal scaling. Okay, but instead of buying new machines, existing machines itself, if you increase the capacity, that is called vertical scaling. Here we are going to install Cloudera Kickstart VM. Okay, so whoever want to do practice in personal laptops, you people can do same setup. So all the installation related links I will provide in the description section. Okay, so Hadoop software installation main, we are going to install only Cloudera Kickstart VM installation. So in this, generally we have to install 5 softwares. One is we need Putty, and the second one WinSCP or FileZilla we have to download. Third one VM player or workstation we have to download, and fourth one Cloudera start. So now we'll install one by one now. Okay, so here first we need Putty. So Putty I will install. So here download, and here we can see you can download Putty here, right? So once you go there, here we have tar file. So whether you can download installer or you can download a tar file also. Okay, so I'm installing a tar file. So tar file successfully are downloaded. So here I have Putty. And next software WinSCP. So WinSCP also we can download. Okay, so here WinSCP download. Okay, so downloads. So here we just go down, and here download WinSCP. Okay, so here it is downloading. Okay, so coming to next one, VM player or workstation. So here VM player, download. Okay, download VM workstation player. So here I'm just downloading latest VM player. So here we have download option. Download now. So this also started downloading. Okay, so this one also downloaded. So now last one, Cloudera Kickstart VM. Okay, so this one I have one uh, download link. Okay, so using that link we have to download. Okay, so this is the uh, download link. Okay, so what we have to do here, directly we have to enter that URL in a Chrome or your browser. Okay, and then click, automatically it will start downloading. Okay, so here it is downloading. Okay, so generally it will take some time for downloading because of 5.4 GB size. Okay, so we have successfully copied all the softwares in one folder. Now we'll install one by one. So first we'll install putty. Okay, now I'm installing putty. Just we have to click next and then install. Yeah, so we have successfully installed putty. Okay, and next we'll see how to install a WinSCP. Okay, so here we have a WinSCP. Just we have to double click yes button. Okay, so successfully installed WinSCP also. Next we'll install VM player. Okay, so we have to click next buttons. Click next button and then install. So VM workstation installation also successfully completed. Okay, now Cloudera. Okay, so this one already zip file, so just we have to unzip. Okay, we have to unzip, so extract all. Yeah, so we have unzipped the Cloudera kickstart VM. Okay, now we'll set up Cloudera kickstart VM. Okay, so here first we have to open VM player. Okay, we installed VM player, right? That we have to open. Okay, so for free for non-commercial. Okay, so time being we'll use a free only and then finish. Okay, so VM player we open. So inside this VM player we have to open that Cloudera Quickstart unzip file. Okay, so here open virtual machine or create new virtual machine. So we have to select open virtual machine. Okay, so go to that particular folder. So here this is the unzip file. So go inside this and again inside this and select this one. Okay, so but here for Quickstart VM we have to this for Cloudera Quickstart VM we have to give minimum 6 GB RAM. Okay, even some laptops if you give 6 GB RAM it will be very slow. Generally 8 GB we have to give. So here I will give 8 GB. Okay, go here and just here we can increase 4 to 8 GB. Okay, 4 to 8 GB. And number of processors also, instead of one I'm selecting two processors and then click OK. Okay, now here play virtual machine. We have to click play virtual machine. So who all are doing setup first time, so this will take 2-3 minutes time. So Cloudera Kickstart VM successfully opened. Okay, so basically here inside this VM we have Linux operating system. On top of Linux operating system, all the Hadoop related softwares installed. Okay, so now how to access this VM, how to access this Hadoop cluster from our laptop. Okay, so for that, first we should know this particular mission related IP address. So open in terminal. So here we have to execute a Linux command. Okay, so this is the IP address for this particular VM. Okay, so let me copy that IP address. So I copied that IP address. So here I'm opening a putty in our local laptop. So I'm entering here IP address. So this is the IP address I'm saving. I'm saving as a Cloudera. Okay, so now just I'm opening. So now what I'm doing basically from my Windows machine to Cloudera or Hadoop software I'm connecting. Okay, so I accept. So here username and password we have to give. So username Cloudera and password also Cloudera. Okay, so successfully I connected Cloudera. So from here you can execute your Hadoop commands or all Hadoop related code you can execute here. Okay, so this is about Hadoop software installation. We discuss about Hadoop commands. So in our first module, HDFS module, we have practicals. So we'll discuss about HDFS module commands. So here we have different types of commands, like almost 20 to 25 commands. So regularly we have to use only those commands in a real time. First of all, we should know what is your local path and what is your HDFS path. Okay, so in Cloudera, this is my local path, so Linux path, and this is my HDFS path, so Hadoop distributed file system path. So basically this HDFS path in real time, maybe your project manager or tech lead or a Hadoop admin team, they will provide. Okay, so they will confirm that which path is your HDFS path. Okay, so now here ls, so I have few data files in a local file system. So in this folder I have few data files. So cd data ls. So these are the different types of files. So these are all the files available in a local file system. So these are all available in my Linux operating system. Okay. Now I want to check what all are the data files available in HDFS path. So for that we have to enter a Hadoop command. So Hadoop fs -ls /user /Cloudera, because user Cloudera is my HDFS path. So if I want to see the files, then compulsory I have to enter ls command. So before ls hyphen we have to give, and Hadoop space fs, this is static. So whenever you want to execute any type of Hadoop commands, so compulsory we have to give Hadoop space fs. Okay, if your command starting with the Hadoop means that is a Hadoop command, always it will look inside your HDFS path. If you are not giving a Hadoop fs, if you are giving directly ls means it is Linux command, not a Hadoop command. Okay, so now we know, right, which one is Linux command and which one is a Hadoop command. If it is starts with the Hadoop means Hadoop command. If you're starting directly ls or a cp or something means that is your local file system command, Linux command. Okay, now we'll see what are the files available under user Cloudera. So it will display all the available files and the directories also. So it is showing empty. So that means there is no files under that directory. Okay. So now we'll copy one file. Okay. So how to copy a file from local file system to HDFS file system. Okay. So now I want to copy a file from local file system to HDFS file system. So Hadoop FS hyphen copy from local. So here F and L capital letters. Okay, case sensitive. And then your local file system path. So local file path, and then your destination path. Okay, or else you can like a source path and a destination path. Destination path. So source path always your a local file system path. Destination path your HDFS path. Okay. So now here I'm choosing one data file. So this is my data file employee.txt. So this file I want to copy from local file system to HDFS file system. So Hadoop FS hyphen copy from local. Okay. So I am copying from local to HDFS. So this is the command copy from local. Then your local file system path. So my file is there under home Cloudera, under Cloudera data directory, under data file name employee.txt. Okay, so my file available under home Cloudera data directory. Now HDFS path. So that means destination path. So user Cloudera. So I'm copying file. Okay, so I executed my command. So that means now your entire Hadoop architecture will execute backend. But here for us within 2-3 seconds results are showing, right? So now we have to check under that particular path file is copied or not. So how to check? So Hadoop fs hyphen ls user slash Cloudera. So under this path file copied or not. Okay, so file it is showing, so successfully copied. So whenever we want to check file existed or not, that time we have to use this command hadoop fs -ls, then your hdfs path. Okay, so file it is showing successfully copied. Okay, here I used copy from local, right? So instead of copy from local, even we can use one more command. We have similar command, that is a put command. Okay, so we'll see that later. So before that I want to create one directory inside hdfs file system. Okay, so hadoop fs hyphen mkdir. So whenever you want to create a directory inside HDFS, you have to use mkdir user Cloudera and then directory name. So new directory name we have to give here. Okay, so a new directory name I'm just giving here RR digital. Okay, enter. So successfully created a directory. Now we have to check, right, directory created or not. So Hadoop fs -ls user Cloudera. So under Cloudera it should show RR digital directory. Okay, so here it is showing a new directory. That means we have successfully created a new directory. Now I want to copy a file from local file system to under this RR digital directory. So RR digital in HDFS, right? So now what I will do, instead of copy from local, I will use a put command. Okay, to copy a file from local to HDFS, you can use a copy from local, or else you can use a put command also. Okay, so HDFS path RR digital. Okay, under this it will copy your data file. Okay, now we'll cross verify it is successfully copied or not. Okay, here it is showing so successfully copied. Okay, now I want to see what is there inside employee.txt file. So I want to see the content. So how to see the content? Okay, so for that we have to use cat command. Okay, instead of ls we have to use here cat command. Okay, so this is the data available inside that particular employee.txt file. Okay, now how to copy a file from one location to another location. So before that I want to remove this particular file. So how to remove a file from HDFS directory. Okay, so here we have to give -rm space -r so that it will remove your employee.txt file. Okay, successfully deleted, but we have to cross verify, right? Under the directory that particular file is there or not, we have to cross verify. Now how to copy a file from HDFS to HDFS? Okay, so maybe I have data file in one directory, same data file I want to copy to different directory. Okay, so how to copy? So here I have data file, so we have to use cp command, then data file available here, user cloudera employee.txt, same data file I want to copy under RR digital. Okay, so whenever you want to copy a file from one directory to another directory in HDFS, compulsory we have to use a cp command. Okay, now we'll cross verify under RR digital file is available or not. So it is showing file, that means successfully copied. Now I will remove again this file. Okay, I will remove. How to move a file from one location to another location? See, earlier we done copy. Copy means it will keep current directories one copy and a new directory another copy, same similar copy. But move means it will cut and it will paste in a new directory. Okay, so here instead of cp we have to use mv command. So now we will cross verify. First under user cloudera employee.txt it is removed or not, that will check first. Okay, it is removed from this directory or not. So only one directory is there, there is no file under this directory, that means it is that particular file is removed here, and under new directory that file copied or not. Okay, so here it is copied, that means under user cloudera it is removed, and under user cloudera or digital directory it is copied, that means cut and paste happens. So whenever we'll use mv command, move command, it will do cut and paste. Okay, so now we'll discuss about the file permissions. Okay, permissions. So how to give full permissions? Here if you see read write and read. Okay, now I want to give full permissions. Okay, so here chmod 777 chmod 777 and then your file name. So we'll cross verify full permissions applied or not. Okay, so full permissions applied. So earlier this is the permissions, but now after applying this is read, write, execute all. Okay, now I want to copy a file from HDFS to local file system. Earlier we discussed local to HDFS, but now HDFS to local file system. Okay, so local, now we are in which directory? In Linux home Cloudera data. Okay, so moving, uh, I'm going back one path back. So now I am under home Cloudera. So there is no employee.txt file. So now we'll try how to copy a file from HDFS to a local file system. Okay, so Hadoop hyphen copy to a local. Here T and L capital letters, and then so HDFS to local means first you have to give HDFS path. Okay, so user Cloudera RR digital under this employee.txt, then a destination your local path. So home Cloudera. We'll cross verify it is copied successfully in local or not. Okay, so here it is showing that means successfully copied. Okay, so similar way we have one more command. Even you can use copy from local, or you can use even get command also. Okay, so both will work to copy from HDFS to a local file system. I want to check server is there in safe mode or not. Okay, so when we discussed about Hadoop architecture, that time I explained about a safe mode, right? So how to check a server is there in which mode? So for that, Hadoop DFS admin hyphen safe mode get. If we give get means it will get the status of the server. Okay, so safe mode is off. Off means you can delete a file or you can copy a file. Okay, so read, write, delete all the operations. So till now we executed all these three operations because server is not in safe mode. Okay, so now for example you can assume Hadoop admin team uh, want to do some maintenance work. Okay, at the time even they can move server forcefully into safe mode. Okay, so enter means it will move to safe mode. See, safe mode is on. Okay, if safe mode is on means it will allow only read operations. It will not allow you to copy any data files. Even now, write operations also not possible. Delete operations also not possible. Only read operations. If server is there in safe mode means only read. You can read the data files, but not possible to store or delete. Okay, now again I want to move it from safe mode to a normal mode. Then you can enter leave command. Now safe mode is off. Safe mode is off means you can use the read command or write command or delete command. Okay, so previously we have seen how to read, how to delete a file from HDFS. Now how to delete a directory from HDFS, that we'll see. Okay, okay, first we'll delete a file, then we'll delete a directory. Okay, so successfully deleted. Now I will remove directory also. So to remove directory we have to use here command rmr. Okay, successfully deleted. If you want you can cross verify Hadoop fs hyphen ls user Cloudera. Okay, under Cloudera are digital available or not available. Okay, so successfully deleted. We'll explain briefly about Hive module. So how Hive module came into market and what all are the companies they are using Hive model, and what is the use of Hive model, and what all are advantages and disadvantages are there in a Hive model. So those topics I will cover in this module. Okay, so basically Hive model uh, initially developed by Facebook company. Okay, so long back when HDFS and MapReduce came into market, that time there is no Hive model. Okay, so MapReduce model only Java people can able to write a code. Okay, but non-Java programmers, there is no component in Big Data Hadoop. Okay, after that Facebook company implemented this Hive model for non-Java programmers. Okay, so in a Hive model completely we have to use only queries. These queries similar to your SQL queries. Also, this Hive model, it will support only structured data. It will support only structured data, not other data. Okay, only structured data. So initially, Hive model came from which company? Means Facebook company. After that, this Facebook company hand over this Hive model to Apache software company. Okay, so now entire Hadoop and Spark from which company? Means Apache software company only. But initially, this particular component implemented by Facebook company. But later, this Facebook company hand over the Hive component to Apache software company. Okay, so what types of data this Hive model support? Okay, so Hive only structured data purpose that they implemented. Okay, because here we have to write queries. So queries means basically it will support only structured data. So Hive doesn't support any semi-structured or unstructured kind of data. Basically, most of the real-time companies they are using this Hive component to process only structured data, but semi-structured and unstructured data they are using other components. Those components we'll discuss in later classes. So topics I'm going to cover introduction to Hive, okay, and manipulating data with the Hive. So how to manipulate the data in a Hive model, also how to retrieve data, how to delete the data, also how to apply partitioning and bucketing concepts in a Hive model. Also, not only partitioning and bucketing, here we have some new features. Those features not available in SQL or RDBMS. So what are the new features available in Hive model? That also I will explain under advanced Hive features concept. So Hive best practices means here practical. So in a Hive model, basically here less theory and more practicals. Okay. So I will cover all the topics in a Hive model. Okay. So in real time, what all are the topics we are going to use? Those topics I will cover in a Hive model. So again, in introduction to Hive, we have few subtopics. What is a Hive and what other advantages is there in a Hive model, and what is a Hive architecture, how it will process your data. Also, how to create tables in a Hive. What types of tables are there in a Hive model? How many types of tables are there? Also, how to load the data into Hive tables. Okay, so generally after creating table, we have to load the data into table, right? Okay, so those concepts also I will cover in a Hive model. Also, how to store data. Also, how to retrieve the results from HDFS, that will cover. Also, how to create different types of schemas or databases. Okay, so when I start practicals, I will give more knowledge about this databases concept. Okay, so first topic, what is a Hive? Okay, so Hive basically it is a open source software only, but they implemented this Hive component on top of HDFS. Okay, so storage capability only HDFS having. Okay, So using Hive model, you can process your data and you can store your data inside HDFS. And again, whenever you want, you can read data from HDFS. That's why they implemented this Hive model on top of Hadoop or HDFS. Okay, Hive full abbreviation, High Performance Integrated Virtual Environment. Okay, so this is the full abbreviation for Hive component. Also, basically this Hive model they implemented for non-Java programmers already we discussed. So basically, whether from SQL background or uh, data warehouse and tools background related people, they can use this Hive model and they can process a data. Okay, because compared to Java model, Hive model is very easy, right? Because everyone, most of the companies, even if you use Java or if you use .NET, any technology, everyone by default they should have knowledge on SQL, because back in most of the companies they are using SQL. That's why 80% people by default they will have knowledge on SQL. Okay, so SQL it is very easy to learn. Okay, so here based on this SQL module they implemented this Hive module. Okay, so basically this they implemented for non-Java programmers to access the data from Hadoop clusters. So Hive supports basically SQL queries, but not all the SQL concepts. Only few concepts it is supporting from SQL, and the remaining concepts they implemented newly in Hive module. Okay, so SQL means basically structured query language, right? Okay, so here Hive we have to call a HQL language. HQL means Hive query language. DBMS generally SQL will call SQL, right? A structured query language. But here Hive we have to call HQL language. H means Hive, Q means query, L means language. So HQL generally it supports all the tables. You can create tables and you can store your structured data inside those tables. On top of that, you can apply your filters or aggregation functions or joins, whatever you want, you can apply. Okay, so all the built-in functions available in HQL also, like SQL. Okay, also here you can implement some HPL scripts. Okay, so inside that scripts you can write a number of queries. Whenever you will execute that particular HPL script, all the queries one by one it will execute, and it will store your data. So based on your queries it will execute. Okay, Hive also includes metadata. Okay, so two concepts here. Okay, one is metadata and the second one is actual data file. Okay, so we are talking about only Hive here. Okay, so don't confuse. For example, now here you can assume I am creating a table. So create table, some table name. Okay, so here I n number of columns. Okay, so I created table. Okay, so when we create a table here, basically column names and each column related data types will specify, right? Okay, those all will call as metadata. So column names and data types. Okay, and the same time a table name also, also which location that particular data stored. Okay, so these all will call metadata. So this metadata, this metadata it will store inside RDBMS. Okay, so whenever Hadoop admin team generally they install Hive software, with the Hive software they install one RDBMS also, like based on their requirement, Oracle or SQL or PostgreSQL, like that, they will install RDBMS. Okay, so metadata information it will store inside RDBMS. Okay, but after creating table, you have to load the data into table, right? So while loading the data, okay, so now you can assume you loaded your data into empty table. Okay, you have one data file. That data file name may be employee.txt. Okay, that particular data, actual data file, it will go and it will sit inside a HDFS. So whenever you are creating table, that table related information, schema related information, it will store inside metadata. So metadata means RDBMS, and your data, actual data, it will store inside HDFS. It was trying to retrieve the data. Okay, select a star from maybe AMP. Okay, so first it will go to metadata RDBMS. It will check, okay, this particular employee table existed or not. Inside metadata, if employee table existed, then only it will go to HDFS. From here it will read your data. In case you was trying to read EMP1, then also it will go here. First it will check EMP1 table is there or not. Table not there, right? If table not there, then it will not go to HDFS. Directly it will throw error. A table does not exist. So first point of check for any table in a Hive model, that is metadata. First it will check metadata. If metadata, that particular table or column or schema existed, then only it will go to HDFS for reading or store. Okay, so that is about Hive metastore data, how it will create. Okay, and Hive implementation at Facebook contains tens of thousands of tables. Okay, so generally we know, right, Facebook daily millions of customers, uh, they will post different varieties of data like images or structured data or comments or videos. Okay, so for a day it is generating more than 700 terabytes of data. Facebook is generating for a day more than 700 terabytes of data. So once the data will generate, immediately they will store inside HDFS. On top of that, they will do uh, analytics also, analysis they will do. And what are the advantages are there in a Hive model? If we use a Hive model, what are the benefits are there? Okay, so basically Hive is easy to learn compared to other coding languages, because Hive model implemented based on SQL. Also, HQL queries is much faster than a Java code. Okay, so for example, here if you want to create a table and if you want to store data, only two queries, two lines of code is required here. But same, if you want to implement in Java, you have to write more code, maybe 50 to 100 lines of code is required. So there more time will be waste, and again you have to compile that code, again you have to add all the required dependency jar files. Okay, so that's why nowadays instead of using Java in a big data Hadoop, they are using a Hive component to process structured data. Okay, also manipulation of the data also very easy in a Hive model. Okay, so but Hive generally is not a relational database, and Hive is not designed for online transaction processing, but our DBM is designed for online transaction processing. Okay, but Hive is not designed for online transaction processing, but you can store offline data. Okay, also we have few features in Hive model. It stores your data inside a database, specific database. So whenever you want to store your data, compulsory you have to create a specific schema or database. Also, Hive is designed for OLAP, and generally Hive will call a HQL or Hive query language. Okay, and compared to other languages, it is very fast and scalable and extensible. Okay, scalable and extensible means you can use built-in functions. Okay, with the Hive software, built-in functions will come. Like if you want to convert into uppercase, built-in function is there, you can convert. Okay, but in case if you want to implement your own functionality in a Hive, okay, using Java or other language, you can implement your own functionality. After that, you make a jar file. That jar file you can integrate inside a Hive model, then it will work. That is called extensible. And the Hive metastore, this we discussed, right? Where metadata it will store and where actual data it will store. Okay, so actual data it will resides inside HDFS path, and the metadata it will store in RDBMS. Okay, so what is metadata means? Your table names, column names, and data types. Also, actual data storage path or data store path. Okay, also schema names. Okay, database names or schema names also it will store inside metadata. So now we'll discuss about the Hive architecture. So Hive queries we can execute in different prompts. One, you can execute from PuTTY. PuTTY means command line interface. Okay, so if we execute from command line interface PuTTY, backend built-in drivers available. Okay, these drivers it will come with your Hive software. So those drivers it will compile first your query. Okay, so if there is no errors, then it will optimize and then it will start executing. So while executing, backend it will connect to your HDFS model for storing or retrieval purpose. Okay, so here driver whatever are available, these all are built in now. Okay, so we no need to worry about. Okay, but that query while compiling, uh, if any errors are there, then it will throw error in PuTTY itself. Okay, so if you use PuTTY or if you use front end, here we have one web user interface also, that is called a HUE module, that we'll discuss in later sessions. So using a front end also you can execute your Hive queries, not only back end PuTTY, even front end also you can execute same Hive queries. Okay, if you use front end also, first it will connect to drivers, it will compile, after that it will optimize, then it will start executing your queries. Okay, so here on top of this HDFS only, this Hive model they implemented. Okay, now to connect a HDFS server, Hive you can use a Java code also. Using Java code also you can create a tables or you can load the data. So JDBC, ODBC concept is there. Okay, so using a Java you can implement that JDBC code. After that you make a jar file. That jar file, this script server basically it will help that jar file to connect these drivers. Okay, so thrift server, this is basically built-in jar file. Okay, so this built-in jar file, whatever Java jar file you are executing, okay, it is basically mediator between your uh, Java code and this drivers. Okay, this will help you. Okay, so even the Java code also, these drivers will verify, then it will connect to HDFS. And here meta data. So metadata we discuss. See, if we execute from backend or if we execute from front end or if we use Java code, okay, so anything this metadata is common. Okay, metadata. So your metadata it will store inside RDBMS and your actual data it will store inside HDFS module. So here SQL queries, okay, so few commands are there and a few commands basically Hive is supporting and a few commands Hive doesn't support. So we have different uh, commands in SQL, right? DDL, DML, DCL, DRL, and TCL. Okay, so here Hive supports DDL, your DDL commands. It will support under DCL, DRL, DML views. Also indexes from SQL it is supporting also joins partitioning concepts and aggregate many functionalities your Hive module supporting. Okay, but a few functionalities Hive not supporting. So TCL, okay, TCL means commit, rollback, and save point concepts are not supporting. Okay, because here auto commit in a Hive everything auto commit, but in SQL manually we have to click a commit button, right? So here everything auto commit. Okay, so TCL commands not supporting, triggers also not supporting Hive. Also, stored procedures also not supporting. There is no primary key, foreign key, keywords or concepts in a Hive model. It is not supporting. Okay, so only a few topics it is supporting from SQL, and a few topics it is not supporting. Hive it is supporting different types of data types. So tiny int 1 byte it is supporting, small int 2 bytes, and a integer 4 bytes, big int 8 bytes, also float single precision, and varchar also there it is supporting, double boolean timestamp. Okay, so these are the different data types already uh, SQL also supporting. Okay, here if you see varchar and string. Okay, so string basically it came from Java. If you specify string means it will support anything. Okay, even if it is numbers or characters, even varchar also same. Okay, so you can define varchar or string, that is up to you. Okay, but both it will support any type of data. Okay, but thing is most of the real-time projects instead of varchar they are using a string data type. Okay, this is about uh, data types. Okay, so first we'll see how to log in into Hive mode. So if we want to execute any queries in a Hive, so compulsory we have to log in into Hive mode. So in Cloudera VM, to log in into Hive mode, here we have to give Hive a semicolon. Hadoop admin team they will give one more secure line command. Okay, so in real time in our virtual machine in a Cloudera quick start VM, we have to give Hive semicolon so that it will enter into Hive mode. So now I'm inside the Hive mode. So here you can execute your Hive related queries. Okay. So now I want to check what all are the databases or schemas available in Hive. Okay. So here show databases. This is the command. It will list all the available databases or schema names. Okay. So as of now, it is showing only one schema name, that is a default. Okay, so whenever you want to see list of databases, compulsory you have to use the command show space databases. Now I want to create my uh, own database. So how to create a new database or schema? So here create database, then database name. Okay, so here database name I'm giving RR digital. Okay, so successfully created a database, right? Whether database created or not. So again we have to execute a show database. See here it is showing a RR digital database. Okay, so now how to select a database? So here we have a total two databases. Okay, but I want to create tables. Those tables has to create inside a specific database, inside a specific database. So at the time you have to choose your database, under which database you want to create tables. Okay, so how to choose database? So here use, then database name. Okay, so I have selected a database name default. So now onwards in this session, whatever tables I will create all those tables it will store inside this default database. Okay, so now I have selected database, but I want to see list of tables. What are the tables available under default database? So how to list out existing tables? So here show tables. So this is the command. Okay, so right now there is no tables. Okay, so we have to create our own tables. Okay, so even single table also not existed. So now we'll discuss about how to create a tables. But before going to tables creation, first we'll see how to remove database. So creation we know how to create, but how to remove a database. Okay, so here drop database, then database name. Okay, so this is the command. It will help you to remove the database. So successfully removed. Now again I will cross verify. Show databases. So successfully removed. Now it is not showing right RR digital. Okay. So drop database and database name. It will help you to remove the databases. I want to create a again database. Okay. So we can use same create database name. Okay. So show databases. Okay, so now it is showing RR digital how to create tables. Okay, in a Hive we have two types of table creation. Okay, one is internal table, second one is external table. Okay, so how to create internal table and how to create a external table. Again in internal table we have two concepts. Okay, with location how to create and without a location how to create a internal table. So even external table also.
How to create with location and how to create without location.
So first we'll see how to create an internal table. So if you want to create a table, first you need a data file, right? Okay, so let me open one more window here, duplicate session. Okay, so here username Cloudera, password Cloudera. Okay, ls cd data. I have few sample data files. ls. So here I have one data file cat employee.txt. Now for this data file I have to create a table. So this looks like employee number, employee name, phone number, salary, and maybe a department uh, number. Okay, so how many columns required? Total 5 columns required. While creating table, total 5 columns we have to define. Okay, so now in a Hive mode, create table, table name employee. Before this, let me choose schema. Now I am creating create table employee. How many columns required? Total 5 columns, right?
So employee number, data type int, and employee name, data type string data type.
Phone number. So phone number we can give int or begint. Okay, int or begint we can give, and then next column salary int I am giving, and the next department a number, department number hint. So all the column names and the data types I specified are here. Okay, and then row format delimited fields terminated by. So in data file your data separated by which symbol? So here if you see your data separated by pipe symbol. Okay, if your data separated by pipe you have to specify pipe. If your data separated by comma you have to specify comma. So while creating a table, you have to specify delimiter. Okay, so what is the meaning of this row format delimited fields terminated by means? Row means in our data file, data row wise, data is there in row wise format. Delimited fields terminated by means each column here, between each column it is separated by which symbol. So that symbol we have to specify here. Okay, so now successfully created a table. Okay, so how to check a table created or not? Show tables. So here it is showing a table. Okay, so select star from employee. So no data because we just created table but the data not yet loaded. Okay, so we have to load the data. Okay, so now we are discussing about without location concept. Okay, here without location concept we are discussing how to create internal table and without location. Okay, now how to load a data file. Okay, so your data file where it is located, your Linux operating system local file system, under this path it is located. Okay, home Cloudera data. Okay, so now how to load a data file into this a table. So here load. So now we are trying to load data file from local file system to Hive table. Okay, load data local in path. So local file system path where the data file existed, home Cloudera under data employee.txt file. So this is the file we are loading into table. So this data file you want to load into which table? That table name we have to give employee table. Okay, so successfully loaded data. So now we'll see data loaded or not. Select star from employee. See data loaded. Okay, so on top of this data now you can apply anything. Okay, even you can apply aggregation functions or whatever you want. Okay, data loaded successfully. Even you can apply where conditions like select from employee where salary greater than maybe 5,000. Okay, so here if you see data it is populated only more than 5,000 related. So once you load your data file into a table, you can apply any operations. Even you can apply joins or you can apply aggregation functions, whatever you want you can apply. Okay, so this is about your internal table without location. So now we know how to create a table, the data from local file system to Hive or HDFS. We know now, right? We'll see how to describe a table. So first we'll check what other tables available in database. So for that we have to give show tables command in a Hive. So here it is showing only one table, that is employee table. Now I want to see what other columns and data types are defined for this particular table. So for that we have to use a describe command. So describe then table name. Okay, so these all are the commands available for employee table. So columns and data types it is showing. Okay, and here similarly we have one more query, describe extended. Okay, so here describe extended means it will give full information. Okay, full means that particular table name and that table is related to which database and who is the owner for that particular table and what time exactly that particular table is created. Okay, and exactly under which directory that particular table is created. Okay, so what is the difference between describe and describe extended? So describe means
it will just give you only column names and the data types, but describe extended means it will give full details. Okay, so full details means that particular table related columns and the data types, along with that who is the owner for the table, and what is the table name, and exactly which date or what time exactly that particular table is created, under which directory that particular table is created, and is it a external table or it is internal table. So whenever you want a full information, that time you have to use describe a extended command, or else you can use only describe command. So describe command, it will just give you only column names and data types. So this is about describe and describe extended. Now, how to rename a table in Hive? So I want to rename a table. Okay, so here I have the employee table. Okay, so this table I want to rename to EMP table. So how to rename a table? So alter table name employee, rename to, and here we have to give new table name. So new table name, here I am giving EMP is my new table name. Okay, so successfully renamed. How to check whether the table is renamed or not? So again we have to use here show tables command. See, old table name is employee, but now it is showing table name as EMP. So whenever you want to rename a table, we have to use this command, alter table name, and rename to your new table name. Not only table rename, automatically data also it will come. So here select star from EMP. So whatever data available in employee, same data it will show for EMP also. Okay, so this is about how to rename a table. Now I want to add one new column to the existing table. Okay, so right now here if you see describe employee means how many columns are there, describe okay, not employee, right? We have EMP table now. Okay, so only 4 columns and 4 data types. Okay, but here I want to add one more new column, that is maybe you can assume a department number new column I want to add to existing Hive table. So alter table name EMP table, add columns. Okay, so here a new column name and then new column related a data type we have to specify here. Okay, so successfully added new column to existing table. Now we'll cross verify whether a new column added to EMP table or not. Okay, so successfully added. Now earlier it is just 4 columns and 4 data types, but now it is showing 5 columns and 5 data types. So whenever you want to add any new columns to existing table, compulsory we have to use add columns command. Now we'll see how to connect RDBMS. Okay, so generally earlier we discussed that metadata it will store in RDBMS and actual data it will store in HDFS, right? So now how to connect to RDBMS? Okay, so here to connect RDBMS, MySQL hyphen u root hyphen p. This is the command to connect RDBMS, and it is asking a password. Password Cloudera we have to give. Okay, so successfully connected MySQL database. So here I want to see what all are databases available. So databases, So here there are multiple databases available in this, but under which database exactly metadata will store means under metastore database our tables related metadata it will store. So use metastore. Okay, so now we'll see EMP table related metadata available under this database or not. Okay, so here select from tbls. So this is the command basically to check your table related metadata. So whenever you want to check metadata available or not, at the time you have to use this command. Okay, so here it is showing your table related metadata. So here this is your table name, and here it is telling it is internal table or external table. Internal and managed means both are same only. Managed table means internal table only. Okay, in real time generally to connect RDBMS and to check metadata, Hadoop admin team generally they will not give you access. Okay, but here Hadoop software we installed in our personal laptop. So just knowledge purpose I'm explaining how to connect RDBMS and how to check a metadata. So again if you create one more table, so under this whenever you will execute this query, by default one more table related metadata also it will show here. So this is about metadata, how to check metadata. We'll discuss about external table. So external table we have with location and without location, two concepts. So first we'll create one external table. After that we'll load data into external table. So we'll see both the concepts with location and without location. Okay. So how to create a external table. Okay. So before creating external table, you need a data file. Okay. So duplicate session, Cloudera, cd data. Here I have some data files. Okay. So whenever you want to create a table, first you should know which is data file and what are the columns available in the data file. So cat employee.txt. Okay. So here this is the data file. So total 5 columns: employee number, employee name, phone number, salary, department, a number. Okay, so create external table, table name, employee one I'm giving. So internal table we have not specified external keyword. Okay, so how will recognize it is internal or external table means if you give external keyword means that is external table. But if there is no external keyword means that is called internal table. By default it will consider an internal table. So here I am specifying column names and data types. So phone number, data type big int, salary int, department number int. Okay, so row format delimited, fields terminated by. So your data separated by which symbol? Okay, so here our each column related data separated by pipe symbol. Okay, so here we have to give pipe. Okay, so now we are creating table for without location concept. Okay, so table created successfully. So we can cross verify table created or not. Show tables. So here successfully created your employee one table. Okay, even you can verify metadata also here for employee one metadata created or not. Okay, so here it is showing. So employee one also metadata created. Okay, now we have to load the data, right? So we just created a table, but we have not loaded any data. So it is giving empty results. Okay. So now we'll load the data. Okay. So load data local in path. Okay. So my data file available in Linux operating system in local. Okay. So pwd. So under this folder, under this path, employee.txt file available. Okay. So here I'm specifying data file path. Okay. Into table. So this data file I want to load into which table? Employee 1 table. Okay, so successfully loaded data into employee 1 table. So now we'll check whether data loaded or not. So successfully loaded and data populating. Okay, so using your select query you can check data. Okay, or else backend also using your Hadoop command also you can cross verify whether data loaded or not. Okay, so this is about external table with location, without location. Sorry, external table without a location. But here while loading data, load data local in path I used, right? In path. Then here file path I specified, right? File path. So why this local keyword we have to give? And even without giving a local keyword also we can load data. Okay, so like this, load data in path, then your file path. Okay, so what is the difference between this query and this query? Okay, so if you specify local keyword means you are loading your data file or your data from local path. That means your Linux operating system. Your data file located in a local path. That means you have to give your a local path. Okay. If you not specify local keyword here, that means you are loading your data from a HDFS path. So your data file already there in HDFS. That data file you are loading into just a Hive table. Okay, so here you have to give your HDFS path, HDFS file directory. Okay, so user Cloudera, then maybe a data file. Okay, so if you give local means you have to load data from your local path. You have to give local path directory. If you not specify local keyword means you are loading your data from HDFS to Hive table. So here you have to give only HDFS path. So this is the difference between local and without local. Okay, so if local is there means you are loading data file from local. If you're not specifying local keyword means you are loading data from HDFS to Hive table. Okay, and now we'll discuss about with location. Okay, without location we created one external table, right? Now with location how to create. Okay, so before that I will just copy one data file to HDFS location. Okay, so Hadoop, let me create the first one directly inside HDFS. Okay, Hadoop FS -mkdir user Cloudera employee. Okay, I'm creating one directory. Employee 2 directory I'm giving. So employee 2 directory created. Now I will copy one file from local to HDFS under employee 2. Okay, so here copy means a put command we have to use and your local path. Okay, so source path home Cloudera data under data employee.txt file. So this file we are copying under employee2 directory in HDFS. So local to HDFS we are copying data file. So we'll just cross verify under employee2 data file available or not. So data file available. Now we'll create external table with location. Okay, so here Hive. Okay, so while creating a table, I'm giving a location also, file location also. Okay, file location user Cloudera employee1 directory. Okay, so here only till directory we have to give. No need to give file name. Under this directory, even if 10 files or 20 files also, all the data it will load into this particular table. Okay, so here I'm giving employee2. See, it will create a table, same time it will load data also in this table. See, earlier we discussed without a location concept. Without location, two queries. One is create table statement separate, another one loading data query is separate. Okay, but with location concept, single query itself we are loading a data file also. Okay, so this query it will create your table, same time it will load the data also. So here create external table name employee2. Okay, and then row format delimited fields terminated by and location HDFS path. I'm not giving here file name. Okay, so under this employee2 directory, whatever files available, even if it is 10 files or 20 files, all the files related data it will load into employee2 table. Okay, so select star from employee2. Okay, so successfully loaded all the data files. So this is about the external table with location and without a location concept. How to insert data from one table to another table. Okay, so here first we'll verify what other tables available. Okay, here I have multiple tables, employee1, employee5, like that. Okay, so here employee5 table I have some data. Okay, so employee5, right? So employee5 data I have 47 records. Okay, but inside employee table there is no data. So now how to insert the data from employee5 to employee table? So whatever data available in employee5 table, same data I want to insert into a employee table. Okay, so for that, how to write a query? So here insert into table. So data you want to insert into which table? Employee table. Okay, and then from which table? Okay, so select star from employee 5. So whatever data available in employee 5, same data I'm inserting into employee table. Okay, so backend here MapReduce jobs are running. So successfully executed. Now we'll cross verify employee table it is showing data or not. Okay, so successfully I inserted data from one table to another table. So like this we have to insert data from one table to another table. Now next concept, how to execute Hadoop commands in a Hive prompt. Okay, so generally in a Hive prompt or Hive mode, will execute only Hive queries, right? But to execute Hadoop commands generally in separate window, here we are executing Hadoop commands. But I want to execute Hadoop commands also inside Hive prompt or Hive mode only. Okay. So for example, I want to list out what all are files or folders available under HDFS path. So generally for that we'll write a query like Hadoop fs-ls, then a user Cloudera. Okay. So whenever you want to execute your Hadoop commands in a Hive mode, in front of the any command we have to give the symbol, then only it will work. So successfully executed your Hadoop command inside a Hive mode. So these all are the files and folders available in HDFS path. Okay, so same way, even you can execute your other commands also, like for example cat command. Okay, employee.txt. Okay, so here instead of ls you can give cat, and then here same this symbol we have to specify. So now I want to execute a Hive queries without a Hive prompt. So how to execute? So here I have not logged in a Hive mode in this window. Okay, but here I want to execute Hive queries. So how to execute? So here, for example, I want to execute a select a star from employee table. So this table is there in which database? Okay, so that database we have to choose. Use RR digital. This is the database. Okay, and here Hive -e means execute. Okay, and entire query we have to specify inside double quotes. So we are telling you can execute this in a Hive. -e means execute. So before executing query, you choose RR digital database. From RR digital database, this particular table related data you can retrieve. So total 47 rows. Okay, so successfully executed Hive queries in local file system without entering in Hive mode. We have executed Hive queries using this command. Okay, so we know how to execute Hadoop commands in Hive mode. Same time we know how to execute Hive queries in a local file system. Now how to import specific Hive table data from Hive to local file system. Local file system or HDFS file system. Okay, so I have one table. Okay, the table contains some data, but I want to import the data to local file system, or I want to import into HDFS path. So how to import a specific table related data? Okay, so for that we have to write a query. So here I want to import employee table related data into local file system. First I will import into local file system. So here insert, overwrite local path. So in local, where you want to import this data? Okay, under home, Cloudera, new one. So new one directory it will create. Under new one directory it will import your employee table related data. Okay, and while importing data, each column should be separated by which symbol that we have to specify. So row format delimited fields terminated by symbol, type symbol. Okay, so this particular Hive table related data I am importing into local file system under this directory. Okay, so insert overwrite local directory and then a local directory path, row format delimited fields terminated by, and then a select star from table name. So now we'll cross verify data imported into local file system or not. Okay, so here pwd ls, so here new one directory created, so cd new one and then ls. Here we have data, so data imported successfully. Okay, so 47 records. So whatever data available in Hive table, same data successfully imported into local file system. So same way, how to import a specific table related data to HDFS path. So here HDFS means local keyword not required, and here we have to give HDFS path. This is my HDFS path. Okay, new one directory it will create. So now we are importing data from Hive table to HDFS path or HDFS. Okay, so successfully we imported data. Control L. So we have to cross verify, right, the data imported or not. So Hadoop FS-ls user Cloudera under new one directory data imported or not will check. So here it is showing. So using cat command we can check, right? Okay, so successfully imported data. Okay, so next concept, manipulating data with Hive. So like how to manipulate data or how to retrieve the data from specific table. Okay, so here again we have few topics. Okay, so mainly how to apply joins on different tables, and how to apply select statement or select query. Also here we have a few functions like aggregate functions and string functions and subqueries. Okay, so these are the different concepts in next sessions we have. Also DML commands like insert, update, delete. So update, delete, Hive is supporting or not. If it is supporting, from which version onwards it is supporting. So those concepts will cover in the next few sessions. Also, we have few important topics in Hive. One is partitioning, and then bucketing, and then sampling, then complex data types. Also, we have a few user-defined functions. So these are all the topics I will cover in the next few slides. So now, how to retrieve data from table that we already seen. Also, we know how to apply where class or how to apply a limit, like if you want to restrict rows, how to restrict. Okay, those all we already seen. So here a basic syntax I given here for where condition and for order by, also limit also. Okay, so here if you want to apply where condition, so select star from employee where salary greater than amount. Okay, so we can apply same way like here 45,000 means only 3 records. Even if you want to apply order by ascending also you can apply. So limit, here we can apply limit. So limit 1 means only one record it is showing. Basically more than 45,000 salary related we have 3 employees. Okay, but here I restricted to only one record, so that's why it is showing 1. Okay, and here we have sort by and order by concept. What is the difference between order by and sort by? Okay, so order by basically it will give ascending or descending, like if 10 records are there. Okay, select all from employee, order by salary, ascending. Okay, so all the records salary ascending order, like first lowest salary related employee details, then highest. So ascending means low to highest, right? See here, first lowest salary it is showing, then highest salary. Okay, so same way descending also we can specify descending order. So descending order basically in a Hive, first highest salaries, then lowest salaries it will populate. Okay, so descending order, first highest, then lowest. Okay, so that is about ascending and descending. And here we have sort by and order by. Okay, so both are same only, but the difference is order by, here sort by. Okay, so order by always it will give correct result. In real time 90% people they will use order by only, because it will always it will give correct results. Okay, but the sort by, if you have only one mapper, one mapper means your data is there in, entire data is there in only one mapper means, then it will give correct results. But if your data is there in multiple mappers, then it will give wrong results. Okay, so because sort by it will apply sorting on each individual mappers related data, but order by it will apply on all the mappers related data. That's why order by always it will give correct result, but sort by whenever multiple mappers are there, inside those multiple mappers different data is there means it will give partial results. That's why always we have to use order by. So in a Hive we have different types of joins. So one is a inner join. Okay, second one left outer join, third one right outer join, fourth one full outer join, fifth one cross join. Okay, so inner join. So basically if you want to apply any joins, okay, so here joins. Okay, so if you want to apply joins, so first we need 2 tables. Okay, so joins always we have to apply on multiple tables. Okay, so here first we'll create one table, that is employee table, and the second table will create a department table. Okay, so if you want to apply joins on 2 different tables, compulsory one common column should be there in both the tables. Okay, so here you can assume employee table you have department number is the common column, and the department table also you can assume department number is the common column. Okay, so on top of these 2 tables we have to apply joins. Okay, so first one is inner join. So this inner join, okay, so basically in both the tables this particular department number will match, okay, only those records will populate. Okay, for example, here employee table, okay, I have employee number 100 and department number 1 and maybe a name, okay, and again here department table I have a department number, okay, and name. First you can assume department name, then department 1, and then here again department description, okay. So when you apply inner join, okay, this is department number column in employee table, this is department number column in department table. So both the records department number is matching, okay. So wherever both the records department number will match, so only those records it will populate, okay. So that is about inner join, okay. Left outer join, okay. So left outer join means, so here also you have two tables. One is employee table, that is you can assume left side table, and department this department table you can assume right side table. So here left outer join means left side table all the records it will populate, but the opposite side table only matched records. So left outer join means left side table all the records, but opposite side only matched records, okay. Now right outer join, okay. So right outer join also similar to left outer join. So right side table all the records, right side table all the records, but opposite side op opposite side table only matched records, okay. So opposite side, or you can assume left side table, okay, because right side table all the records means left side table only matched records. And fourth one, full outer join. So basically full outer join means from both the tables all the records, even left side table all the records and the right side table also all the records. And next here we have fifth join, that is a cross join. So basically cross join means left side table each record it will map with all the records from right side table. So left side table first row, okay, it will map with all the records from right side table. Again second record, okay, like that. Also here, so for example you can assume this is left side table, okay, and this is right side table, okay. So left side table you can assume I have only three records, okay, maybe record number 1, record number 2, record number 3, only 3 records, okay. And here right side table also I have only 3 records, and here one more record, okay. So cross join basically how it will apply means left side table first record it will map with all the records from right side table, okay. Again same record it will map with other record. So like this each row it will map with all the records from right side table, that is called a cross join, okay. So similar way your second record also, again second record also it will map, okay. So this is called cross join. Even your last record also. So last record also it will map with all the records. So this is called cross join. Okay. So now first we have to create two tables. Okay. So after creating tables, then we'll apply these joins. Okay. So first we'll create a department table. Okay. So if you want to create a department table, you need a data file, right? Okay. So username Cloudera, password Cloudera. Okay. So first we'll check department related data file cd data ls cat dept.txt. Okay. So this data file I have few records. So first column department number and department name and then salary. Okay. So for this data we'll create one Hive table. Okay. So Hive table we have to create with three columns. Okay. So first we have to log in into Hive mode. Okay. So here we have to choose schema or database name. Okay. Okay, database does not exist. Okay, show data bases. Okay, default December, October. Okay, let me create a database. Create database, then database name. Okay, so database created. Use database name. Okay, now I will create a department table. Okay, so create table dgt. First column name dgt number. Data type integer because only numbers. Second department name, so string data type. Next one salary int data type. Okay. So row format delimited. Here fields terminated by. So each column separated by which symbol? Pipe symbol. So that we have to specify within single quotes or double quotes. Okay. So table successfully created. So here we can cross verify show tables. So department table it is showing. Okay. So table created, but there is no data inside department table. So we have to load our data. Okay. We have to load data. So here load data local in path. Okay. So data file is there in a local file system under home Cloudera under data directory dgt.txt. Okay, so this data file I am loading into dgt table. Okay, so successfully loaded. Now select from dgt. Okay, so I have department table now. Department table contains a few records. Okay, so to apply joins we need one more table also. Okay, so we created only department table. Now we have to create employee table also. Okay, so for that also we need the data file. So cat employee.txt. Okay, so here I have data. So for this also I will create a table. So create table name employee. So first column employee number, second column employee name, third column phone number. So phone number big int. Okay, then salary int, last column department number int. So department column also we have common column department number. Employee table also we have common column department number. Okay, row format delimited fields terminated by, okay, type symbol. Okay, so here also each row, each column separated by pipe symbol. Okay, if it is separated by comma, then we have to give comma. Okay, so table created. Now we have to load a data. Okay, so how to load? Here we have to give employee.txt into which table? Employee table, right? This data file I want to load into employee table. Okay, so successfully loaded. Select star from employee. Employee table I have department number. Department table also I have department number. So one common column is there. So now we can apply joins. Okay. First we'll apply inner join. First. So select employee number name from which table? First table, employee table. Okay. So you are applying inner join. Inner join you are applying on which table? Second table, department. Okay. On from employee table based on which column? Department number column. Okay. And then from department table also department number. So wherever department numbers will match from both the tables, only those records it will populate. Okay. So now backend MapReduce jobs are running. Job tracker executing MapReduce jobs to retrieve the data from both the tables. So inner join only matched records, right? Employee table 21 is their department, okay? But department table here there is no 21, there is that is employee table, okay? So except 21 remaining all it should show. So here if you see from both the tables wherever department numbers matched, only those records populated. Okay, but a department table there is no 21 department number, so 21 department number not there in both the tables, that's why not populated. So inner join always wherever department numbers will match, only those records it will populate. Okay, so this is about inner join. Now left outer join. Okay, so here same query after table name left outer join. So employee table left side table, department table right side table. So now if we execute this query, employee table all the records it will populate, but opposite side table only matching records. Okay, so opposite side department, right? So department side matching means except 22 and 21 remaining all it will populate. Okay, because this 22 not there in employee table, department number 22. Okay, okay, I think only except 22 remaining all it will populate. Okay, because 22 not there in a left side table. So here if you see 22 not showing. Okay, 21 it will show because left side table all the records. Okay, so left side table all the records, but the right side table 22 is there, but that 22 not matching with the left side table, that's why not populated. Okay, so this is about left outer join, and then right outer join. So right outer join means, so right outer join right side table all the records, that means now department table all the records 22 also it will populate, but left side table only matched records. So right outer join, so right side table all the records, even department number 22 20 all the records populated. Okay, but left side table, okay, left side table we have department number 21, but 21 not populated because 21 not there in department table. It is there in only employee table. So right outer join means right side table all the records, okay, but opposite side table only matched records, okay. Next, full outer join. Okay, so full outer join means from both the tables all the records. Now 22, 21 department related also it will populate data. 21 department also populated, 22 also populated because full outer join from both the tables all the records. Now cross join. Okay, so cross join here just we have to specify cross. Okay, so for cross join we no need to apply condition. Okay, select star from left side table name, then cross join, then right side table name. See 564 rows. Okay, if you see this 147 record from left side table, okay, it is mapped with all the records from right side table. See, same 147. Again here same 147. This 147 record it is mapped with department number 18 row and again 17. So like that each row it will map with all the records from right side table. So this is about joins, and next concept basic Hive functions. Okay, so basic Hive functions we have different concepts: mathematical, date, string, conditional, and aggregate functions. But in real-time projects, most of the people they are using only string functions and aggregate functions. Okay, so string functions we have again different functions. Okay, so length means, for example, name is there, how many characters are there. Okay, 8 characters or 9, that length it will give. Okay, concat means if you want to concat two different columns. Okay, so first name and last name. Okay, so both it will concat, it will apply merging. Okay, substring means in for example, name is there. If you want only second position to only fifth position related characters. Okay, so specific position related means you have to use a substring. Okay, upper means if you want to convert all the characters into uppercase letters, capital letters, then you can use upper. Lower means lowercase letters, all small letters it will display. Okay, trim means before name or after name any space is there, then it will remove. L-trim means left side space it will remove. Okay, for example, one name is there, so before name left side if any space is there, then it will remove that space. And R-trim means right side space after word. Okay, and replace means instead of one character, if you want to replace with a different character, then you can use replace. Okay, so these are the string functions generally we'll use in real-time projects. And here I given queries also. Okay, so we'll see like how to apply these string functions. Okay, length, concatenation, substring, upper, lower. Okay, all this. Okay, so first we'll try length. So here select ename comma length of ename from employee table. Okay, so I want a employee name related length. See, this is employee name column. So length, how many characters? 5 characters. Here how many characters? 3 characters, like that. Okay, so this is about length. And same way even you can use uppercase. See, uppercase. this is the actual name, but it is converted into uppercase letters. Okay. Same way, even we can apply lower also. Lower. See here, B capital letter first, but it is converted into a lowercase letter. Okay. And then concatenation. Okay. Concatenation means, for example, here one more column is there, phone number. Okay. So concatenation always we have to apply on two columns. Okay. So employee number comma phone number. Okay. So employee name, phone number. So both it is merged, right? Concatenation it is applied. Okay. So substring here, substring also built-in function. Okay. So substring of employee name comma which position to which position related characters you want. Starting position, ending position. Okay. So here you see. So here 1, right? Okay. So 1 means K. And end position 3. Okay. 1, 2, 3. So 3 letters. Okay. So this is about substring. And trim and L trim. Okay. So right now we don't have any space. Okay. Okay, so to apply trim we don't have any space between any words. Okay, last one replace. Okay, reg exp underscore replace. So for replace, this is the built-in function. Okay, so replace, for example, capital K is there. Okay, wherever capital K is there, you can put capital B. Okay. So capital K, so here capital K is there, it is replaced with capital B. Okay, but replace we have to use this built-in function. Okay, so you should not directly use replace, we have to use reg exp underscore replace and then which column related data. Okay, and which character you want to replace, that character and a replace character. Okay, so this is about string functions. And the next aggregate functions. Okay, so aggregate functions means like sum means, for example, 10 employees are there, all the 10 employees related salary you have to apply sum. Okay, and the average salary. Okay, minimum lowest salary, which employee is getting lowest salary, max, which employee is getting highest salary. Okay, so these aggregate functions also we'll see now. Select sum of salary. Okay, so backend again MapReduce jobs are running. Okay, because it has to apply sum, right? First it has to read all the employees related salary, total salary. Okay, so this is the total salary, and you can apply min and max also. Max means only highest highest salary it will populate. Okay, so which employee is taking highest salary. Okay, so 48,094 rupees highest salary. Same way, minimum salary, lowest maybe 5,000 or something it will populate. Okay, so lowest salary. And the average means, so all the employees salary, first it will apply sum. Okay, so total salary by number of persons. Okay, so for example, if 1 lakh, okay, 1 lakh by 10 employees means by 10, so that average salary. Okay, so this is average. We'll discuss about these topics. Okay, first one is cluster by and distribute by. Okay, so basically cluster by and distribute by both are similar to order by and sort by. Okay, so here which one will give correct results means always cluster by will give correct results. Okay, and distribute by sometimes it will give wrong results. Okay, and group by, so how to apply uh, group by in Hive tables. Okay, on top of Hive tables, how to use a group by concept. Okay, and next topic that is how to create tables based on existing table. Okay, for example, you have a table, so that table contains 10 columns and data. Okay, maybe you want to create a duplicate table or backup table. Okay, so that time how to create a new table based on existing table. So next we have subqueries concept in Hive. So Hive is supporting subqueries also, that I will explain how to apply subqueries, how to create views and what is the purpose of views. Okay, and after creating again how to drop views. Okay, and what is the difference between a view and a table? Okay, so generally in interviews they will ask these kind of questions. Okay, difference between view and a table. Okay, also here we have union all and a union. So both these concepts Hive is supporting or not, that we'll discuss in this session. Also we have some advanced concepts in Hive, that is partitioning and bucketing concepts. Okay, so most of the real-time projects generally by default they will use this partitioning concept. Okay, so partitioning also we have two types of partitions. One is a static partition and the second one is a dynamic partition. Okay, and which scenario we have to use a static partition and which scenario we have to use dynamic partition, and what is the difference between partitioning and bucketing. Okay, so when we have to choose a bucketing concept and when we have to choose a partitioning concept. Okay, cluster by and distribute by. Okay, first we'll discuss about distribute by. Okay, so distribute by, if you see I have one table here. Okay, so table name T1. Okay, so my table contains this data. Okay, so cat, fish, dog, cat, dog, bird. Okay, so now when I apply distribute by, okay, so generally to apply distribute by, it is similar to your order by and sort by. Okay, so select star from table name T1 and distribute by on a specific column. Okay, so here this table related data, here are two reducers involved. Okay, so half of the data it went to first reducer and the remaining half of the data it went to second reducer. Okay, so when you apply distribute by, so obviously distribute by here it will not give correct sorting results. Okay, because here two reducers involved. On top of two reducers, generally it should apply sorting logic. Okay, but here it is applying on individual reducers. That's why here if you see final output wrong results. Okay, see first if you see order means sorting order, first it should come B, right? So bird it should come, after B C, then D, then F. Okay, so distribute by, whenever multiple reducers will involve backend, that time it will give false results. Okay, but if a single reducer involved means it will give correct results. Okay, so here we have cluster by also. Cluster by always it will give correct results. Okay, because here also if you see I have T1 table, two reducers involved. Okay, so final results cluster by always it will apply on top of all the reducers. Okay, so on top of all the reducers data means, see here which one bird. Okay, so here always final results it is showing in sorting order. So bird, cat cat, dog dog, finish. That means cluster by always it will apply on top of all the reducers related data. It will not apply individual reducers. Okay, so if you compare distribute by and cluster by, which one will give correct results means cluster by will give correct results always. Okay, so distribute by it will give wrong results. So order by and sort by, if you compare which one will give correct results means order by will give always a correct results. So sort by it will give false results. Okay, so this is about cluster by and distribute by. Okay, so next we'll see how to apply a grouping. Okay, so till now we have not used any group by keyword. Okay, so for example, I have one table, employee table. Okay, so my employee table department number column is there. Okay, so each department few employees are there, like department 10 maybe 5 members, department 20 5 members. Okay, so I want to know each department how many employees are there. Okay, so whenever you want to apply these kind of conditions, then you have to use group by. So group by column name, group by department number means it will apply group on department number column. Okay, so for that we have to write one query here. So here I'm in a Hive mode. Okay, so here select star from maybe employee table. Okay, so employee table I have department number column. Okay, so if I apply group by department means department 21 how many records it should give 4 records. 4 members are there with department 21. Okay, so 20 also 4 members, like that each department it has to give results. Okay, so now select department number. Okay, count of star from which table, employee table. Okay, so group by you are applying on based on which column, department number column. Okay, so each department wise how many employees are there, that count it will give. Okay, so backend here map reduce jobs are running. So map reduce jobs will fetch your data from data nodes, and based on your condition, your query, it will fetch the results. Okay, so mapper 100% executed, reduced also. So department number 10 it is telling 3 records. Okay, so department number 10 3 records. So even you can cross verify here. Cloudera cd data cat employee.txt. Okay, so department number 10 how many records are there with the department 10. Okay, so here only 3 records. So department number 3 and department number 11 4. So same results it is showing. Okay, so like this we have to apply a group by concept whenever it is required. Okay, so next concept how to create a table based on existing table. Okay, so maybe if you want to take backup one table, okay, with the data columns everything. Okay, so that time you can create a table based on existing table. So here Hive, right? Okay, so create table name I'm just writing a backup table. Okay, So based on which table you want to create new table, based on employee table, select star from employee table. Okay. Okay. So while creating table, you can create a table based on specific columns also. So here we given select star from. Star means all the columns related data. Okay. But instead of star, if you specify only employee name comma employee number, only those two columns it will create, and those two columns related data only it will import. Okay. So now we have to verify, right, backup table created or not. Okay. So here show tables. So backup table name showing. So that means it is created. Select star from backup. Okay. So based on existing table, we created a backup table. Okay. So here even if you don't want all the columns, okay, if you want only specific columns in a new table, okay, or specific columns related data only required in new table means you can specify only those columns. So employee number, e name only I want in a new table. Okay. So backup underscore new. So now backup underscore new table, it will contains only two columns, employee number and e name. Only those two columns related data it will import from employee table to backup underscore new table. Okay. So now we'll cross verify show tables. So here it is created backup underscore new table. Okay. So select a star from backup underscore new. See, only two columns related data I imported. Okay. So like this we can create new tables based on existing table. Okay. So next concept subqueries. Okay. Next concept subqueries. So subqueries means generally query inside one more query, that is called subquery. Query, main query, inside that query again subquery. Okay. So here if we see select a star from, okay, table name employee, where employee number greater than 130. That means 130 employee number 130 above related records it will fetch. Okay. And here again subquery is there. Select star from employee, order by salary descending. So that means highest salary first it will show, then lowest salary. So first I will write main query, select star from employee, where employee number greater than 130. Okay. So this is main query. Inside this main query we can write a subquery also. Okay. So here we can write, okay, select star from employee, order by salary descending. Okay. Order by salary descending. So basically first it will execute a subquery, then it will execute main query. Okay. So results are retrieved. Okay. So descending order, so highest salary, then lowest salary. And one more condition, employee number greater than 130. So here if you see 130 above related only employees details populated. Okay. So that is called subqueries. Okay. And next, how to create views and how to drop views. Okay. Next concept. Okay. So generally if you want to create views you need a table. Okay. So views it will read the data from table. Okay, only runtime, whenever you will execute a view, immediately it will read the data from table and it will populate. Okay, so while creating view, generally why people will create views means, for example, if you are working for customer care, okay, so for customer care people, generally they want to hide a password, maybe banking login password they want to hide, right? Okay, if table means all the columns related data, by default it will be visible. Okay, so if table contains 10 columns, okay, what they will do, generally on top of table they will create view. So only required columns, with required columns they will create view. Okay, so they will hide password column. Okay, so whenever some security or something they want to hide, only few columns related access if they want to give, then they will create these views. Okay, so views always read only. Okay, so now we'll see practically, we'll create one view. Okay, so if you want to create a view, you need table. So select star from maybe um, employee number comma employee name from employee table. Okay, so for create a view name emp underscore view. Okay, so this view based on this table I'm creating. Okay, from this table only these two columns related. Okay, so a view created. If you want to see data, select star from emp underscore view. Okay, so employee table contains 5 columns. Okay, but we given access to only 2 columns. So these 2 columns related they can able to see. Okay, so views basically in select query you can write anything. You can write a where condition or you can write joins. So whatever results this select query it will fetch. Okay, only that results it will show for this view. Okay, now how to drop a view? So drop view name emp underscore view. Okay, so whenever you want to drop, okay, so here show table, see emp view not showing, successfully dropped. Okay, so this is about views. Okay, now what is the difference between a view and a table? Okay, difference between a view and a table. So basically these kind of questions they will ask in interviews for 2 years or 3 years experience people or freshers. Okay, so view without table view creation not possible. Okay, without table view creation not possible, but without view table creation possible. You can create table without view, but without table view creation not possible. And when view holds the data means only runtime, whenever you are executing view, that time only it holds the data. Once a view execution completed means generally it doesn't hold any data, because data always available in a table only. But when you are executing view, that time backend it will connect with your table, from there it will read data. Okay, and there is no space wastage in views generally, but a table sometimes a space wastage will be there. Okay, so that is about views. Okay, so next concept union and union null. Okay, so in SQL we have union also. Okay, so union it is supporting in SQL, but in a Hive union are not supporting. Okay, so here only union null it is supporting. Okay, so basically union whenever you want to read data from multiple tables, at that time you have to use union null. Okay, so at a time you want to read the data from two tables, then you can use union all. Select star from employee. So this is one table. Then union all. Then your second table. So select a star from. Maybe I'm giving a backup table. Okay. So union all. So when you are writing select query between those two tables, you have to specify union all. Okay. Then from both the tables, all the records it will populate. See 94 records. Okay. So this is your second table data. Okay. So this is 101 to 147 second table. This is your first table data. Okay. So here only union all it is supporting, but union doesn't support in Hive. Okay. So this is about union all. Okay. So next concept of partitioning and bucketing. Okay. So this is a important concept in a Hive, partitioning and bucketing. Okay. So first we'll discuss about partitioning. Okay. So here partitions, we have again two types of partitions. Okay. Static partition and a dynamic partition. First of all, what is the use of partitioning? Okay. For example, when you create a table, backend generally in HDFS, it will create a directory like this, right? So Cloudera and table name. Okay. Under this table, your data file. So from here, basically your select query will read data. So for example, here you are applying some where condition. Okay. Where, okay, month equal to John. Okay. That means this select query has to scan all the records. In that it has to filter out only January month related data. So that means it has to scan all the records. Okay. If data is there in terabytes or petabytes, it will take more time, right, to scan your data. So performance will decrease. Okay. That's why they introduced partitioning concept. Okay. So partitioning generally what it will do. Okay. Under this directory here, again it will create a subpartition. Okay. So January. So January means January month data here. Okay. So again here February. Okay. So here February related data. So like that it will create n number of partitions. Okay. So what is the use means, when you apply where condition, directly it will go to this directory. So no need to scan data blindly, it will fetch your data and it will show here. That means performance will be very fast. Okay. So partitions, basically you can apply day wise also, okay, month wise also you can apply. Okay. And even hourly also you can apply, like first hour, whatever data will come first hour, it will move. Okay. And daily means a date wise partition. Okay. With the 12th date, one partition, whatever data it will come today, under that date it will push your data. And month means each month related. Okay. And again yearly also you can apply partition. So 2021 related entire data under one partition. Okay. So partitions basically you can apply on hourly basis or day wise you can apply, and same time monthly also you can apply, okay, and yearly also you can apply. Okay, now we'll see first static partition, okay, and then we'll see dynamic partition. So difference we'll discuss later. First we'll see practically. Okay, so to apply a static partition, here I have data files. 2011 related data is there, and 2012 related data is there, and 2013 related data is there. Okay, so for this data I will create first static partition. Okay, so for that first we have to create a table, and then we have to load data into table. Okay, okay, so here total 3 columns. Okay, so student name, student number, student passed out year. Okay, student passed out here. So for this data we have to create a table. For this data we have to create a table. Okay, so here create table. Okay, so static underscore partition. Okay, so first column student name string, second column student number. Okay, so partition we are applying on a year column. Okay, so year wise. Okay, so here partition of, so partition you are applying on which column, that column we have to specify here. Okay, so student passed out year. Okay, so data type int. Okay, int. Then here row format delimited fields terminated by. Okay, so here data separated by each column comma. Now partitioned by. Okay, so partitioned by. Okay, so here we have to use so create table name, first column student name, then data type, then student number, data type, then partitioned by. Okay, and then column name. Okay, and then data type. Okay, so if you want to apply, in case if your data contains month, here you have to specify month, column name, and data type. So partition by you are applying on a date means maybe date column name. Okay, like that. So now we have to load the data into table. Okay, so our data is there under this directory. Okay, under local directory. Okay, so here data is there under that directory. So static underscore partition underscore details underscore 2013. Okay, 2013 dot txt. Okay, so into table, which table you want to insert this data? So table name we know, right? Static underscore partition table. So here while inserting we have to specify which year related data we are passing. Your data file contains which year related data. Okay, so here if you see 2013. Okay, 2013 related here partition of. So which year related data you are passing, that year you have to specify. Okay, so here into table S year equal to 2013. Your data file contains 2013 related data. Okay, so here partition keyword also we have to specify semicolon. Okay. So successfully loaded 2013 data. Okay. So now if you see backend, okay, Hadoop FS -ls user Hive warehouse. So backend it is created one partition or two partitions that will check now. Okay, rr digital dot db. Under this your table name should be there. Okay, so table name static underscore partition. So here it is created 2013, it is created partition. Okay, so yes, year equal to 2013. Okay, so we loaded only 13 related data, so that's why only one partition it is created. Under 13 related data available. Okay, now if you load 14 and 15 related data, okay, 11 and 12 data will load. That means 11 and 12 also it will create partitions. Okay, so here Hive, so 11. Okay, so data file name also 11.txt. Okay, so 11 related data loaded now. Again same table, 12 year 12 related data also I am loading. Okay, so 12 related data also loaded. Now if you see backend, how many partitions available means 3 partitions. Okay, so 11, 12, 11, 12, 13. So in a Hive, if you execute your query, okay, select star from static underscore partition where s year equal to 2013. Okay, so now no need to scan entire table related data like 11, 12 partitions related data. So directly it will go to this directory backend. From there it will read your data. So performance it will give very fast. See here very less data, but in real time, so large data. Okay, so no need to scan. It will directly go to the that particular partition. It will fetch your data. So this is about static partition. Okay, so static partition when we have to use means whenever your data file contains a specific date related data, okay, or a specific month related data or specific year related data, then you have to use a static partition. Okay, dynamic partition when your data file contains mixed data. Mixed means maybe all the years data or all the months related data or maybe all the days related data. That time you have to use dynamic partition. Okay, so now we'll discuss about dynamic partition. Okay, so dynamic partition generally we have to follow some steps. Okay, so first we have to create one temp table. Okay, then load data into temp table. Okay, then create a dynamic partition table. Then load data from temp table to dynamic partition table. So these 4 steps we have to follow, but you have your data already there in some table means you can consider that table as a temp table. You no need to create again table and you no need to load data. Okay, So but the backend here, backend, we have to enable dynamic partition. Okay, so by default dynamic partition will be there in a disable mode. Okay, so we have to enable that. Okay, so this command we have to use. Okay, so before creating tables, by default in your command prompt or cluster, dynamic partition, it will be disable mode. Okay, so we have to enable that. Okay, so control C. So here your Hive mode, first you execute that command. Okay, so now we'll create a temp table. First step, temp table. Okay. So I have one data file. So the data file contains all the years related data. Okay, so 2009, 2010, 11. But earlier, each data file a specific year related. That's why we used a static partition. Okay, but now this data file contains multiple years related data. Okay, so first we'll create one temp table. We'll load the data into temp table. Okay, table dynamic underscore temp table name. First column. Okay, first column, student name, string data type, then student number, then student passed out year. Okay, so this is like your normal internal table. Okay, row format, delimited fields terminated by. Okay, comma. Okay, table created. Now we have to load data into temp table. So load data local in path. So data file is there under this directory. Okay, home cloudera data std all dot txt. Okay, into table. Which table you want to insert this data? Dynamic underscore temp table. Okay, so we'll cross verify data loaded or not. Select star from dynamic underscore temp. Okay, so whatever data is there in data file, so entire data loaded. Okay, so now first 2 points we completed. So temp table we created, we loaded data into temp table. Now we have to create a partition table. So here create table dynamic. Okay, and first column student name, student number. Okay, and partitioned by. Okay, so partition we are applying on which column? Year, passed out year column. Okay, and then row format delimited fields terminated by comma. Okay, okay, so partition created as here. Now we have to load data from temp table to dynamic table. Okay, so here temp table select star from dynamic underscore temp table. Okay, so this data we have to load into, so insert into table. Which table? Dynamic table. So you want to insert into dynamic table. While inserting, you have to apply partition based on which column? Year column. Okay, so what it will do, it will read each record. If it is a 2010 means 2000 under 2010 partition, it will load. If it is 11 partition like that. Okay, see here it is created partitions. Okay, 2010 one partition, 11, 13. So 13 related data under 13 partition, 10 related data under 10 partition like that. Okay, so now if you apply select query, select star from employee, where SER equals to 2000, 10 means only 10 related data. Select not employee dynamic table, right? Okay. Select star from dynamic, where SER equal to 11 means only 11 related data. 12 means 12 related. So backend automatically it will create partitions. Okay, static partition, we have to specify which year related data we are loading. But a dynamic partition, you no need to tell, Hive will take care. Based on data, it will create partitions and it will load data. Okay, so this is about static and dynamic partitions. Okay,
We'll discuss about 3 topics.
so first one, bucketing. Second one, table sampling. Okay, third one, complex data types. Okay, data types. Okay, so first we'll discuss about first concept of bucketing. Okay, so why bucketing is required. Okay, so basically bucketing is similar to partitioning. Okay, so in a previous session we discussed about static partition and dynamic partition. Okay, so basically this partitioning and bucketing to improve query performance will use. Okay, so whenever we are trying to retrieve the data, it will give good performance if we use partitioning and bucketing. Okay, but already partitioning is there, so why we have to use again bucketing? Okay, generally most of the organizations, 90% projects, they are using only partitioning concept. Okay, so only 10% projects they are using a bucketing concept. Okay, so why bucketing came into picture means partitioning we have one small drawback. Okay, so what is that drawback means? For example, okay, so when we create a Hive table, okay, so user Hive warehouse, so under this generally it will create a partition, right? Under this maybe table name, under this table partition. Okay, partition means maybe with the 2021 one directory. Okay, so 2021 related data here. Okay, so same like maybe you can assume 100 partitions created. Okay, so 100 partitions means maybe 2020 also one more partition. So under 2020 year, whatever data generated 2020, so that data available. Okay, so here I have 1980 related partition. Okay, so 1980 I have very less number of records. So less number of records means you can assume only maybe 10 or 20 records. So you can assume last 50 years, each year I have more data, maybe GBs and terabytes. Okay, but 1950 to 2000, 1952, maybe 1990, I have each year very less number of records. Okay, so each year maybe 10 records or 20 records. Okay, so if you have less number of records, okay, separate partition not required. Okay, so that means almost 50 years are related, 50 directories it will create, 50 partitions, but each partition you can assume only 10 or 20 records. Okay, so for less number of records, partitions not required. So whenever your data is large data, you are unable to scan. If it is taking more time, then only partitioning is required. Okay, but here whenever less number of records are there, at the time if you use a partition, there is no use. Okay, so I can club these 50 partitions, right? 1950 to 1990. Okay, so due to that small drawback in partitions, bucketing came into picture. Okay, so here basically bucketing, okay, partitioning always that is a Hive control. Okay, your Hive framework will take care of how many number of partitions it has to create based on data. It will be control. But here bucketing always it is a user control. User control means you can decide your data you want to keep in how many buckets. Okay, so maybe you have 1 lakh records. Okay, so here table name. Okay, so bucket 1. Okay, maybe here 50k records it will place. Okay, and the remaining 50k maybe another bucket under same table, only different bucket. Okay, so while defining a table, while defining a bucketing table, you have to specify your data you want to keep in how many buckets, whether 2 buckets or 3 buckets or 4 buckets. Okay, so here for example create table emp. Okay, so generally here we'll write column names, table names. Okay, maybe department number like this, right? After that here clustered by, so bucketing you want to apply based on which column. Okay, so that column name. Okay, so into how many buckets your data you want to put into how many buckets. Okay, 3 buckets. Okay, so that means your entire data it will keep in only 3 buckets. Okay, but partitioning based on your data it will create n number of partitions. Okay, 2020 one partition, 21 one partition, or if it is a device partition means with the today date one partition, tomorrow date one more, or yesterday date. Okay, like that. Okay, create bucketing table we have to follow some steps. Okay, so basically backend bucketing concept will be in disable mode. So we have to enable that bucketing concept. Okay, for that we have to execute one Hive command. Okay, so set Hive dot enforce dot bucketing equals to true. So this is the command you have to execute in a Hive mode, so that backend it will enable a bucketing concept. Like partitions also we executed one command, right? Similarly here also we have to execute this command. Okay, and second you have to create a table, temp table. Okay, and you have to load data into temp table. Okay, already if your data is there in some table, you no need to create step 2 and step 3. Okay, and then fourth step, create a bucketing table, bucketing table. And the fifth one, insert data into bucketing table from temp. Okay, so these are the 5 steps we have to follow while creating bucketing. Okay, so now practically we'll see. Okay, so here I have to choose the database use RR digital show tables. Okay, so here to select a star from employee. Okay, so employee table 47 records. Okay, so this employee table I am considering as temporary table. Okay, so that means no need to create again table. Okay, so second and the third step completed. I have table, inside table already data available. Now I will execute this command. So set hive dot enforce dot bucketing equals to true. Okay, so now bucketing concept enabled backend. Okay, So now step 4, I have to create a bucketing table. Okay, so I know my temp table contains how many columns? 5 columns. Okay, so bucketing table, create table emp underscore bucket, my table name. Okay, so first column, second column, and then third column, and salary department number clustered by. So based on which column? Okay, department number column. So clustered by department number column, and then you want to create how many buckets? Okay, into 3 buckets. Okay, and then row format delimited fields terminated by. Okay, so data separated by, here I am giving a pipe symbol. Okay, so bucketing table created. Okay, show tables. So here emp underscore bucket. Okay, so now fifth step, insert data into bucketing table from temp table. Okay, so here insert into table emp underscore bucket. Okay, so data we have to insert into emp underscore bucket table from which table? Select star from employee table. So whatever data is there in employee table, same data you can insert into bucketing table. While inserting, you can put data into 3 buckets. So here backend MapReduce jobs are running. Okay, so now we'll verify. Okay, so select star from emp underscore bucket. Okay, so whatever data available in temp table, now same data available here. Okay, but we have to check, right, data available in 3 buckets, backend it is created 3 buckets or not. Okay, that we have to verify. Okay, so we'll see how many buckets it is created. Okay, so Hadoop fs-ls user Hive warehouse under warehouse database name. Okay, or digital under that emp underscore bucket. So under db name, table name, emp underscore bucket directory. Okay, so total 3 buckets it is showing, right? Okay, so this is first bucket, this is second bucket, this is third bucket. Okay, so your data available in 3 buckets. Okay, so partitioning means generally date wise or month wise, but here user can decide if you want to put your data into only 2 directories, you can put. If you want to put your data into 3 directories, you can specify into 3 buckets or 5 buckets or 10 buckets, like that. Okay, but here when we execute your table name, all the buckets related data it will populate. But now question is how to retrieve a specific bucket related data. So I have 3 buckets backend, but I want only first bucket related data, or I want a second bucket related data. So how to check that? So for that, here we have one more concept. Okay, that is a table sampling. Okay, so table sampling, we have 2 options. Okay, one based on bucket, you can retrieve your data. Okay, second option, percentage wise also you can retrieve your data. Okay, like maybe you want 20% data from all the buckets, or maybe 70% data from all the buckets. Okay, So practically we'll see this table sampling concept. Okay. So now here MP underscore bucket. So table sample of bucket 1 out of 3. I have total 3 buckets, but I am telling here you can retrieve only first bucket related data. See, first bucket related only 16 rows. We have total 47 records. Okay. So now if you want only second bucket related data, then 2 out of 3. Again 15 records. Previously 16 rows, now 15 rows. And then 3 out of 3. So 16 plus 16, 32. 32 plus 15, 47 records. Okay. So whenever you want to retrieve specific bucket related data means then you have to use this table sample concept. Okay. So number of buckets 3 means 3. If number of buckets 10 means you have to specify 10. So out of 10, which bucket related data you want? If it is a fifth bucket related means fifth. If it is third means third. Okay, but a space compulsory we have to give. Okay. So this is about a table sample. So table sample again here we have percentage wise also we can retrieve, right? So now how to retrieve data based on percentage. Okay. So I have data in 3 buckets. Okay. But from all the buckets, I want to retrieve maybe 10% data. Okay. Or maybe from all the buckets, I want to retrieve 100% data. Okay. Then we can use a percentage wise also. See 47 records. Okay. So here, if you want 10%, if you want 50% data from all the buckets, then you can retrieve percentage wise. Or if you want to specific bucket related means bucket 1 out of 3, bucket 2 out of 3, like that we have to specify. Okay, so this is about table sampling. Now we'll discuss about complex data types. Okay, so in Hive we have different data types, right? Integer, varchar, string, boolean, float. Okay, so along with those data types, here we have complex data types. Okay, so complex data types. So first one is array. Okay, second one is map, and third one is struct. Okay, so we have total 3 complex data types: array, map, struct. Okay, so these 3 data types are important. Okay, same time when we have to use array data type. See, we know when we have to apply string data type. Okay, and we know when we have to apply integer data type, but array data type when we have to use. Okay, so for example here I have 3 columns. Okay, name, employee number, and then subjects. Okay, so subjects means basically this BSc or BTech people, they will choose a stream, right? CSC or ECE. Okay, stream. Okay, so here stream like computers. Okay, and chemistry. Okay, and physics. Okay, so this is collection of data. Okay, column name is a single column, but it contains multiple values. Okay, so whenever in your data file contains a specific column contains a collection of elements, at the time you have to use array data type. Okay, And now coming to map. So map, whenever you have data in a key comma value pair, at the time you have to use a map data type. So key comma value pair means, for example, employee number, e-name. Okay. After that, I have like this salary, maybe salary 2000 rupees. Okay. And then here bonus, okay, 200 rupees. That means this is key, this is value. Again, this is key, this is value. So whenever your data file or specific column contains data key value pair format means then you have to use map data type. Okay. And then a struct data type. Okay. So this struct data type generally whenever address kind of data is there, then people will use a struct data type. Address means here maybe street number, okay, area, then pin code. Okay. So whenever these kind of like here you have to use multiple data types, right? Integer, string, and again int. Okay. Okay. So whenever your data looks like a address kind of, then you have to use a struct data type. Okay. So now practically we'll see how to use all these three data types. Okay. So here I have data files, small data sets, ls, at. So okay, so here I have one small data file. So this is student name, okay, and the student marks, and this is a subjects or stream, okay, and this is a grade. Okay. So now I have to create a table and I have to load data. While creating a table, I have to use array data type for this column. Okay. So now Hive mode. So here I will create table, internal table, create table, table name student underscore array. First column student number. Okay. Second column student marks are passed out here. Okay. And the next column name may be subjects. Right? Subjects are a stream. Okay. So here data type array. Okay. But maths, physics, chemistry, which data type? String data type. Okay. And then grade, ABC grade. Okay. So grade I am giving a string. Okay. So here row format delimited fields terminated by. So between each column data separated by comma. But here maths, physics, chemistry separated by dollar symbol. That means a collection of items. Okay. So collection items terminated by which symbol? Dollar. Okay. So basically this array data type came from Java. Okay. This is there in Java. Okay. So array means a collection of elements or collection of values. Okay. So here collection items terminated by which symbol means a dollar symbol. Okay. And each column separated by which symbol means comma. Okay. So table created. Now I have to load data, right? So load data local in path. So my data is there under this directory. Okay. Home Cloudera data array data file dot txt into table. So this data file you want to load into which table? Student underscore array table. Successfully loaded. Okay. Now select from student underscore array. Okay. So successfully loaded data. But now if you give select star from means all the columns. But in the third column name we know subjects. Okay. I want only first position related data. Okay. So here column name subjects, right? Subjects of 0. Okay, here position starts from 0. See, maths, biology, civics. So maths, biology, civics. And even first column also if you want means here student name. Okay, student name. And if you want again subjects third position related means here instead of 0, 2. Okay, so chemistry, commerce. Okay, so like this you can retrieve your data for array data types. Okay, so this is about array. Now we'll see map. Okay, so for this also we need a data file ls cat map data file. Okay, so here also I have small data file. See, this looks like employee number. Okay, this column, this is employee name, but this looks like payments. Okay, so third column looks like a key value, again key value, key value. That means for this column we have to apply map data type. So here create table emp underscore map table name, employee number, employee name. Okay, so last column name payments. Okay, and which data type? Map data type. So salary, commission, bonus, these three keys, and 5,500 100 values, key value. So keys, all the keys is there in string. Okay, and values int. Okay, in row format delimited fields terminated by your data separated by comma. Okay, so here between each key value what is there has a symbol. Okay, so that is called collection items terminated by which symbol has. Okay, but this key value pair which symbol it is separated? Dollar. For that map is terminated by dollar. Okay, so now table created, we have to load a data file, right? Okay, we have to load a data file. Okay, so table name emp underscore map. Okay, your data file name map data file.txt. Okay, so this data file we are loading into emp underscore map table. Okay, show tables. So emp underscore map table created. Okay, and data loaded or not will cross verify from emp underscore map. Okay, so data loaded, this is key, this is value. Okay, but now how to retrieve a specific key related value. Okay, so third one payments, right? Column name payments of which key related value you want. I want a salary key related value. See, 5,000, 6,000. If you want only bonus related, here bonus. Okay, so like this we have to retrieve the data. Okay, so this is about map. And the next struct data type. Okay, struct data type, data file required ls. Okay, so cat and then struct data file. Okay, okay, so in this data file, for this column we have to apply array, and for this we have to apply map, and for this we have to apply struct data type. So all three complex data types we have to use now. Okay, so here create table, employee, create table name emp underscore struct, employee number, employee name, array. Now first column name, right? Subjects. For subjects, array data type, and massive physics or chemistry characters. So string. Okay, and then payments. For payments, which data type? Map data type. So all the keys characters, and the values, so integers. And then the last one address column, because Bangalore, Karnataka. Okay, so address we have to apply struct. Okay, so first one city, string data type. Second one state, string only. Third one pin code, int. Okay, so now row format, delimited fields terminated by, so each column separated by comma, and the collection items terminated by, so here massive physics chemistry separated by dollar. Okay, so here also between key value pair, each key value pair dollar symbol is there. That means here dollar. Okay, and the map is terminated by hash. Okay, so now I will load data, local in path. So home, Cloudera, data, struct, data file dot txt into table. You want to insert this data into which table? Emp underscore struct. Okay, so data successfully loaded. Now we have to cross verify, right? Select a star from emp underscore struct. Okay, so now we know array related data how to retrieve. We know map related data how to retrieve. Now we'll see how to retrieve only struct related data, struct data type related data. Okay, so here, so for example, I want only state related value. Okay, so here address dot state, see, state name. And if you want to pin code, here pin code. Okay, so this is about complex data types. Okay, so complex data types and bucketing, table sample, these all are important concepts. Okay, discuss about advanced Hive features. Okay, so in advanced Hive features, we have two topics. Okay, so here we have two concepts. One is Hive scripts. Okay, second one is parameters passing. Okay, so here first we'll discuss about Hive scripts. Okay, so why we have to implement Hive scripts and how to execute Hive scripts. Okay, so basically in a real time based on requirement we have to implement a n number of queries. Okay, so till now each concept individual queries we executed. Okay, but in a real time based on a requirement we have to implement a n number of queries. Okay, so like query 1, query 2, query 3, like this. So all these n number of queries we have to put into one script. Okay, so that script it should ends with HQL dot HQL. So script name you can give any name. Okay, like generally in real time we have to give meaningful name. Okay, if it is customer data, customer.hql, if it is employee data, employee.hql, like that. Okay, so Hive script always it should ends with dot HQL. Okay, so here why people are calling HQL. Okay, so basically we have SQL. Okay, so SQL generally will call structured query language. Okay, so similar way here also we are using a queries only. Okay, but where we are using means Hive. Okay, so this basically we have to call Hive query language. Okay, so this is the full abbreviation for HQL. Okay, Hive query language. Okay, and you can call Hive query language or else directly you can call HQL. Okay, so whenever you will implement any kind of script, that script should ends with dot HQL. Okay, so now we'll implement one small Hive script. Okay, so how to implement that? Okay, so now you can assume I have one requirement from a client. Okay, so maybe first the client told me to create one table. Okay, after that we have to load data into table. Okay, after that maybe we have to apply some business logic. Okay, maybe business logic means here I'm just assuming where salary greater than something. Okay, and fourth step I have to save this final data into uh, another table. Maybe you can assume this data we have to store into final table. Okay, so this is a small requirement. Okay, but in real time generally it will be big requirement. Based on requirement we have to implement a number of queries. Okay, so here first we have to create a table, right? Okay, so to create table here we have to write a create statement. Okay, so create a table. Okay, maybe emp. Okay, employee number. Okay, string data type, and then phone number big int, then salary int. Okay, then department number. Okay, so row format delimited, fields terminated by a pipe symbol, data separated by pipe. Okay, so this is your first requirement related query. Okay, And next I have to load the data into table. Which table? This EMP table. Okay, so here load data local in path. See, if your data is there in a HDFS, you can give HDFS path, then local command not required. Okay, but my data is there in a local file system. Okay, so here data file is there under this path. Okay, home Cloudera data, then employee.txt. Okay, into table. Which table you want to load this data? EMP table. Okay, so based on requirement, second query also I implemented. Now I have to apply a business logic. So where condition. Okay, so select star from EMP where salary greater than 40,000. Okay, so third query also I implemented. Okay, now whatever results this table, this query will give, that results I want to store into another final table. Okay, so create table emp underscore final. Okay, yes, this query. Okay, so whatever final data it will retrieve, with that I'm creating one table. So this table, it should be final results. Okay, this table should contain final results. Okay, so all these 4 steps I implemented. Now I'm copying this all the 4 queries, control C. Okay, so here maybe uh, control L. Okay, so here we have to create a HQL script. Okay, so cat greater than sample.hql. So here I copied all the 4 queries. Okay, and then control C. Okay, now my sample.hql file created successfully. Okay, so you can cross verify here sample.hql file. So if you want to verify content saved or not, then cat sample.hql. Okay, hql. So in real time, based on requirement, you can implement n number of queries. All those n number of queries we have to place inside HQL file. Okay. Now, if I execute this HQL file, all the queries will execute. Okay. So first it will execute first query, then it will go to second query, then third query, like that. Okay. So how to execute a HQL file? Here Hive -f, then HQL file name sample.hql. So this is the command which will execute your Hive scripts. Okay, so here table created, after that load command executed. Okay, so where it is created means a default database or default queue. Okay, and now final table, it is creating a final table. Okay, so backend MapReduce jobs are running. So database name we have not given. Okay, that's why by default it is selected default database. Okay, so now here Hive mode, so use default database. So here we'll verify final table created or not. Okay, so final table name emp underscore final, select star from emp underscore final. Okay, so business logic we applied this only, right? Salary greater than 40,000 related data. Okay, like this in real time we have to create Hive scripts, HQL scripts, and we have to execute. Okay, and the next concept, how to pass parameters to HQL scripts. So here, if you see, I have created a table name with EMP. Okay. But again, if you execute the same HQL script, it will not execute. It will throw error, right? A table already existed error will get. Okay. And here also, if you see, today my data separated by pipe symbol. Okay. So that means this SQL will execute. Okay, it will work. But tomorrow my data, maybe it will come with comma separated. So at the time, if we execute this SQL file, it will throw error. It will not work. Okay, so that's why basically we have to define parameters wherever it is required. We have to define parameters while executing the HQL file. We have to pass those values, those parameters related values. Okay, so here instead of hard coding table name, I will define a parameter here. Okay, so here dollar, so table name. Okay, so here Hive where this is my parameter name, and here also you can define a parameter. So dollar Hive conf for variable, you can give basically anything. Okay, Hive conf for variable, and here delimited. Okay, delimited. Okay, so even here also, if you want, you can define parameter. So wherever you need any parameter, you can define. Okay, so now these two statements, okay, these two statements I will keep in one HQL script and I will execute. Okay, so here cat greater than parameter passing data HQL, okay, and paste. So ls parameter passing. Okay, so cat parameter passing data HQL. Okay, so now this is one parameter, this is another parameter. Okay, so while calling this HQL script, I have to pass values. Okay, so hive -f and then parameter passing data HQL. Okay, so before -f here we have to specify parameter. So first parameter name, this one, hive where okay, table name equal to. Okay, so maybe table name I want to specify emp1. Okay, and then next parameter name here hive conf. Okay, hive conf delimited equals to. Okay, so if your data separated by comma means comma, dollar means dollar. Okay, so here type symbol. Okay, then semicolon. Okay, okay, so while running the script, we are passing the parameters. Okay, so now we'll cross verify here table created or not, show tables. So table name emp1, so emp1 successfully created. Select star from emp. Okay, so like this we have to pass parameters to Hive scripts. Okay, so even database name also. Okay, so database name also you can create. Okay, so here we have to specify, right, use database name. Okay, so here also if you want you can pass a parameter. Okay, so Hive variable or conf you can give. Okay, like this. So this is about Hive scripts and parameter passing. I will discuss about DML commands. So basically in Hive 0.12.0, okay, so initial versions DML commands not supported in Hive. Okay, but after 14.0 version onwards, Hive is supporting DML commands. Okay, so DML commands means basically insert, like in SQL we are using, right? Okay, insert, update, and delete. Okay. So to enable these DML commands, basically backend, we have to add a few set commands in properties file. Okay, so in real time, basically Hadoop admin team will add those properties. Okay, so here, so these are the properties we have to add in a hive-site.xml file. Okay, so if we add these properties, then only it will support DML commands. Okay, like insert, update, delete queries. Okay, or else we have to add these set commands. Okay, but performance will be very less. Okay, so because Hive is supporting update, delete, but still it will give a very less performance. Okay, also in a real time, these properties Hadoop admin team will take care. Okay, in a few projects they are enabling this DML commands, but a few projects they are not enabling. Okay, due to performance issues. So here we'll add these properties. Okay, and we'll try how to execute DML commands. Okay, so to execute DML commands, first we have to enable these concepts in backend. Okay, so these all are the properties. Okay, we have to add. Okay, so where we have to add means inside a hive-site dot XML file. Okay, so basically these properties, these things Hadoop admin will take care. Okay, but here just knowledge purpose we are discussing. Okay, where we have to add, how to add. Okay, so to add these properties, we have to log in into root user. Okay, root user. Okay, so here root and password Cloudera. Okay, so here we have to go to Hive directory. Okay, so cd/usr ls, so cd lib ls. Okay, so here all the Hadoop related softwares they installed. Okay, so like a Hive module related they installed here, and pig module related, Wooji related. Okay, so basically in real time in a Hadoop we have many modules. Okay, 8 to 10 modules, but if they are using only 3 modules, 3 components, they no need to install other components, right? Only required components. Okay, so here only required components generally they will install in the real-time projects. Okay, so now here I have to choose Hive directory. Okay, cd Hive. Okay, ls. So here conf folder. Okay, so inside this conf folder we have all the XML files. Okay, configuration related XML files. So cd conf. Okay, again pwd. Okay, ls. Okay, so here your hive-site.xml file available. Okay, so inside this XML file we have to write those properties, or we have to add. Okay, so to modify this XML file we have to use a vi command, right? So vi hive-site.xml. Okay, and insert mode, now I entered into insert mode. Okay, so I will add these properties at the end. Okay, so maybe here I will add. Okay, so properties I copied already. Okay, then escape colon WQ. That means it will save and it will come out. Okay. So now we'll cross verify whether those properties are saved or not. Okay. Hive-site.xml. Okay. So here all the properties are saved. Okay. So now we have to restart a Hive server. Then only these properties will enable backend. Okay, so changes will reflect once we restart Hive server. So this is the command. Okay, so in real time, basically Hadoop admin team will execute these restart commands. Okay, so here, so Hive server stopped, and again server restarted. Okay, now we have to close this root user window, and this window also I am closing. Okay, so I am opening we have to open a new window. Okay, so here Cloudera, username Cloudera, password Cloudera. Okay, so now I'm logging into Hive mode. Okay, because DML commands we have to execute in a Hive. Successfully logged in. Show databases. Okay, so here default database is there. Okay, so use default database. Okay, so generally we can call as a database, or we can call as a queue also, queue. Okay, so show tables. There are no tables. Okay, so now first we'll create a table. So create table name I'm giving a customer. Okay, so here CID means customer ID. Okay, and customer name. Okay, here I'm giving a varchar of 129. Okay, and then clustered by. Okay, so based on which column we have to insert. Okay, based on CID. Okay, into how many buckets? Here I am giving 2 buckets. Okay, so 2 buckets, and then stored as ORC. Okay, so whenever we want to execute DML commands, we have to specify stored as ORC. Okay, then TBL properties, that means table properties, transactional equals to true. Okay. So this is a built-in function, TBL properties. Transactional equals to true means generally it will allow to execute update queries. Okay, update and delete queries. Okay, now table created, so we'll insert data insert. Okay, so insert into customer values. Okay, so first column ID, so ID value I am passing as 1. Okay, second one customer name. Okay, I am passing as Ram. Okay, okay, so now select star from customer. Okay, so data inserted successfully. Okay, and the next one update. Okay, so update table name customer. Okay, set which column related value you want to update. So okay, so instead of Ram I want to update Sam, where ID equals to 1, where CID. Okay, where CID equals to 1. So instead of Ram, we are updating Sam. Okay, so now we'll cross verify record updated or not. Okay, so instead of Ram, Sam replaced, so successfully updated. Okay, and the last one delete. Okay, So if you want to delete data from table, okay, delete from which table? Customer table. Okay, so now we'll verify that data removed or not. Okay, successfully deleted. So this is about DML commands. Okay, so next concept, the file formats. Okay, so in Hive is supporting different types of file formats. Okay, so one is a text file format and RC file format and ORC file format and Parquet file format and Avro and sequence file format. Okay, so while creating a table, so file formats. Okay, so here basically we'll create a table like this, right? Okay, so create table, maybe table name. Okay, and then here column 1, column 2. Okay, like this n number of columns. Okay, after that row format delimited fields terminated by. Okay, so maybe if it is comma comma. Okay, so generally in Hive we will use the create statements like this. Okay, so here we are not specifying any file format. Okay, so if we not specifying file format, that means by default it will consider as a text file format. Text file format. So if we not specify means by default it will consider text file format. Okay, and how to define file formats in a table. Okay, so end of your create statement you have to specify stored as text. Okay, if it is text file format, stored as text. If it is VRC means stored as VRC. Okay, if it is a Parquet means stored as a Parquet. Like this we have to specify. Okay, so only these three keywords backend your Hive framework will execute based on these three keywords. Okay, so just end of your create statement you have to specify file format. If you not specify, then by default it will consider text file format. Okay, or else you can specify like RC or ORC, whatever. Okay, so except this you no need to write anything. Okay, but what is the use of uh, these file formats? Okay, well, first point, it will save your HDFS space. Okay, because file formats basically few file formats it will compress your data. Okay, like generally in Windows operating system, if you have one folder, will do zip, right? Zip means actual size 1 terabyte means it will reduce after zip. Okay, so same way here also it will apply compression techniques so that it will save space. Okay, and retrieval also it will be very fast, speed retrieval. Okay, see obviously if data it is compressing and size will be reduced means performance will give very fast, retrieval is very fast. Okay, and a good writing space. Okay, so after compression if you uh, write or if you save your data inside a HDFS means space also it will save, right? Okay, because it is applying compression technique. Okay, for example if you have 10 MB, if you apply compression technique maybe it will come 6 MB or 7 MB, that means 3 MB or 4 MB space it will save. Okay, so these three advantages in file formats. Okay, so first one, text file format. Okay, so text file format behavior basically end of each line. Okay, it should terminated by a new line character. Okay, also uh, performance wise it will give a good write performance, okay, but data retrieval basically it will be bit slow. Like whenever you are trying to read your data compared to write operation, reads will be slow in a text file format. Okay, also text file format generally it doesn't apply uh, any kind of a compression technique. If it is size, actual size is 1 terabyte, 1 terabyte space is required, so compression technique it will not apply. Okay, and the second one, sequence file format. Okay, so sequence file format basically it will store your data in binary format. Okay, in that binary format also key value pair format it will save key value pair. Okay, and also if you want to merge 2-3 files in a single file, okay, it will do. Okay, so you can merge files into single file. Okay, so that is about the behavior of sequence file format. Also read and write. Okay, so write it will give good performance compared to your text files. Also read also it will give good performance here. Okay, and compression technique, sequence file it is supporting. Okay, so compression technique available. Okay, so basically these all backend it will take care. Okay, in create statement just we are adding a stored as ORC or stored as sequence, but backend these three automatically it will apply. Okay, your Hive framework will take care. Okay, and the next Yavro file. Okay, so Yavro file basically it is a file format and also serialization and deserialization concept it will apply. Okay, so basically this serialization deserialization available in core Java. Okay, and read and write operations of write average performance. Okay, also next RC file format. So RC file format behavior basically it is similar to your sequence file format. Okay, RC file format is similar to sequence file format. Also if you want to perform multiple rows at a time, okay, so you can use RC file format. Okay, and here reading is very fast, data retrieval or reading is very fast, but compromise with the writes, that means write it will be very slow. Okay, and the ORC file, so ORC file compared to your RC file format, ORC file is better. Okay, better, also faster reads, and writes it is very slow. And coming to Parquet file, so Parquet file it is just a columnar file format. Okay, similar to RC and ORC only. Okay, so here faster reads and slow writes. Okay, so these all are the 6 file formats. Okay, so query wise just end of the query we have to write only stored as then a file format name. Okay, but backend it will behave different. Okay, so like compression technique it will apply. Okay, and performance also reads and writes. Okay, based on your file format it will behave. Okay, so this is about file formats. We'll discuss about Apache Pig model. Apache Pig initially came from Yahoo company. Okay, so initially who implemented this Apache Pig component means Yahoo company implemented. So in Big Data Hadoop, initially only HDFS and MapReduce came into market. So HDFS from Apache company and MapReduce from Google company. Okay. Later Hive module came into market. So Hive module implemented by Facebook company. Okay. So later Facebook company handed over this Hive module to Apache software company. Okay, but Hive module basically it will support only structured data. Then Yahoo company realized okay, so Hive is supporting only structured data, but what about semi-structured and unstructured data? So Yahoo company implemented this big model. Okay, so basically pig module will support any kind of data. Okay, so any kind means it will support structured and semi-structured, okay, also unstructured data also. So in real time, which component we have to use for structured data? See, semi-structured, unstructured, okay, Hive anyway not supporting, but structured data Hive also supporting and pig also supporting. So basically in IT world, 80% people they have knowledge on SQL queries. Okay, so that means that 80% people Hive is very easy to learn. Okay, because Hive we are using SQL queries only. Okay, all the queries it is similar to SQL. So in real-time projects also, most of the projects they are using a Hive model for structured data. Okay, but a few projects they are using a pig model for structured data. Okay, but still which model we have to use in real time, that basically architect or your project manager, those people they will take a decision. But compared to Hive, pig is very fast processing wise and speed wise. Pig is very fast. Initially this pig model Yahoo company implemented, right, that we discussed, but later this Yahoo company hand over this pig component to Apache software company. Okay, after that again Apache software company did some customization and then they released into market. Okay, now pig component from which company means that is Apache software company. So next we'll see pig components. We have two components, pig Latin and pig engine. Okay, so pig Latin, basically pig Latin, it will allow you to write pig scripts. So pig engine, it will convert your pig scripts to MapReduce. Okay, so backend MapReduce jobs will run, right, to retrieve the results or to write the results. Okay, so it will convert your scripts to MapReduce jobs. Next concept, modes of pig. So in pig we have two modes. One is local mode. Second one is MapReduce or HDFS mode. So local mode means you can execute your pig queries in a local without a HDFS. Okay, you can execute your pig queries, okay, in local mode itself. Okay, so Linux operating system itself you can execute directly your pig queries. You no need to log in into HDFS. Okay, so if you execute your pig scripts in local mode, input path and output path should be local only. And MapReduce or HDFS mode. Okay, so here it will execute inside a HDFS. So inside a HDFS means your input path and output path should be HDFS. Okay, so your input file path you have to specify HDFS and output also you have to store in HDFS. Now how to log in into local mode? Okay, so here pig -x local. So this is the command to execute your queries in local mode. Okay, and MapReduce or HDFS pig -x MapReduce. Okay, or else you can give directly pig also. It will enter into MapReduce or HDFS mode. So now practically we'll see first how to log in into local mode. Okay, so whenever you want to execute your pig scripts, compulsory you have to log in into pig mode. Okay, so here pig -x local. Okay, so grunt means that is pig mode only. Okay, now successfully we logged into local mode. So here you can execute your pig queries. Okay, so pig component related queries you have to execute in a grunt mode. Grunt means a pig mode only. If you want to come out means you have to enter exit or control C. Control C. How to enter into map reduce mode? Okay, so pig -x map reduce. Okay, so successfully logged into map reduce mode. So here one more option is there, right? Whether you can use this one or this command also. Okay, so we'll try second option now. So control C, I came out from front mode. Now pig. Okay, so successfully logged in. Okay, so these all are the two modes to execute your pig queries. And next, data types. So what are data types your pig component is supporting? Okay, so int, float, double, boolean. And in a Hive basically we have seen string and varchar, right? But here char array means it will support any type, even it is a number or character. Okay, char array. So instead of varchar or string, here we have to use char array data type and byte array data type. Byte array, char array both are same, but why two data types required here? Both are supporting all. Okay, it is a number or a character. So in real time basically we have to use char array. Okay, byte array purpose I will explain later. Okay, these all are the data types. Okay, we'll use in pig module. Okay, Hive or RDBMS. Okay, and then pig. Okay, so in a Hive or RDBMS basically we'll call table, right? Okay, but in a pig we have to call bag or relation. You should not call table. Okay, so here bag means table or relation means table. Okay, in a pig always we have to call bag or relation. You should not call table. And in Hive or RDBMS we'll call a row, right? Okay, here instead of row we have to call a tuple. Tuple means row. Okay, in pig tuple means a row. And here field. So field. Okay, field here also same we are calling field only. Okay, so field wise no difference, but these two always we have to keep in mind. Okay, so in a Hive RDBMS a table row generally will call, but in pig table means we have to call only bag or relation. Okay, row means tuple. Okay, so now how to check pig version? Okay, so for example in your project you want to check your pig version, because you know few concepts it will not support in a few versions, right? Old versions. Okay, and a new version whether it is supporting or not. You executed one query or function. Okay, so it is not working. So if you want to check whether that is supporting in current version or not, okay, that time you have to check pig version, right? So how to check pig version? Okay, so here pig hyphen version. Okay, see here it is showing version 0.12.0 pig version and Cloudera version 5.13.0. So like this you have to check your pig version. Okay, and the next types of bags creation in pig. Bags creation means tables creation, right? information. So how many ways you can create table or bags? Okay, so first one is a full schema, second one is a semi schema, and the third one is a no schema. So three ways you can create your bag. Okay, so full schema means you have to define all the elements and data types. That is called a full schema. Semi schema means elements mandatory, all the columns you have to specify, but data types are optional. See, uh, maybe one column numbers and characters both are there. Okay, so here which data type it will support means a char array, byte array, both it will support, but you have some confusion. Okay, which one you have to specify. So at the time you no need to specify data type name, you just specify column name. So data type backend your pig framework will assign. Okay, so data types optional in semi schema. No schema means no need to define elements or data types, just you can load your data file. Backend your pig framework will take care. Okay, so last two features not there in a Hive module. Okay, see, you have 100 columns. Okay, so that means it will take time, right, to define those column names and the data types. Okay, so at the time better you can go for no schema, just you load your data automatically, backend it will take care column names and the data types. So now first we'll see practically full schema. So for that we need one a data file, right? cd data ls, okay, cat employee.txt. Okay, so for this data file in a pig full schema bag I will create table in pig. Okay, so to create a table we have to log in into grunt mode, right? I'm opening one more window here, logging into local mode pig-x local. So now bag name, so starting itself we have to give table name, employee equals to load is a keyword. Okay, built-in keyword. Load means it will load your data file. Okay, so your data file available under which path? This is the path home Cloudera data. Okay, so here that path we have to give home Cloudera data. Under data your file name employee.txt. Okay, using also keyword pig storage. This is built-in function, p and s capital letters here. So what is the purpose of this built-in function pig storage means here you have to specify your each column separated by which symbol, whether your data separated by pipe symbol or comma or space, that we have to specify. So in Hive basically we are giving row format, delimited, fields terminated by like that, right? But here you have to just specify built-in function, that is pig storage. Okay, so backend your pig framework will take care. And here you have to specify column names and data types. Okay, so first column employee number, data type int, employee name, here a char array data type. Okay, and then a phone number. So phone number, whether you can give int or char array, anything you can specify. Okay, and then salary int, department number int. Okay, so here before defining column names and the data types we have to give as. Okay, so now successfully your full schema bag created. So you want to see data loaded, bag created or not. Okay, then dump bag name, so that it will read your data from bag, from table. Okay, so successfully retrieved. So here, while creating bag, it will not verify whether that path is correct or not. Okay, but when you are trying to retrieve a data, when you use the dump command, only that time it will check this path is correct or not. Okay, so this is about a full schema. Okay, now maybe you want to describe your bag, like what other columns and the data types are there you want to check, then describe bag name. So this is the command. It will show you all the column names and the data types. Really, we have one more command, illustrate and bag name. So what is the difference between describe and illustrate? So describe only column names and the data types. Okay, so here column names and data type. So along with the column names and the data types, one sample record also it will show. If you use illustrate, it will show one sample record also along with the data types and column names. Okay, this is the difference between data describe and illustrate. So now we'll discuss about semi schema. Okay, so semi schema, only column names mandatory, data types optional. Okay, so how to create a semi schema, a bag. So here, so in semi schema, only data types optional, correct? Okay, so I have confusion for phone number. I don't know whether I have to specify int or char array. So I'm not defining a data type. Okay, so column names is mandatory. So all the column names available, but data type optional. So data type I have not specified. Okay. So earlier also full schema I used the same bag name. Now also same. That means it will override. Okay. So now if you specify dump, it will give you result like full schema. Okay. But for phone number, which data type it is assigned, because we have not specified a data type. Okay, so data successfully retrieved, but which data type it is assigned. Okay, so describe employee. See backend byte array data type assigned. Okay, so whenever user want to specify data type, we have to give char array. If you don't know what data type, if you want to specify, then just you specify column name, you no need to define data type. Backend it will assign a byte array data type, because byte array it will support any type of data. This is about semi schema. Okay, and last one, no schema. No schema means no need to define any columns or data types, just you have to load your data file. Okay, so no need to specify column names or data types. Just I am loading data. This is called no schema. Okay, so dump employee. Okay, so no schema also retrieved data like your no schema and full schema, semi schema. Okay, it is retrieved like a semi schema and a full schema. Now doubt is column names we have not defined, right? But if I want to retrieve a specific column related data, then I have not defined any columns, right? So how will retrieve? Okay, so basically if you not defined column names in a no schema, then by default backend it will assign column names as like this. First column $0, first column name, Then the second column $1, $2, like that, n number of column names. So now if you want to read employee number related data, means you have to use column name as $0 for no schema. Full schema and semi schema, we are defining column names. Okay, so based on those columns we can retrieve data. But no schema, we are not specifying column names, but backend your pig framework, it will assign column names as like this in order, starts with $0, $1, $2, so on. So this is about types of bags creation. Okay, next concept, how to store results in pig. Okay, so basically pig is a session oriented. Session oriented means, see, Hive, if you create employee table, after 2 days or after 3 days, again if you log in, if you enter show tables command, means it will show all your existing tables, but in pig it will not show. Session oriented means, now I am in this session, I created employee, okay, employee bag. Okay, if I close this window, putty window, again if you relog in, it will not show this table related data, this bag related. That is called session oriented. Session oriented means if you are there in that session, it will show. Even if you are there in the same window till evening, if you enter n number of times employee related, then it will show result. But once you close this window and if you reopen, it will not show that bag related information. That is called session oriented. But if you want this data for future purpose, you have to store that data. You have to store that output into somewhere. Then permanently it will be available, that output or that results. Okay, so now how to store that results permanently? Okay, for that we have to use one command. Okay, that is store. Store is a keyword. Okay, so which bag related data you want to store permanently? Employee bag related data. Under which directory you want to store your results. Okay, so Cloudera, and then here new pig directory, it will create backend automatically. Okay, using pig storage. While storing the results, each column you can separate with this symbol like that we are telling here. So successfully executed. Now we'll verify output permanently stored or not. Okay, ls cd new pig directory created ls. So here results. Okay, so like this permanently we have to store final results or output into some directory. Okay, because pig is session oriented. Once you close this window, if you re-log in, it will not show. Okay, I will show practically now. I'm closing this window. Okay, so I'm re-logging pig-x local. Okay, now if you give dump employee, it is throwing error, unable to find. That means it is not available. Okay, this is called session oriented. How to bags using map reduce or pig mode. Okay, after that, how to apply filter. Okay, so in a Hive, basically we are applying where condition, right? Okay, so here instead of a where condition pig, we have to use a filter and limit. So how to restrict rows? Okay, so here also we have built-in function that is limit, and then we have order. Order basically we know, right? Order by salary descending or order by salary ascending, and we have distinct. So distinct means basically maybe in your table you have some duplicate records. So instead of duplicate records, if you want to retrieve a unique records, at that time you have to use distinct. Okay, and the size. Okay. So basically in a Hive we use the length, right? Length means each word how many characters like 5 or 6 7, right? So here instead of length we have to use size. And then we have here string functions. Okay, so string functions concept, we have substring and replace we have, and then concat we have, and upper, and then lower, and then we have LC first. LC first means basically only first letter it will convert into lowercase letter. Okay, and the UC first. Okay, so UC first means only first letter it will convert into uppercase. Okay, then we have a split also. So first we'll create one bag in pig mode or MapReduce mode. Okay, so first topic. So here now how to log in into MapReduce or HDFS mode. Okay, so pig, this is the command to enter in MapReduce mode. So I have logged in. So now to create a bag in Reduce mode, our data file should be there in a HDFS path. Okay, so first we'll cross verify any data file available in HDFS. Okay, so I have one a data file in user Cloudera emp directory. Okay, so this is my HDFS directory. Okay, so now I have to create a bag for this data. Okay, so here bag name A I am giving, you can give employee or whatever. Okay, I am giving A. Load is a keyword. Okay, so that means we have to load the data. So data file available under user Cloudera, and then emp, under emp employee.txt file. So data separated by which symbol, that we know. Okay, so big storage, here data separated by pipe symbol. Yeah, so all the column names and the data types we have to specify. So employee number, e name. So for e name here we have to give char array. Phone number. So phone number also you can give char array or byte array. And then salary. Then department number. Okay, so successfully created a bag in MapReduce mode. Okay, so now if you want to retrieve the results, then you have to use dump and then bag name. My bag name is here. Okay, so local mode or MapReduce mode, queries wise same only. Only input and output path we have to change. Okay, so here basically if you are using local mode, okay, that means input and output path should be local. Okay, MapReduce mode, input and output path should be HDFS. Okay, so this we have to keep in mind always. Okay, so queries wise same only input and output path will be different. Okay, so here successfully retrieved the data. Okay, so like this we have to execute queries in MapReduce mode. Now how to apply filter? Filter means where condition. Okay, so now I want to retrieve maybe more than employee number 130 above related data. Okay, employee number 130 related data. So at that time you have to use a filter. Filter basically it is a keyword and it is a built-in function. Okay, built-in function. Basically, it will come with your Apache Pig software. Okay, Apache Pig framework. So filter you are applying on which bag, employee bag or A bag? I am applying on A bag, filter A. By which column? Okay, employee number column. So where employee number greater than 130 related data I want. Okay, so filter, after that your bag name, then by, after by column name, and then condition. Okay, so these results you have to store into different bag always. Okay, so if you not store this data in same session, it won't be available. Okay, so I'm giving a bag B equal to this. So that means whatever results this will retrieve, that result it will store into bag B. Okay, so now dump B. So dump B, now it will read more than 130 employee number related records. Okay, so here successfully retrieved employee number 130 above related data. Okay, so filter you can apply anywhere. Okay, so maybe salary greater than 10,000 related. Okay, so instead of where condition in a pig model we have to use a filter. Okay, and the next limit. So I want to restrict rows. Okay, so only one record I want to see. Okay, so now limit you are applying on which bag B or bag A, whatever. So if you apply bag B only 15 records out of 15, okay, it will display maybe one or two, okay, based on your condition. So from bag B I want only one record, or I want two records. Okay, so this results also I'm storing inside a bag. So my bag name C equals to limit I am applying on bag B and only two records. Okay, now dump C, because C bag contains this results, limit condition related results. Okay, so successfully retrieved two records. Okay, even in our limit we specified two, right? So two records populated. So now order by order you are applying on which bag? Okay, so maybe I am applying on bag A. Okay, by which column? Okay, salary column. Okay, under A by salary, here ascending or descending. Okay, so here I am giving a bag name D. Dump D. Okay, so here salary ascending order. Okay, so 36,000, 38,000, 39,000. Okay, so it is populated ascending order. Now descending order. Okay, so order A by salary, DESC, descending order. Dump. Okay, so here we can see descending order. So results are displayed successfully. Okay, so this is about order. Next we'll see distinct. Okay, so distinct actually duplicate records required. Okay, but in our data file there is no duplicate records. Okay, I will just show query. Okay, so distinct basically here you have to give your bag name equals to distinct. Distinct you are applying on which bag? Bag A. Okay, only this. That's it. Distinct and bag name. Okay, only unique records it will populate instead of duplicate records. Okay, now we'll see size. So here size applying on which column? Employee name column. Okay, size of employee name. Okay, and then bag g equals to for each. Okay, you are applying size, you are applying on which bag? Bag A. Okay, generate, then ename comma size of ename. Okay, G. Okay, see, employee name size how many characters? 4 characters. So here 6. Okay, next before going to string functions, okay, so here we'll discuss about another point for each and generate. So for each, if you want individual columns related data, then you can use for each and generate. Okay, or if you want to generate new columns based on existing columns, you can use for each and generate. Okay, so now my bag A contains 5 columns, but I want only 2 columns related data. Then how to retrieve? Okay, so here h bag name h for each I am applying on bag A. My bag A contains data. Generate, and I want only 2 columns related data. So employee number, e name. Okay, dump h. So now this for each and generate, it will read only 2 columns related data. So we have 5 columns, okay, but it will read only 2 columns related data. So whenever you want to read specific columns related data, then you can use for each generate. Okay, so only 2 columns related. Okay, and next point, new columns based on existing columns. I want to generate new column. Okay, so here employee name. Okay, I want to generate a bonus. Okay, bonus column not there in bag A. Okay, so here salary into 0.2% as bonus. You have salary column, maybe if salary 10,000 means 10,000 into 0.2, that it will generate new column as a bonus. So values it will generate. So salary into 2 as a bonus. Okay, so dump h. Now third column, it has to show bonus amount. Okay, bonus amount, third column bonus amount. Okay, so salary into 2 bonus amount. Okay, now string functions. In string functions we have first one substring. So bag b equal to for each, we are applying on which bag? Bag A. Okay, employee name comma substring of substring you are applying on which column? Employee name column. Okay, and which position to which position related data you want. Dump b. So 1 comma 3. Okay, so here position always it will start with 0. That's why it is started with a. Okay, so 1 comma 3. Okay, 1 2 3. Okay, so end position if you give 3 means it will display till 2 only. Okay, if you give 4 means -1 it will apply. If you give 6 means -1 it will apply. Okay, so this is about substring. And the same way concatenation also you can. Okay, phone number here concatenation. Okay, concatenation. Okay, done. B. So now concatenation of employee name comma phone number. Okay, so both the columns values it will merge and it will display as single column. So here if you see both the columns related data. Okay, and then next replace. So here replace. the place. So employee name, wherever small s is there, you can replace with capital S. Okay, dump B. So small s, see here small s, here can replaced with capital S. Okay. Upper, how to convert into uppercase letters. Okay. So here instead of replace function, we have to give upper. Okay. Dump B. Okay, see successfully converted into uppercase letters. So same way lower also. Lower. Okay. So now it will convert into all lowercase letters. Okay. So here capital M, but here small m. And the same way LC first and LC UC first. So LC first. So LC first means only first letter. It will convert into lowercase letter. Okay. So here converted into lowercase letters. The same way UC first. So UC first means only first letter it will convert into uppercase letters. Okay. So here successfully converted into uppercase letter. So next one split. Okay. So here bag B equal to split. Split means basically whenever you want to split your data into multiple tables, that time you can use split. See, based on some condition, if you want to move that condition matched related data into other bag means you can. Okay. So split you are applying on which bag? A into A related data you can put into bag X if employee number greater than 120. So employee number greater than 120 related data, you can create bag name X and you can put 120 above related data in bag X. Okay. And then Y if employee number double equals to 140. Only 140 employee number related data you can put in bag Y. So here based on these two conditions, see our entire data is there in bag A, but I'm splitting data into different bags. Already you are creating two bags. Again, you no need to put these results into bag. Okay, so now dump X. So X related only salary greater than 120 means so all the employees salary more than 120. So by default, it will display all the records. Okay, now employee bag Y contains only 140 related data. Okay, so here dump bag Y. Okay, see bag Y contains only 140 related data. Okay, so this is about string functions. Okay. These pig scripts also like similar to Hive scripts. Okay, so till now in pig we executed individual queries. Okay, but if you want to execute okay at a time 10 queries or n number of queries, okay, that time we have to use pig scripts. Okay, so here maybe I have one client requirement. Okay, so client asked me to create one bag. Okay, after that data loading. Okay, I have to load data. I have to apply a filter condition. Okay, and then I have to apply a limit. Okay, then final results I have to store in some location. So you can assume this is small example, but in real time maybe based on business requirement we have to implement complex queries or a number of queries. Okay, so now for all these conditions I will write queries. Okay, after that I will put inside pig script. Okay, so pig scripts names you can give any name, but script should ends with dot pig. Any script, any pig script should ends with dot pig. So name you can give anything. Okay, so maybe here I'm giving a name as pig script dot pig. Create one bag. Okay, so here I will create a bag. Okay, so maybe employee bag. Okay, so load, data loading, and then using pig storage pipe as employee number int employee name array phone number array salary int department number int. Okay, so tag creation completed, and same time here we are loading data also. Okay, that means data loading also completed. Next, third step, I have to apply filter. Okay, so bag B equals to filter. Filter you are applying on which bag? Employee bag by salary, maybe salary greater than 40,000. Okay, so filter also I applied filter condition. Now I have to restrict rows. So bag C equals to limit you are applying on which bag? Previous bag, my previous bag name B. Okay, so bag B contains only 40,000 above related records. So based on B results we are restricting rows. Here I want only 2 records from bag B. Okay, and final results I have to store in a directory because pig is session oriented. So here store results we have to store. Okay, and which bag C related into, okay, into under which directory you want to store, home cloud. So if you want to store in HDFS, you have to give HDFS path, but here I am trying to store in a local directory. Okay, so testing. Okay, and then using pig storage type symbol. So this step also I implemented. Okay, now all these queries I have to put in a script. Okay, so here less cat greater than pig script dot pig. Okay, so all 4 queries. Okay, control C. Okay, so successfully stored. Now I will check pig script dot pig is available or not. It is available. Okay, even inside that query is also available or not, that will check. Okay, so query is also available. Now how to execute this pig script? Okay, so here pig -x local. If you want to execute in local mode, you have to give local. If you want to execute in HDFS or MapReduce mode, then here you have to give MapReduce. Okay, then your script name pig script dot pig. So inside that script, all the queries it will execute. Okay, so final output it will store into testing directory. Okay, so success, here it is showing success. Okay, and here it is telling output created. Okay, so cd dot dot pwd ls, here testing directory it is showing, so cd testing ls. So here output generated. Okay, so if you want to see output cat file name, see, so limit we given 2, that 2 should salary should more than 40,000. Okay, so like this real time Based on a requirement, we have to implement n number of queries. Those n number of queries we have to put into script. That is called a pig script. So next concept, parameters passing. Okay, so similar concept we discussed in a Hive module also, how to pass parameters to Hive scripts. Okay, so here also how to pass parameters to pig scripts. Okay, so here, okay, here I have a bag. Okay, bag. Okay, so loading here employee.txt. Okay, using pig storage type. Okay, so instead of hard coding data file name, okay, see now I hard coded. Okay, if I execute pig script, it will execute first time, second time also. Okay, but maybe tomorrow file name it will change, it will come with a different name. That time this query will not work, right? Okay, so in such a scenario we have to make this as parameter. That parameter, while running the script, we have to pass the value. Okay, so here dollar file name. So this file name, while executing the script, I will pass this file name value. Okay, and delimiter also, maybe today it is separated by pipe, maybe tomorrow maybe data will separate by comma. Okay, so here also dollar delimiter. Okay, so like this we have to define parameters. Okay, so after defining parameters, how to pass values, I will create one script for this. Okay, cat greater than parameters dot pig script name. Okay, and then control C, ls, so parameters dot pig available cat script. So inside script query is there. Okay, now while executing this script, I have to pass this parameters related values. So pig hyphen x local, then hyphen param, first parameter name file name. So file name equals to, if it is employee.txt, employee.txt. If it is customer.txt, you have to give customer.txt. And the next param name delimiter. Okay, so delimiter equals to, if it is comma you can give comma, if it is pipe you can give pipe. Okay, after that hyphen f, your script name, parameters dot pick, hyphen param. So successfully executed without any errors. So now we passed parameters without any errors. Okay, so this is about parameters passing. We'll discuss about aggregate functions. Okay, so compared to Hive aggregate functions, in Pig we have two or three functions, more functions available, like new functions. Okay, so first one, count. Okay, so basically count means if you want to apply a record count, then you can use count. But count always it will ignore null values. Null values means, for example, in your data file you have 50 rows. Okay, but 51 row is completely empty. Okay, so here if you apply count, so it will give 50 or 51. Okay, so ignores null values means it will give only count 50 because 51 completely empty, so it ignores. And coming to count underscore star, it includes null values. That means empty rows also it includes. So now count underscore star, how many records count it will give? 51. So even empty one also. So what is the difference between count and count underscore star means count, it ignores null values. Okay. Count underscore star, it includes null values. Okay. And max we know. Okay. So whenever we want to see highest salary or something, then we can use max. And min means lowest salary details or values. And average we know. Okay. And sum means for example, if you want to apply sum on salary column, like all the employees salary, if you want to sum, okay, then you can use sum. And diff, basically if you want to compare two different fields related values, then you can use diff. Okay, so basically it will compare two different fields related values. So wherever those two fields related values not matching, then unmatched records it will populate. Okay, but matched records it will not show, only unmatched values it will show. And coming to next one, cross. Okay, so cross basically it will work like a cross join. In a Hive we discussed it, right? So it will work like a cross join. And a union it will work like your full outer join. So both the bags, all the records. Okay, so to apply aggregate functions, okay, first we have to create a bag. So here first full schema, then a bag a equal to load home Cloudera data employee.txt using storage type, then as column names and the data types. Okay, e number, int e name, array, phone number, array, salary, int, department number, int. Okay, so bag A created. So now bag B equal to group you are applying on which bag? Bag A, by based on which column? Department number. So each department related employees we are applying a group. Okay, so like department number 10, how many employees, like that. Okay, so now group we applied, so group related information available in bag B. Okay, C equals to for each you are applying on which bag? I am applying on bag B. Okay, generate, then count of a bag. Okay, then sal, full name we have to give here, salary. So dump C. Okay, so here y3 it displayed. Okay, because we applied group, right? Okay, cat employee.txt. Okay, so here department number 21, how many? 4. So 4. Okay, but here count we discussed that it ignores null values, but in our data file there is no empty row or null record. Okay, so now what I will do, backend I will insert one empty record. okay, backend. So here vi employee.txt, okay, insert mode. So starting itself one empty row, okay, escape :w q, okay. Now cat, okay, so here if you see empty row, okay, empty row. Now again we'll execute. So first I will load the bag again. I will create, okay, bag A created, then bag B, okay. So now it is loaded empty record in bag A, okay. Then bag C, okay, dump, okay. So here 0, that empty record it ignores, okay. And now we'll try for count underscore star, okay, whether it includes or it ignores, that we'll see, okay. So here instead of count I will give count underscore star, dump C. See, previously 0 for count, but count underscore star it is giving 1. That means it includes null values or empty records, okay. So this is about the count underscore star and count, okay. Now max. So each department number, if you want highest salary employee or highest salary, okay, then you can use here max, okay, dump C, okay. So here 17,841 first department related, it is telling 17,841 highest salary, okay. So we'll cross verify, okay. So department number 10, so this only, right, highest salary, okay. So each department related, so here also department 11 4 employees, okay. So whose salary highest means this one 41,061 7, okay. So this one, okay. So this is about max. And min means lowest, each department lowest salary, okay. So lowest salary, then here whose salary lowest here 13,000 department number 10 related 13,575. So 13,575. And then average AVG. So average also each department related. So department number 10, okay, average means how many employees? 3 employees, okay. So all these 3 salaries it will apply sum, okay, and then by 3 number of employees, then it will give average 15,242 average it is giving, okay. So 14 13 this one, okay. That means almost 45,000 plus, by 3 means 15,000, okay. So this is about average, okay. Now sum, okay. So here sum means each department related how much salary they are paying for employees, okay. So department 10 3 employees, so 3 salaries, okay. So it will come 45,000 plus or 46, okay, okay, 45,726, okay. So max completed, min, average, sum completed. Now difference, okay. So difference will apply on 2 fields, okay. So bag B equal to for each a generate diff of, okay, name comma phone number, dump B. So employee name means only characters, phone number means number. So always it will not match, right? So that means all the records it will show. See, wherever it is not matching, obviously employee name and phone number never match. That's why both the columns related values are populated. Okay. So now what I will do, I will give employee name itself. I will compare employee name. Then it will give empty results, right? Because both the values it will match, right? Comparing employee name with employee name. See, all empty because no difference, right? Okay, that's why empty. Okay, so this is about a diff. Okay, now cross. Okay, so cross we know, right? For cross, basically we need two bags. We created only one bag, right? Bag A. Okay, so bag B I will create with the employee data. Okay, so here cat dept dot txt. Okay, so for this data I will create one more bag. So here bag B equals to load home Cloudera data dept.txt using pig storage type symbol as dept number int dept name char array salary. Okay, so bag C equals to cross you are applying on what other bags, bag A comma bag B. Okay, dump. Okay, so cross. Okay, so cross means left side each record it will map with the right side all the records. Okay, see right side department 10 related record it mapped under department 11 related 12 related like that. Okay, and then union means from both the bags all the records it will populate. So here union dump C, both the bags all the records it will display. Okay, so first one union bag A related and this results bag B related. So both the bags all the records. Okay, so this is about the cross and union. Okay, so aggregate functions we completed. Okay, so basically in real time instead of aggregate functions we can call eval functions also. Aggregate or eval both same only. About how to process semi-structured data. So first we'll see how to process XML files because XML files also will call as semi-structured data. And then JSON files how to process. So semi-structured data main in real time these files we have to process. Okay, so these two will come under semi-structured data. After that we have another topic that is complex data types in pig. Okay, so here we have again three concepts. One is tuple, second one is map, third one is bag. So first we'll see how to process XML files. So here I have one XML file. Okay, so ls cd data ls. So here I have one XML file, book.xml file. So catch book.xml. So this is a root element. Okay, and this is sub elements, these two. Okay, that means this is just one row. Okay, so under this root element, name and cost. Okay, here values. Okay, name and value. Also, this is another set of record. Okay, so this is name and this is value. So how to process this data file? See, at the end we don't want all this, right? So we need only values. Okay, so once you get without root elements, if you get values, you can apply any business logic. Either you can apply joins or you can apply aggregate functions or string functions, whatever you want. So first we'll create bag and we'll load data. So now here my bag name A equals to load, and here I have to specify book.xml path. So under home, Cloudera, and then data, then book.xml. So if a data file is there in HDFS, means here you have to give HDFS path. Also same time you have to log in HDFS mode instead of local mode. But here before loading data, we have to register supporting jar file. Okay, so to process XML files related data, backend piggybank.jar one built-in jar file available. Okay, so that jar file we have to register here. Okay, so I will show that jar file. Cloudera cd usr ls cd lib cd pig. Okay, ls. So here we have supporting jar file. So this is the jar file, piggybank.jar. Okay, so whenever we want to process any kind of semi-structured data, then this jar file will help to extract the data. Okay, so this jar file we have to register. Now we know the path, right? This jar file path. Okay, so here grunt mode, this is the grunt mode. Okay, so register, then your jar file path. Okay, so jar file path we know, right? usr lib pig, then piggy bank.jar. Okay, so successfully registered. Now if you load XML data, it will support to process. Okay, so here bag A equals to load, then your XML file path, home, Cloudera, data, under data, book.xml file. Okay, using, so earlier pig storage we used, so data separated by comma or pipe that we specified. Okay, but here different, right? Here elements are there, book, name, cost. Okay, so here to extract those we have to specify a package. So inside that jar file one package is there, piggybank.jar file. Okay, so org means organization, Apache, because this is from Apache dot pig dot piggybank dot storage dot xml loader. Okay, so till here this is the package. Under this package this is the function. Okay, so xml loader of. Okay, so we know, right? File name book, so you no need to specify the .xml. So here yes, so for this entire data I'm specifying a single column. That column name I'm just assuming a name, char array data type, because here name, characters and cost numbers. So which data type it will support means char array data type, it will support both. Okay, so successfully loaded the data. Now dump. Yeah. So data loaded, right, successfully. See here, so 2 records. Okay. Now we don't want this, right? We need only values. So how to remove these tags? So for that also we have to write query. So bag b equals to for each. So for each you are applying on which bag? Previous bag. Previous bag name A, because A contains XML data. Okay. Generate flatten. So flatten built-in function we discussed in a previous session, right, about flatten. And here regex underscore extract underscore all. So that means it will extract only values. It will remove all those tags. Okay. So here column name name. Okay. So previous back we defined only one column, right? That is name. That column contains data, entire data. Okay. So here first which element? Book element. Okay. So here book. After book, which element is there? Name. So name and book both are same or different? Book and name both are same, different words, right? Not same. Okay. So here next which tag means name. Okay. After that again which tag? Again they closed the name tag only, right? So here name. After name which is there? Cost. So cost they opened, again cost closed. Okay. So here cost. So again cost they closed. Okay. After cost finally which one? Book they closed. Okay. So here. So now so coming to book and name, both are different. If both are different means we have to specify here a yes star. Between those two double slash star. And here also name and cost both are different. So between those two double slash yes star. And here also cost and book both are different. That means yes star. Okay. Now again here name and name both are same only, right? So if both are same tags, then between those two you have to specify dot star. So here also cost and cost both are same. Then we have to specify dot star. Okay. So if elements are different, then between those two you have to specify double slash s star. Okay. Elements are same means between those two dot star. Okay. B equals to for each. Okay. For each we are applying on bag A generate. So flatten of regex underscore extract underscore all. So this function also it is available in piggybank.jar file. Okay. And then previous bag A we defined a column name as name, because name contains entire data. Okay. Comma. So here whatever elements available, root elements, sub elements, all those we specified. Dump B. So here only two elements. Okay, we discussed only two elements. Okay, so book one element and sub elements name cost. Okay, but in real time n number of elements. Okay, so maybe name cost. Okay, so description like that n number of Okay, so even if it is n number of also query, we have to follow same only. Okay, so here data successfully retrieved. Okay, so query wise, here maybe description you have to add extra. Okay, so till cost we specified, right? After cost, if description means again here description. Okay, so like this you have to add a number of elements. Okay, but only thumbnail is if tags are different between those two, we have to give / star. If both are same means between those two we have to give dot star. Okay, this is about XML files processing. Now how to process JSON files. Cat sample.json. Okay, so here see JSON files always looks like this only, but here we have only 3 columns. Okay, so food related value, person name, amount and value. Okay, so this is a JSON file. So JSON file format looks like this always. Okay, so now we'll process this data. Okay, we'll process. So here bag A equals to load home Cloudera data, then sample dot JSON, sample dot JSON. Okay, then here using JSON loader. Okay, so to process JSON files inside piggybank.jar, we have this JSON loader function. So we have to use that built-in method so that it will read only values. Okay, so JSON loader, and then the first column name food. So food which data type? Array data type. And then the next person which data type? Array. And then amount which data type? Int data type. Yeah. So here instead of using a pig storage, we have to use a built-in function JSON loader for processing JSON files. Successfully retrieved values. Okay, so like this we have to process JSON files. Okay, so next concept, complex data types. Okay, so complex data types, earlier we discussed about bags, like regularly we created bags, right? See, bag always it contains tuples means rows. Okay, so bag we no need to discuss. Okay, so we created many bags. Okay, so tuple will see one example. Okay, and map also will see one example. So map basically whenever your data looks like a key comma value pair, then you have to apply map. Okay, whenever your data looks like a key comma value pair, then you have to apply map. Okay, so tuple means collection of data. Okay, so each row contains collection of data, right? Okay, so first practically we'll see how to use tuple data type. So here we need data file first. Okay, so we'll create one sample data file. So cat greater than tuple data dot txt, and then control C. Okay, so cat tuple data dot txt. Okay, so this is just a small data file I created. So this is mobile series number, and this is maybe a brand name. Okay, so for this we'll create a query and we'll load the data. So a equals to load home Cloudera data tuple data dot txt as t:\tuple of. So here this is just a object I created a t. Okay, tuple. So first column maybe brand number. So which data type? Int data type. Second one brand name. Which data type? Char array data type. Okay. So now if you want to read only brand name related data, okay, then here back b equals to for each a generate. So here we created object, right? So this object holds the entire data. So object name dot column name, which column related data you want. Okay, so I want maybe both the columns. If you want single column, you can specify a single column also. Okay, t dot brand number, brand name, term b. So whether you can read a specific column related or all the columns related, but object name with object name you have to read object name dot column name. Okay, so successfully processed. So this is about a tuple. Now we'll see how to process, how to use a map data type. Let's cat. So here this is a key and this is a value. This is key and this is value. Okay. So we'll see practically how to load data and how to retrieve specific key related values. Okay, back a equals to load home Cloudera data complex data map dot txt as a. So column name a and then data type name map complex data type name. So here multiple keys and multiple values. Okay, that's why we specified this symbol. That means a collection of values it will store. Okay, and here a is a column name. Okay, or you can assume object name also a. Okay, so object dot you can give like column name dot or object dot you can call a key, then it will read a value. Okay, so here back b equals to for each a generate then a slash key name right, first key name comma next a slash age right, next key. Okay, dump b. So here we are just calling keys. It should retrieve values, that particular key related values. Okay, so successfully retrieved that particular key related values. Okay, so here we specified name and age, only two columns. If you want only one also, you can specify only one key related value, it will retrieve. We'll discuss about joins in big module. So actually here we have a few joins. Okay, so first one is left outer join and second one is right outer join. Third one is full outer join, and the fourth one is inner join. And also here we'll see how to apply join on multiple columns instead of a single column. How to join multiple columns. Okay. Also in Pig model we have advanced joins also. One a replicated join. Second one is skewed join. Third one is merge side join. Okay. So these joins basically are regular joins, but these joins generally we'll call as advanced joins. Okay, advanced concepts in a Pig component. Left outer join we know. Okay, so left outer join basically you can assume I have two bags or a relation. Okay, so maybe first bag, my first bag name employee, second bag name is a department. I have two bags. Okay, so employee bag I have department number column, and a department also I have department number column. So how to apply left outer join on these two bags? Okay, so theoretically we know what is the left outer, what is right outer, what is a full outer, what is inner join. Even in SQL also same, Hive also same, even Pig also theoretically it is the same. Okay, but only difference is the queries. Okay, so left outer join, how to apply? Okay, so now practically we'll execute a left outer join. Okay, so to apply any join we need two bags. We have to create two bags or a relation. Okay, so first we'll create a employee bag. Okay, for that we need a data file. So here ls cd data ls pwd. Okay, cat employee dot txt. Okay, so I have data file in local file system. For this I will create a bag. Okay, so to create I have to log in into pig mode, pig-x local. So here I'm logging local mode, but in real time we have to use HDFS mode. So successfully I logged in. Now while creating bag I have to specify 5 columns and 5 data types. Okay, so here I'm going to create a full schema bag. Okay, so bag employee equals to load is a keyword. Okay, and here data file path, then employee.txt using pig storage. So your data file each column separated by which symbol. Okay, that we have to specify here as here column names and data types. So first column employee number into data type, second one ename. So char array data type, and then phone number, so char array, and then salary into data type, then department number into data type. So I have created my bag. So this is first bag. So we'll cross verify whether data loaded or not. So dump employee. So bag A successfully loaded the data. Okay, now we have to create a bag B also, right, to apply joins. Okay, So here I have one more data file, department.txt. So for this I will create one more bag. Okay, so bag name is department, bag are relation, and here load. So load your data file path, home, Cloudera, data, and then dept.txt using big storage. So here your data separated by pipe symbol. Yes. Then here column names and the data type. So department number of integer data type, department name, array, then salary. Okay. So I have created my department bag. Dump department. Okay, so now both the bags, which is common column, we have two common columns, department number and salary, both. Okay. Okay, so department bag also data available. Okay, so first we'll see left outer join. So how to write a query for a left outer join. Okay, so here bag name employee by. So from employee bag, which column you are trying to apply join. Okay, department number, then which bag which join you are applying, left outer join, and then right side bag name also we have to specify, right? dept. From dept, based on which column you want to apply join, department number. So here also department number, here also department number. Okay, and here this results I'm storing into bag A. Okay, join. Okay, so starting we have to specify join. Okay, so bag A join. Join you are applying on which bag? Employee. From employee bag based on which column? Department number. And which join you are applying left outer. And then bag B, department bag by department number. Okay, dump A. Left outer join, left side all the rows, opposite side only matched records. So here opposite side department number 22 available, but 22 not retrieved. Why? Means left side table 22 department number not there, that's why. Okay, so left side all the records populated. See, if you see wherever department numbers matched from both the bags, all those records are displayed, but a department number 22 also there not displayed because 22 not available in left side bag. So this is about left outer join. So similar way we can apply right outer join. Okay, so here just we have to specify right. So right outer join means now it will show department number 22, but left side 21 is there. So 21 it will not show. Okay, dump. Yeah. Okay, see department number 22 displayed because right side bag, right outer join. Okay, and 21 not displayed from left side. Okay, so this is about right outer join. Okay, and then a full outer join. So here we have to give full. So full outer join means right side bag and left side bag, all the records it will display all the records. Okay, see department number 21 and 22 also displayed. So this is about a full outer join. Now inner join. So here you no need to specify anything. Okay, just dump here. Inner join, both sides only matched records, matched department numbers. Okay, see here 21 22 not displayed. So both sides wherever department numbers matched, only those records are populated. Okay, so this is your left side bag record. This is right side bag record. Okay, so this is about uh, these four joins. Okay, now we'll see how to apply join on multiple columns. So we have two common columns. Okay, so we have department number and the salary also available in both the bags. Okay, from department by also here also salary I'm specifying. Okay, salary. So that means join I'm applying on two columns instead of single column. I'm applying on two columns. So wherever, so both sides department number should match, salary also should match. Okay, because inner join we applied. Okay, see here department number 20 matched from both the bags and salary also matched. Okay, so this is about joins. Now we'll discuss about advanced joins. Okay, so first we'll discuss about a replicated join. When we'll use a replicated join, okay, basically it will improve performance. Okay, so basically all these three advanced joins while retrieving it will improve performance. That means it will give fast results. Okay, but a replicated join, okay, it is a special join. Okay, for example, you have employee bag. Okay, employee bag contains more data, but department bag contains very less data. Okay, so when you try to apply join on these two, generally backend mapper and reducer will run. Okay, so if only mapper involved means the performance will give very fast, but reducer involved means it will take time. Okay, so replicated join generally what it will do, when you specify while writing a join query, if you specify replicated means this less data related uh, bag related data, it will put into memory. Okay, so you have data nodes, right? A number of data nodes. Okay, so inside RAM memory, it will keep this bag related data, so that only mapper will involve. Okay, so performance will increase. Coming to Sqoop join. Okay, so Sqoop join also special join, and generally people will call advanced join. Okay, and here why they implemented Sqoop join means, for example, bag A, you have 5 columns. Out of 5 columns, only one column more data is there. Maybe you can assume country column. And here bag B. Bag B also country column is there, but very less number of records. So when you are trying to apply join, okay, see here less number of records, but there more records. That means more records means that column it has to each and every record it has to scan, right? So it will take time. So if any column, if you see like this, one bag less number of records, another bag more number of records in that particular column, if you apply skewed join, it will give fast performance. And coming to merge side join, if your bag already contains data, right, so that data already in a sorting order, then you can specify merge side join. So again backend it will not apply any sorting, so that time will save, it will give fast results. This is about advanced joins in pig. So now practically we'll see. Okay, so here all advanced joins. Okay, end of your query you have to specify using keyword and then within a single quotes your join name. So if you are trying to apply replicated means you have to specify here replicated. So here we are just entering only one keyword, but backend that big framework it will take care about the performance. That framework will take care. Okay, and the same time here you can specify if you want to apply Sqoop, you can apply Sqoop. So using is common, using keyword is common. After that, if you want to apply replicated, you have to specify replicated join. If you want to apply Sqoop join, you just specify Sqoop word. Also, last one merge. Okay, so this is about joins. Okay, so even if you give dump a means it will retrieve a result. See here in our system there is no large data. Okay, but in a real time it will give a good performance. Okay, so this is about joins. Next concept is sensitive or insensitive. So here first point, all the bag names are case sensitive. See, while creating bag, if you specify capital A, while retrieving also capital A. If you specify small a, while retrieving also small a. And second point, all the keywords case insensitive. So keywords means we use right a few keywords. Okay, so load also keyword, using also keyword, filter also keyword. Okay, and the limit also keyword, order. Okay, so these all case insensitive. Okay, and the third point, all the column names are case sensitive, and all the string functions and aggregate functions case sensitive. Okay, so substring, concat, these all you have to specify capital letters. Okay, so always we have to keep in mind these 4 points. What all are case sensitive, what all are case insensitive. Optimization techniques. So optimization techniques basically are to improve query performance. Okay, apply filter as early as possible. So if you apply filter, see you have 1 lakh records. If you apply filter or where condition, it will reduce size, right? So if you give like a salary greater than 70,000 means out of 1 lakh records, maybe 20,000 or 10,000 records it will filter out. Then on top of that, if you apply some conditions, so it will give fast results because you are not applying conditions on 1 lakh records, just that 20,000 or 10,000 records. Okay, so apply filter as early as possible. Apply split also as early as possible. Okay, apply joins as late. Okay, as late as possible. So that means joins we have to apply very late because large data if you apply join it will take more time. So joins always you have to apply on less data. Okay, also apply limit as early as possible. See, based on your requirement, you have to take care of these 4 things. Then performance will increase. So these are basically optimization techniques. We'll discuss about 3 concepts. Okay, one is a group, and the second one is a co-group. Okay, and the third concept word count program. So group, we know, right? Okay, so whenever you want to apply group on specific column related, okay, then we can use a group. Okay, so if you apply on department column, then each department it will group. Okay, then why co-group is required? Okay, so initial versions basically group supported to apply on single bag or single relation. Okay, so inside that single bag you can apply on any column. Okay, so co-group, whenever you want to apply group on multiple bags, then you have to use a co-group. But in the latest versions, group also it is supporting to apply on multiple bags. Okay, so generally in the interviews they will ask what is the difference between a group and a co-group. Okay, so group it will allow you to apply on a single bag in older versions, but latest versions it is allowing to apply on multiple bags. Okay, co-group it will allow you to apply on multiple bags or relation. So practically we'll see how to apply a group and a co-group. Okay, so for that first we need data files. Okay, cd data ls. Okay, so first I will take this csv file. Okay, so at owners.csv. Okay, so here in this data file I have 2 columns. Okay, this is owner names, first column owner, second column animal name. Okay, so if you want to apply group, first we have to create a bag. Okay, so what I will do with this data, I will create a bag. Now here I will create a bag name owner, or I will give owners. Okay, so load data available under home Cloudera data, then owners.csv, then using big storage. So here data separated by comma. Yes, first column name owner data type array, second column animal data type char array because characters. Okay, so successfully I have created a bag. Okay, now I want to group this animal column. Okay, grouping equals to my bag name grouping equals to group you are applying on which bag? Previous bag, owner's bag, by on which column? Animal column. Okay, then dump grouping. Okay, so see here cat related one group. These two are 2 different rows, right? It is applied one group. And again a dog, so this animal related one group, and again fish related one group. Okay, so this is about group. So if we want to apply co-group, we need 2 bags, right? Okay, so one bag will consider owners only. Okay, and the second bag will create now. Okay, so second bag we need again a data file. So here cat gets.csv. Okay, so I have one more data file, that is pets.csv. Okay, so for this I will create a bag. Okay, so here pets, my bag name is pets equals to load. So data file path we have to give here, then file name pets.csv. Okay, using big storage, so data separated by comma. As first column owner only. Okay, second column animal. So care here. Now I have two bags, right? So owner's bag and pet's bag. Okay. So co-group I will apply on both the bags. So we have one common column, right? Animal common column. Okay. So here co-grouping my new bag name. So co-group you are applying on which bag? So first bag name I will specify here owners. From owners bag based on which column? Animal. And then the next bag name pets. From pets bag which column? Animal. So from both the bags it will apply co-group on animal column. Okay. Some co-grouping. So here if you see cat related single group. Okay. So these two from first bag, owner's bag. These two from second bag, pet's bag. Okay. So all cat related one group. Again dog related one group. Fish related one group. So this is about and co-group. Okay. Now third concept, word count program. Okay. So basically this word count program, why we have to use in real time? Okay. See, for example, if you post a video in YouTube, okay, so maybe uh, movies related they will release generally teasers, right? 10 seconds or 50 seconds. So for that video, many people generally they will give comments. Comments means like uh, good or bad, average, like this. They will give comments. Okay, so they will read comments, only comments, all the people related comments they will read. Based on that they will review and they will apply word count, like how many people given good, whether 500 members or 1000 members. Again bad word count. Okay, so how many people bad rating, and how many people commented average. Okay, so based on this they will give even review. Okay, so here I will give small example for word count. Okay, so I have one unstructured data. Okay, so maybe this is RR digital. Okay, and this is Hadoop session. So basically this is unstructured data, right? It is kind of a paragraph, not structured data, because first row 3 columns but second row 4 columns. So this is unstructured data. Okay, so for this data I want to apply word count, like this how many times repeated. So how many times repeated? 2 times. Okay, and is how many times repeated? 2 times. And RR digital 1 time, and Hadoop 1 time, session 1 time. So I have to load this data. At the end output I want like this. So each word how many times it is repeated, that I want to count. Okay, so for this we'll write logic, okay, using a pig. So same logic if you want to implement in MapReduce model, 3 Java classes you have to write. There it will take more time, okay, but here within 4-5 lines you can complete within 2-3 minutes. Okay, so now we need first a data file, right? I will create a new data file, okay, with this 2 records at greater than here word count 1.txt. Okay, control C. Okay, so here word count 1.txt. Okay, so now grunt mode here. For this we have to write a program. Okay, so here lines, so my new bag name lines. Okay, load, so we have to load the data, right? First home Cloudera data under data word count 1.txt. Okay, yes, so this is paragraph kind of. Okay, so I'm assuming that only one column for entire data. Column name line. Char array. Why char array means it will support numbers and characters. So here all words only, right? So we have to use a char array. Okay, so here I defined only one column because this is unstructured data, and also my bag name lines. So that means now this entire data available in this bag. Okay, and then for each you are applying on which bag? Previous bag. Lines generate tokenize of your column name. So previous column contains the data. So previous column, this one, right? Lines bag contains only line. Okay, so this result we have to write. So for that I have to create a new bag. So tokens, my new bag name tokens. So dump tokens. So we'll see results. Okay, so what is the use of this tokenize? Okay, that built-in keyword that we'll see now. Okay, so each word it is separated. Tokenize keyword, each word it is separated. Okay, now next query flats, my new bag name flats. Okay, for each, so previous bag name tokens, so I am applying for each on previous bag tokens. Generate, okay, here flatten off. So previous bag there is no column name, only first bag contains a line column, but second bag no column, we have not defined any column. That means column name $0. Okay, so flatten. See, from tokens bag only one column we have not specified. By default backend it will assign $0. This already we discussed. Okay, now flatten what results it is giving. Okay, dump flats. So what is the use of flatten keyword? So flatten keyword, all the words it is placed as a single column. Previously our data row wise, but now single column wise. Okay, so use of flatten means it is arranged one by one, all the words one by one. That means single column. Next we have to apply group. If we apply group, then only each word how many times repeated that will come to know. Like a group we have to apply on that column. Okay, so here, so if we apply group, this related all one group, is related all one group, like that it will arrange. Okay, so groups equals to group you are applying on which bag? Previous bag. Okay, previous bag flats. okay, by which column? So we have only one column, right? That is $0. So sum groups. So now all each word related one group it will apply. This related all the words one place, and is related like that it will apply. Is related all one group. This related all one group. Hadoop related one group. So now this first column related words we need as it is, and this position related we need count. So is how same word how many times repeated means 2, and here also this 2. So counts new bag name counts equals to for each you are applying on which bag? Previous bag name groups. Generate. So first column we need as it is, that means $0. Second column we know, right, what that second column $1. Okay, so $1 related values we have to apply count. So count of $1. Okay, so dump counts. Okay, so here we got output, right? Is word how many times repeated? 2 times. This word 2 times. So whatever output we expected here, same it is generated. Okay, so this is about word count program. See, we just used a total only 5 queries. So this is first query, and this is second query, and this is third query, and this is fourth query, this is fifth query. So LTFGC, if you keep in mind, L means lines you have to apply here column name. Tokens means you have to apply tokenize keyword. Flats means you have to apply flatten built-in keyword. Groups means you have to apply group for that query. Counts means for this query you have to apply count. So if you keep in mind LTFGC means easily you can implement. Okay, so even if it is a large data file also you can use the same technique. Okay, so word count program to implement in Pig, just 5 lines code is required, but same if you want to implement in a Java, minimum 150 or 200 lines of code you have to implement. Okay, so this is not only word count program, even unstructured data also we processed here. See, first we have seen text files last 3-4 sessions. After that, today CSV files, again this unstructured data. Okay, so this is about word count program. I will discuss about Apache Hbase module. So this Apache Hbase module initially came from Microsoft company. Later Microsoft handed Hbase module to Apache company. Okay, so basically this Apache Hbase module implemented on top of HDFS module. Okay, so backend at the end it will store data inside HDFS only. So this Hbase module like most of the telecom domain companies and retail domain companies, okay, and social networking companies, so they are using this Hbase module. Okay, so for example, if you consider telecom domain companies, okay, to store audio recordings, okay, so call detail records, so what they will do, generally they will process that recordings, okay, so audio files using web services, Java web services. At the end, that web services framework backend it will connect to Hadoop HDFS. Okay, so inside HDFS, call detailed records it will store. So here we have few topics. Okay, so introduction to Apache Hbase. So first I will cover about introduction, and then Hbase data model means Hbase architecture, and then Hbase shell. Shell means here practicals. Okay, so queries I will explain. Okay, so how to write Hbase queries and how to enter into Hbase command prompt or Hbase shell mode. Okay, so those all I will explain, and also how to connect a Hive module from Hbase, how to update a record in Hive. Okay, so using Hbase you can connect to Hive and you can update a specific table related record in Hive. Okay, because initial Hive versions, Hive was not supported by DML commands like update, delete, not supported. So at that time, many projects using Hbase, they connected to Hive table and they updated records. Okay, so that concept also important concept I will explain. And introduction to Apache Hbase. Okay, so basically Hbase is a open source. See, in Hadoop, all the components are modules open source only. Okay, like Hive or Pig or Sqoop, all components are open source only. Okay, and distributed. So distributed means backend we used HDFS, right? So basically our data it will distribute into different data nodes, different machines. That is called distributed. So sparse means here it will not allow you to store null values or empty values in Hbase. See, basically Hive, if you not pass any value for a specific column related, then it will allocate space, but null or empty it will store. Okay, but here Hbase generally it will not allocate any space and it will not allow you to insert any empty or null values in Hbase. That is called sparse. Multi-dimensional. Okay, so multi-dimensional means basically in a Hbase backend it will store data in a key value pair format. Why key value pair format means here if you store your data in key value pair format, storage and retrieval will be very fast. Okay, so that's why by default in a Hbase it will store data in key value format. And sorted. Okay, so basically sorted means in a Hbase, okay, by default whenever you are trying to insert your data, it will apply in sorting order. While inserting itself, it will apply sorting. Also, whenever you are trying to retrieve the data, that time if you look up using a key, then it will be very fast retrieval. Like based on key, if you try to retrieve a value, then it will be fast. And a map, we know basically map it will be associates keys to values. So each key it will map to values. And persistent. So persistent basically in a HDFS, once you've written your data, that will be available until you remove. Okay, so Hbase is basically a column oriented database on top of Hadoop they implemented. See, column oriented database means basically we have RDBMS, right? So RDBMS basically data it will store row wise. Okay, but in a Hbase data it will store column wise. That is called a column oriented database. Okay, how it will store column oriented, that later I will explain. Okay, and here row key. Okay, so row key is mandatory whenever you are trying to insert your data in Hbase. Okay, compulsory row key is mandatory. Okay, so without row key it is not possible to insert your data inside HDFS or Hbase. So this row key basically it will work like your primary key. Okay, and the column families. Okay, so in terms of columns families means basically in a Hive we have a queue name or database names, right? Okay, so one database contains n number of tables. Okay, so here whenever you are trying to define any column, compulsory you have to define a column family name. So that particular column is belongs to which column family, that you have to specify here. Okay, and coming to versions, qualifiers I will explain later. Versions, so basically here employee name column is there. Okay, employee name column, so I inserted employee name value as Ram. Okay, so in Hbase first value it will consider as v1 version v1, and again maybe after some time I updated a value for employee name. Instead of Ram I updated Sam. This is called v2 version, second version. So like this backend it will create uh, versions. Okay, so this is a v3 version. Okay, so backend it will keep all the versions. Okay, but default number of versions by default 3 versions. In case while creating a table, if you not specify versions, then by default 3 versions it will store in Hbase. And now if you assume fourth value I updated, instead of Harshit again I updated one more value. So now backend what it will do, it will remove this. Always it will keep only latest 3 versions related data. Okay, so this is about versions. So whenever you are trying to retrieve the data, by default it will read v4 version related data latest. Okay, in case if you want old versions related data, then you have to specify in query, then only it will read whether last 3 versions related data or last 2 versions related data. Okay, so this is about versions. Next, automatic partitioning. See, backend Hbase will take care about partitioning. Here manually you no need to specify or create any partitions. Okay, so about the scalability we already discussed in a HDFS module, right? So whenever you want, you can increase capacity or you can decrease capacity, because Hbase also implemented on top of HDFS only. Okay, and columns. So in Hbase there is no limit, you can create n number of columns. Okay, and a cell we know, timestamp. See, timestamp basically what is the use of a timestamp means whenever you are trying to insert a record, okay, it will update a timestamp. So this timestamp column we no need to create. Backend your Hbase framework will create this timestamp column in that particular table. Okay, so what is the use means, for example Ram updated at 4 a.m. Okay, so that information it will insert, and again v2 version what time exactly updated. Okay, now when user trying to retrieve latest value means it will compare timestamps. So which record updated what time, based on that it will come to know, right, which is latest version and which is second latest version or which is third latest version. So that is the use of timestamp in Hbase. And Hbase overview. So basically Hbase will call a Hadoop plus NoSQL database. Okay, because here column wise we are storing the data, and at the end our data it will sit inside a HDFS. Okay, so Hbase also basically from Apache company, and it is a open source project from Apache company, and used to provide a real-time randomly you can read your data or you can write your data. Also compared to Hive, here you can process very large tables like billions of rows or millions of columns on top of your commodity hardware. Okay, so here we have HDFS. If you use a Hbase module, or if you use a Pig, or if you use a Hive, any module, at the end your data it will store inside HDFS only. Okay, so RDBMS row oriented, row wise it will store. Even Hive also row oriented, but only your Hbase it is column oriented. Okay, so Hbase is built on top of a HDFS. Also Hbase files are internally where it will store means inside HDFS. So next concept, Hbase plus a Hadoop offering. So Hadoop offerings we already discussed when we started HDFS module. Okay, so we discussed about the fault tolerance and the scalability, and backend how mapper and the reducer will involve. Okay, and Hbase basically randomly it will read your data and writes. Also high throughputs means more number of records it will insert in less time. Okay, so it will not take more time to insert more records. So basically Hive it will take more time, but in a Hbase it will insert your data very fast. That is called high throughputs. What is the difference between Hbase and HDFS? Okay, so Hbase we know built on top of HDFS, and it will provide a fast record lookup for large tables. And HDFS basically it is a file system. Your data it will store inside HDFS, and it does not provide a fast individual record lookup. And in HDFS data it will store in flat files, but Hbase your data it will store in a key value pair format. Also column wise it will store your data in Hbase. Okay, and next Hbase it is a NoSQL database. So generally basically people will call that Hbase is a NoSQL database. Okay, also that runs on top of a Hadoop cluster, and it will provides a random real-time read or write access. HDFS good for sequential data access, and record level insertion Hbase is supporting, but HDFS not good for a record level insertion or incremental addition of existing data. Also Hbase supporting for updates. Updates means if you want to update a specific record, Hbase is supporting, but HDFS not good for updates. So Hbase is not a traditional RDBMS, so like it will not work like your RDBMS. Okay, so Hbase is completely different. So data layout in RDBMS row wise it will store, right? But in a Hbase column oriented, column wise it will store your data. And transactions, so RDBMS it is supporting online transactions. Okay, yes. Here Hbase single row. And a query language, basically RDBMS will call structured query language SQL, but here we'll call NoSQL DB. Indexes concept RDBMS is supporting, but here row key we have to consider as indexes are primary key. Maximum data size RDBMS terabytes it is supporting, but your Hbase petabytes plus it is supporting. So compared to RDBMS, Hbase is supporting maximum size of data. And read and write throughput limits. Okay, so here for second RDBMS 1000 queries it will insert, but here for second millions of queries. Okay, so if you use a large cluster, if you are using a supercomputer, then millions of queries it will insert. And the data, RDBMS is good for only structured data, but Hbase supporting to process semi-structured data as well as structured data also. So about null values we already discussed, right? So in a Hbase, good with the sparse tables means it is not generally it will not allow you to insert null records, but RDBMS are not optimized. It will allow. How it will store column wise in a Hbase? How your data it will organize as column oriented. So here this is row wise. Okay, so you can assume this first table Hive, and this is the second table your SQL RDBMS, traditional RDBMS, and this one your Hbase. Okay, so here first row, if you see serial number here 1 or ID. Okay, and here some URL. Okay, this is ID, again name. Okay, so here also data stored row wise only. So same here, if you see Hbase home, here also Hbase home. Okay, so this same row wise data here it will insert column wise. So here Hbase Apache, here it is there. Again here 3 of G4J, see here column wise, and again here Hbase home. So in RDBMS or Hive, generally data it will store row wise, but here same that row wise data here it will store in column wise. That's why basically Hbase will call as a column oriented database or NoSQL database. So Hbase data model, coming to second topic, Hbase data model. So here every row has a row key. So row key is mandatory. Okay, so to recognize a row, here row key is mandatory, compulsory. We have to consider one column as a row key. Also, rows are sorted by row key for fast lookups. Okay, also rows are sorted on insert. Okay, so this already we discussed, right? See, when you are trying to retrieve the data, that time it will not apply sorting order. While inserting data into Hbase, that time itself it will apply sorting. Okay, here scan means basically to retrieve data, here we'll use scan command. That's why not during scan means not during a retrieval time. So while inserting data itself, it will apply sorting. And selecting appropriate keys for your application is critical for performance. See, in a Hbase, if you are trying to read your data based on key, if you apply, it will give fast performance. Results will give fast retrieval. Or if you are try with a different column, it will take more time. Okay, so based on key, if you retrieve, it will give good performance, because in Hbase backend your data it will store a key value pair format. And the timestamp of an Hbase cell. So about timestamp we discussed, right? Whenever you are trying to insert a record in a table, that timestamp column your Hbase framework will take care, and what time exactly we inserted that particular record, that time it will update. Based on that, whenever you are trying to retrieve specific version related data, then a timestamp will help you to retrieve. Okay, so here Hbase column family attributes. Okay, so in Hbase we have few concepts. By default your framework will take care. Compression technique. So compression backend it is supporting none, gz, lzo, snappy. Okay, so if you not specify, by default it will consider none. And versions, default one version, it will possible versions 1 plus, like n number of versions, but a default number of versions 3 it will consider. And a block size in a HBase, block size 1 by 2 2 GB, 1 by 2 2 GB. Default block size 64 KB. Okay, and in memory true false, by default false. Okay, if you want you can enable true. Block cache true false, by default true. Okay, so this basically whenever we need, then we can enable this true or false. If in memory concept is required, then you can make it true. And block cache anyway we no need to do, by default to true. Versions, while creating a table we have to specify, in case if you need more than 3 versions, then you have to specify. If you not specify, by default it will consider 3 versions. Compression means basically, see, backend it will apply zip and unzip, right? So if you zip your data, size will reduce, right? Okay, so that your storage, HDFS storage will save. Okay, so designing tables. Okay, so for example here we have client. Okay, so client have one record. Okay, so that record, if client want to retrieve, okay, backend these two, basically you can assume HDFS. Okay, your data is there in HDFS. So first it will check which column is related to which column family. Okay, so if column family 1 related means it will send here, from here it will go to HDFS, from there it will read your data. If specific other column is related to your column family 2, then it will go to here, and from here it will read your data. So you people will get more clarity when we start explaining HBase architecture. Okay, Hive disadvantages and HBase advantages. Okay, when we process terabytes of data, at the time Hive process will be very slow. That is one drawback in Hive. Also, Hive doesn't support DML commands in older versions. Okay, even still now also many companies, they are not using DML commands in a Hive model. They are using some other models. And a HBase advantage, HBase is basically alternative for Hive, and also it will run on top of HDFS. Also another advantage, backend it will store your data as a key value pair format. Compared to your Hive, Hbase is 10 to 12 times faster if you are processing terabytes or petabytes of data. See, your data size is Gbase or Mbase, then not much difference between Hive and Hbase. But if you are trying to process a large data, terabytes or petabytes of data, that time it will give 10 to 12 times fast. Also, Hbase supporting updates. So if you want, you can update specific record or specific value. Also, we know, right, there is no space wastage in Hbase because null values it doesn't allow you to store. Also, by default, Hbase storing 3 versions of data, right, like 3 old versions related data. Or if you want, you can increase the 6 versions or 10 versions. We'll discuss about Hbase architecture. So earlier we discussed about HDFS architecture and Hive architectures, right? So similar way in Hbase we have one architecture. From Hbase architecture, two important nodes we have. Okay. So one node it will be added to the master node. Okay, and another node they added in slaves. So here if you see, name node, map reduce job tracker, and a secondary name node. These all basically HDFS master nodes. Okay, so along with these three, from Hbase, they added one more master node, that is a Hbase master node. So this node, if they are using Hbase, then only this will be available in cluster, in their project or their cluster. If a Hbase component available, then only this master node will be available. Okay. If they're not using, then this master node won't be available. And coming to slaves also, in HDFS, we have data nodes, n number of data nodes, and each data node contains a task tracker, right? Okay, so basically from HDFS, these two we are calling as slave nodes. Okay, so if Hbase is there, means one more new slaves is available, that is a Hbase region servers. So basically this Hbase region servers will come under slaves, and the Hbase master will come under master nodes. So if Hbase component available in your cluster, means two nodes extra will be available along with your HDFS nodes. So this is Hbase architecture here. Okay, so here client, so client means maybe you or your job. For example, I am trying to store the data, so that means I am the client. Or maybe you scheduled one job. Okay, so daily so on so time that job automatically it will execute, then that job will call as a client. This client, if any request will come, then it will connect with HMaster. So to connect with the HMaster here, Zookeeper, basically it is a mediator between your client and HMaster. Also, Zookeeper always it will track all HMaster related and H region. Okay, these both are active or not, these both are running or not. Okay, so these kind of monitoring activities also Zookeeper generally it will take care. Okay, so whenever some request will come from client, then this Zookeeper will accept that request, and same request it will pass to HMaster. And again, whenever this HMaster will give response back, then that response it will take from HMaster, then Zookeeper will pass that response back to client. So this is about Zookeeper and client. Now, what is the use of this HMaster? So basically this HMaster is master node, right? So in a Hbase architecture, this HMaster it will store your Hbase tables related metadata. Which table related data available in which region server, or which region, or which data node. So all this information available in HMaster. Basically, this is like your HDFS. We have that name node, right? Okay, so similar way here HMaster for Hbase HMaster. Okay, so if you want to retrieve any data, or if you want to store data using Hbase, compulsory HMaster we have to contact. So who will help us to connect with the HMaster means Zookeeper. So now if you have data file, if you are using a HMaster, okay, then immediately that request will goes to HMaster. Then HMaster will assign a region server. Okay, so here if you see H region server, so basically in real time parallelly we have multiple region servers. Okay, so these region server it will so each data node contains one H region server. Okay, like HDFS we discussed, right? Each data node contains one task tracker, individual task tracker. Okay, so here also each data node contains one H region server. So if you have n number of data nodes, then n number of H region servers. Okay, so this H region server, okay, whatever data it will come from HMaster. Okay, so that data it will like if it is data insertion like a read operation or write operation, or it is a delete operation. Okay, so those operation related requests, this H region server, it will assign it to H region. Yeah, so here H region is there, right? So this region server, it will assign it to H region. So we have n number of H region servers, and inside that H region server, H region also available. Now this H region, it will store your data in a H file. So H file, that is basically temporarily your data, it will store inside H file. But whenever this H file is going to full, like this memory is going to full, then it will send that entire data to data nodes. So this DFS client, what is the use of a DFS client? See, basically DFS client, it is mediator between your data node and a H region server. Okay, see, both will run in same machine only. Okay, but this is basically built-in jar file, DFS client, built-in framework or jar file. Okay, so this jar file, this client, it will help you to connect with your H region server and data node. So whenever this H file want to push data to inside a data node or HDFS, then this DFS client will help. So reading it will help, and writing it will help both. Okay, whenever you want to store your data also, it will help, or whenever you want to read also, this DFS client will help. So once this data, it move to data node, then here again a space will be free, right? So whatever new data will come, again it will keep here. Okay, after some time again it will full, right? Then again it will flush to data node. Okay, so all these H files will work like that only. Okay, so it will keep till that memory is full. Once that is going to full, then it will flush to inside data nodes. Coming to memstore. Okay, so memstore basically always it will keep new data, latest data. See, we discussed about one version related data, it will keep in HDFS. Okay, but HDFS doesn't support updates, right? Okay, instead of some value, if you want to update different value, HDFS is not supporting, right? So that V2, V3 related updates, it will keep in the memstore. So this HMaster knows that where is V1 version related data and where is updated data. So HMaster knows that, okay, V1 data available in HDFS and V2 or V3, V4 available in memstore, because HDFS doesn't support updates. That's why this memstore always it will keep updates related information or data. So this is about Hbase architecture. See, also here we have H log, right? Okay, so this H log, generally it will generate log files. Also, whenever when you are trying to execute your job, okay, if any kind of errors or logs, okay, so those also this H log will capture basically. We'll discuss about Hbase commands. Okay, so before executing Hbase command, so first we have to enter in Hbase shell mode. Okay, so for that we have to enter command Hbase space shell. Okay, so this is the command which will take you to the Hbase shell mode. Okay, so successfully logged in Hbase mode. So here we can see Hbase version 1.2.0 and Cloudera version 5.13.0. So first we'll check what are tables available in Hbase. Okay, so to check existing tables, we have to use list command. Okay, so here it is showing only a DEPT table. Okay, so only one table available, that is a DEPT. And also if you want to check which user logged in, okay, then you have to give command who am I. Okay, so here it is showing Cloudera user logged in this console, and this particular user belongs to Cloudera group and the default group. Next, how to create a table in Hbase. Okay, so create table name, employee, okay, and the column family name. Okay, so this particular table belongs to which column family? Okay, so create table name employee. Okay, and column family name here CF1 I am giving. Okay, so before creating a table or while creating a table, compulsory we have to specify column family name. Okay, so table successfully created. Using a list command we can cross verify. So here it is showing employee table. So we have created table, but we have not specified any column names, or we have not inserted any data. Okay, now we'll insert a few records. So before inserting, if you want, you can describe a table. Okay, so this is the command describe table employee. Okay, so here it is giving information. This particular employee table is there in enabled mode. Okay, so here we have two modes, enable mode and a disable mode. Okay, so here it is showing it is enable mode. Column family name, which we defined, that it is showing here CF1. Okay, so these are backend by default it will provide this information. Okay, these are the default configurations. Okay, so now we'll insert data. So to insert data we have to use a put command. Okay, put employee, then row key is mandatory, so row key 1 I'm giving here, and then which column related data you want to insert, employee name. Okay, so before column name, here we have to define column family name. Okay, and then employee name related value. Okay, so here I am giving Ram. Okay, so successfully inserted one record. Okay, so after inserting, how to retrieve the data from Hbase table? So for that we have to use scan command. Scan in table name. Okay, see here it is showing one record. Okay, and column family name, employee name, and value we inserted as Ram. Okay, and this timestamp, what time exactly we inserted. So we have inserted only one column related, but the same row, same record, I want to insert another column related data. Okay, so maybe salary related data also. Okay, so here maybe 5,000. Okay, so this row key is same. Okay, so row key is same means we are inserting record in for a same. Okay, it is not different record. If you give here 2 means that is different record. Okay, but you are giving existing row key, that means this is a new column value we are inserting into existing row. So successfully inserted, and again using the scan command we can check. Okay, so here it is showing only one row, because yes, only one row. Employee name and salary both are different columns, but a single record. Okay, single record contains two different columns related data, employee name and salary. I will insert a different row. Here I am giving row key 2. Okay, scan employee. See now here it is showing two rows. Okay, because these two single record, this one single record. Now how to retrieve specific row key related data? Okay, so here get, and then table name employee, and then row key. Okay, So row key 1 related data you can retrieve. Okay, see, successfully retrieved row key 1 related. Okay, so using get command you can retrieve specific row key related data. If you use scan, by default all the records it will show. Okay, but based on a row key, if you want to retrieve data, you can use a get command. Okay, and if you want to check how many records are there in employee table, then you have to use count and then table name. See, here is given count, right? Only 2 records are there. I want to check table is there in which mode. Okay, so here is underscore enabled and then table name. So it is giving a true because our table is there in enable mode. See, whenever generally we create a table, by default it will be enable mode. You can try disable also. Disabled is underscore disabled. What it will give? False, right? Because it is there in enable mode. Now I want to disable this table. So disable, then table name. Table disabled. Now you can cross verify is underscore enabled. What it will show? False, because disabled. And is underscore disabled, what it will display? True. Okay, so table successfully disabled. Why we have to disable table? So whenever you want to hide your table related data to others, then you can disable. Okay, so now if you try scan command, it will not give result because it is there in a disable mode. Okay, that's why it will not give results. Now you can enable. Okay, and then you can try scan command. Okay, enable. So now table is enabled, so it will retrieve the data now. Okay, so basically this is about enable and disable. Okay, how to drop table? Drop or truncat. Okay, so drop table name employee. Okay, so if you want to drop table, first you have to disable. So disable table. Okay, table disabled. Now drop. Okay, so successfully dropped. See, list, it is showing only department table. There is no employee table. Okay, so now we'll create again a table. Okay, so here I will specify versions also. Okay, okay, table created and I specified 3 versions. Describe table name. So here it is showing 3 versions. Okay, now we'll insert data. Okay, so using a put command we'll insert a data using a put command. Okay, so here employee name I am inserting. Okay, name Ram. Okay, so this is v1 version related data. Now instead of Ram I'm updating Sam. Now again instead of Sam, Ramu. So in Hbase it will store last 3 versions related data. Okay, scan employee. But when you use a scan command, always it will read only latest value, not 3. Okay, so here scan employee, then versions here 3. He successfully retrieved last 3 versions related data. Okay, so if you update a 4th value instead of Ramu, again if you give Ram1 means now it will give only 3 So first value, this one it will remove, always only latest 3. Okay, backend also it will keep only latest 3 values related data. Now how to truncate table. Truncate table. So truncate means data it will remove, but table it will keep. Okay, so here you can check a list. It is showing employee. Okay, but data scan employee, because we applied a truncate. Okay, so data removed. Okay, so status simple. Okay. So generally this status command Hadoop admin team will use. Okay, so whenever they want to check a cluster related or HBase related information, so what all are nodes running backend and the server is live or not, how many backup servers are running. Okay, so that time they will use this command status simple, and also here it is showing how many number of regions also running. Okay, and instead of simple summary also you can try. Summary just what it will give, how many servers, how many dead, how many are active, how many are running, like that. Okay, and the next one detailed. Okay, detailed means if each region server related all the information it will show. Okay, basically this information required only for a Hadoop admin team. Okay, for developers it is not required, but just knowledge purpose I explained here. Okay,
Please subscribe our channel for more training related videos.
we are going to discuss about Hbase managed Hive table. So Hbase managed Hive table, this is basically important concept in Hbase module. Okay, so earlier Hive 0.14.0 version, Hive not supported
DML statements like
delete, update, those commands not supported. Okay, so that time most of the projects using Hbase, they can connect a Hive model, and inside a Hive model you can connect a specific table and you can insert your records from Hbase to Hive table, or you can update records in Hive, or you can delete records from Hive. So this concept we are calling as a Hbase managed Hive table. So now we'll see how to implement this concept. Okay, so here we have to follow some steps. So step 1, we have to add all these supporting jar files in Hive prompt. Okay, after that, second step, we have to create a temp table in a Hive. Then we have to load data into temp table. And fourth point, we have to create Hbase managed Hive table. Okay, so when you create this Hbase managed Hive table, same table it will create in both the places. Like Hive side also it will create, and same time Hbase side also it will create. So we have to verify table created in Hive and Hbase. And the next point, insert data into managed table from a temp table. So here we have created temp table, right? So this temp table contains data, right? Same data you can insert into this managed table. So when you insert this data, Hive side also it should insert, and same time Hbase side also data inserted or not, that we have to verify. And next, Hbase side, same table you can insert a new record. Same new record, it is inserted into Hive or not, that we have to check. Okay, and the next, update record in Hbase. Same changes, it is reflected in Hive or not, that we have to check. So here concept is, using Hbase you can update records in Hive or you can modify records in Hive. Okay, same time using Hive also you can reflect data in Hbase. Okay, now we'll follow one by one. So first step this one. Okay, so add jar, all the jar files. Okay, here if you are using Cloudera 5.14.0, then you can give 14.0 jar name. Okay, so in my laptop I'm using 5.13.0. Okay, so here Hive, so I'm adding all the supporting jar files successfully added. So step 1 completed, and the next step 2. So here step 2, create a temp table in a Hive. Okay, so for that we need the data file, right? Okay, so here cd data ls. Okay, so cat, here we need one a data file, hive hbase.txt. So this is the data file. So for this data file we'll create one a table first. Okay, so here this is a Hive, create table, table name, student, student number, student name, student passed out year, student marks, student region. Okay, so region string, row format, delimited, fields terminated by, fields terminated by. So your data separated by space. Okay, so here I am giving a /n. Successfully created table. Here show tables. So student table it is showing. Now we'll load the data into student table. Okay, load data local in path home Cloudera data your data file name hive hbase.txt, hive hbase.txt. Okay, into table student. Okay, so temporary table created and the data loaded or not, that will check now. Okay, so select star from student. Okay, so data successfully loaded. So we have completed 3 steps now. Okay, next fourth step, create a hbase managed hive table. Okay, so we'll see how to create that table. Okay, so here, so now whatever table we are going to create, it will create a table in both the components. Hive side also it will create, same time hbase side also it will create. So create table student 1, so student number, student name, string, data type, student passed out here, and student marks, student region, region. Okay, so all the columns are specified. So these all the columns it will create in a Hive. Okay, so stored by, okay, stored by, here org.apache.hadoop.hive. Then hbase dot hb capital letters hbase dot storage handler store. So here dot not required. So hbase storage handler. Okay. Okay. So this is the package which is available inside Hbase jar file. Okay, so we loaded 4 jar files, right? Inside that jar file, this package available. Okay, so with the properties. Okay, and now here hbase dot elements dot mapping, okay, equals to, because whatever columns here we created, those all just it will create inside Hive, but now we are mapping to Hbase also. Hbase also same columns we have to create, right? Key, comma, so first one student number I'm considering as a key. Okay, then column family name, student name, then again column family name, student year, passed out year, then again column family name, student marks, then again column family name, student region. Because in HBase column, in front of a column name we have to specify column family name. Okay, that's why here my column family name I defined as a CF1. Okay, then EBL properties. Okay, so here HBase dot table dot name. In HBase you want to create a same table name student one or different. Okay, so here I am creating the same only. If you want you can give a different name also, but a Hive side and HBase side both I am giving the same name, student one. Okay, so successfully created. Okay, now Hive side will see table created or not. Show tables student one created. And the same time Hbase also we have to cross verify. Okay, Hbase also student one table created. Okay, now both the components table created. Okay, but we have to load a data, right? We have to load the data from temp table to this table. So here if you see, insert data into manage table from temp table. Okay, so for that here we have to execute one query. Okay, so insert into table student one, you can insert data into student one table. Okay, one, select star from student. So whatever data available in student table, same data you can insert into student one table. Okay, so now select star from student one. Okay, so data inserted into Hive, and we'll verify even Hbase also data available or not. Okay, student one. So Hbase also data inserted. So both the places, both the tables, same data inserted. Okay, so we executed query in Hive, but changes reflected in Hbase also. Okay, now I will insert one new record in a Hbase table. Same record it will reflect in a Hive or not, that will check. Okay, so put student one, then employee number, student number, and the column family name CF1. Okay, student name and value. Okay, so inserted scan. So earlier 20 records, now it is showing 21 records. So here, okay, so in Hbase successfully inserted new record. Now we'll verify same record inserted in Hive or not. Okay, so Hive also it is inserted same record. Okay, so employee name only we inserted, but remaining 3 null. Okay, because Hbase we inserted only one column related data, not other columns related data. Now what we'll do in Hbase, we'll insert here instead of null, it will update here or not, that will check. Okay, so Hbase here. Okay, same record here column. So here I will give 2022. Okay, so now go to Hive. You check. See, previously null, now it is updated. Instead of null, it is updated 2022. Okay, so using Hbase managed Hive tables concept, you can insert or you can update records in Hive using Hbase. We'll discuss about a Sqoop module. So in Bigdata Hadoop, we have different components. So basically, why this Sqoop model came into market and what is the purpose of this Sqoop model? The Sqoop model, it will allow you to connect with RDBMS, any RDBMS, like you can connect Oracle database or MySQL or PostgreSQL, any SQL. Okay, so you can connect any RDBMS and you can import the data from RDBMS to HDFS. It is like import and export purpose. Whenever you want to import some data from RDBMS, you can import, and again you can export data from Hadoop to RDBMS. So in import we have few topics. One is how to import data from RDBMS to HDFS. And the second concept, you can import data from RDBMS to Hive. And third concept, you can import the data from RDBMS to Hbase. Okay, so these are the 3 topics available in import section, and export section we have
Export the data from HDFS to RDBMS, and you can export
data from Hive to RDBMS. So these are the main important topics in Sqoop model. So in most of the projects, they are using only import and export, these two only, RDBMS to HDFS and RDBMS to Hive. But they are not using RDBMS to HBase, RDBMS to HBase, how to import. That concept is available, but in projects they are not using. But here we'll cover that also. Out of these 5 topics, here RDBMS to HDFS, how to import our data, this I will cover. So in this again, first we'll see how to connect RDBMS and how to list out schemas from RDBMS using a Sqoop query, and how to list out tables from RDBMS, and then data importing from RDBMS to HDFS. Okay, so RDBMS to HDFS we'll discuss only with the primary key concept. If RDBMS side one table is there, if the table contains primary key, then how to import a data, that concept we'll see. And then while importing a data from RDBMS to HDFS, how to import data to target directory in HDFS, and how to import a data only specific columns related data. Okay, how to import specific columns related data, and how to import specific condition related data, specific condition related data. So here first we'll see how to connect RDBMS. Okay, so here I'm opening a new window, Cloudera, and then here MySQL -u username root -p. To connect RDBMS, we have to give password also, right? So I given Cloudera as password. So successfully I logged in a MySQL database. So here we'll see what other schemas available. So show databases. So these are the different databases available in MySQL. Now using MySQL, you know how to list out schemas, but using a Sqoop query, how to list out same schemas using a Sqoop query. Okay, so I will write now Sqoop query, Sqoop list hyphen databases, then to connect a database hyphen connect JDBC MySQL localhost. So here instead of localhost in real-time projects, you have to give your RDBMS IP address or alias name, and then hyphen username. So to connect to database, we have to give username and password, right? So here username root and then password. Password here I'm giving Cloudera. Okay, so using a Sqoop query, I list out all the schemas from RDBMS. See, same schemas available here also, and my Sqoop query also displayed same in MySQL. How to check specific schema related tables? Then use retail underscore DB here show tables. Okay, so these all are the tables available in RDBMS. Okay, so now using Sqoop query, I want to list same tables. Okay, so here Sqoop query, so I want to list out tables, specific database related tables. So Sqoop list hyphen tables, then this is JDBC connectivity. Here everything is same, but after your IP address or localhost, you have to specify which database related tables you are planning to list out. So I want a retail underscore DB related tables. Okay, see, successfully retrieved all the tables. Okay, so whatever tables available in RDBMS, using a Sqoop also we can able to list all the tables. So instead of connecting MySQL directly using a Sqoop query, you can list out schemas or you can list out tables. And now here describe employee. So this is the table. This table contains total 5 columns, and this table contains primary key. Okay, so I want to import this table related data from RDBMS to HDFS. So here this concept we completed now, connectivity, and we listed all the databases and tables also, right, using a Sqoop query. Now we are discussing about this concept. So now if table contains a primary key in RDBMS, then how to import a data. So here select star from employee. Okay, so this table contains data, only one sample record is there. So now to import this data, we have to write a Sqoop query. Okay, so Sqoop query will write here. So here Sqoop import. So database connectivity, this everything is same. Even name also, schema name also same, because under retail underscore db only employee table available. After that here hyphen table, which table related data you want to import, employee table related data, and then hyphen fields hyphen terminated by. So we have to import data, while after importing each column separated by something, right? Okay, so here pipe symbol, fields terminated by pipe symbol. Okay, so successfully imported data. So we can see in HDFS data imported from RDBMS or not. Hadoop FS -ls user Cloudera. So with the table name, it will create a directory under user Cloudera. So employee table related data, right? So here if you see employee directory created. Okay, so if you go to employee directory, it will show data file. So one data file available here. Okay, so here, and then if you want to read data means here catch. Okay, so successfully imported data from RDBMS to HDFS. Okay, this topic also we have completed. And next, how to import data to specific directory in HDFS. Here at the end of Sqoop query, we have to specify hyphen target directory. Here you specify your directory. Okay, here I am specifying RR digital is my directory. Okay, so earlier we have not specified target directory. If you not specify target directory, then with this table name it is created a directory. Under the directory data is imported. But now here I specified a target directory. You can import data into this directory. So till here directory available in HDFS, and this RR digital is new directory. So it will create this new directory. Under this new directory, employee table related data it will import. So it is not going to create a employee directory. Instead of employee directory, I specified my own directory. So this own directory it will create. Under this, it will import a data. Okay, we'll execute this query and we'll see. So here it is showing one record retrieved. Okay, so we'll check one record retrieved or not using ls command. First we'll see RR digital directory created in HDFS or not. Okay, so here RR digital directory created. Okay, so now RR digital, under RR digital any data is available or not, that will check. Okay, so here data also available, right? So to read the data here we have to use cat command. Okay, so successfully imported data to target a directory. So this topic also we completed. Okay, now we'll see how to import specific columns related data from RDBMS to HDFS. Specific columns, not all the columns. Okay, only specific columns related data. See, RDBMS I have total 5 columns, but I don't want all the 5 columns related data. I want only first 2 columns related data, employee number and e-name related. So how to import specific columns related data? For that we'll write Sqoop query. Here Sqoop import hyphen table Okay, and then hyphen hyphen columns. Remaining connecting DB, that syntax is same. Hyphen hyphen columns. So which columns related data you want to import? So employee number and then e-name, only these two columns related. If you want another column, you can specify with comma, you can specify columns, but I want to import only these two columns related data from RDBMS to HDFS. Okay, so successfully retrieved. Now we'll cross verify specific columns related data imported or not. So successfully imported only two columns related data from RDBMS to HDFS. So first one, employee number, and then employee name. So now again I will remove employee directory from HDFS. So this concept also we have completed. Okay, and next how to import data based on condition. Okay, so here Sqoop query. Okay, so this column syntax, whenever you want, you just add that syntax, that's it. Okay, so now specific condition. Okay, hyphen hyphen where, here I'm writing condition. We'll insert one more record in RDBMS first. Okay, so insert into employee values, then employee number 2, employee name from, and then phone number, and then salary 15,000, then department number 20. Okay, so select star from employee. Now I will apply condition where salary greater than 5,000. It will import only one record. Okay, so here hyphen hyphen where salary greater than 5,000. Okay, so more than 5,000 salary related data, it will import from RDBMS to HDFS. So based on condition also we can import data from RDBMS to HDFS. Okay, so successfully imported data. So we'll see using a cat command. See, it is imported salary greater than 5,000 related records. Okay, so this topic also we have completed. So RDBMS to HDFS with if table contains a primary key, then all these topics we covered. Who all are not yet subscribed our RR Digital channel, please subscribe and support us. And we'll discuss if table doesn't contain any primary key, then how to import data from RDBMS to HDFS. So if table doesn't contain primary key, then we have two options to import data. First option we have to use whether split by, or second option we have to use a mappers. Okay, so we'll see how to import data. So here I have department table. So this department table doesn't contain any primary key. Okay, so select from DEPT. I have two records. So how to import these two records from RDBMS to HDFS. Okay, so here I'm writing Sqoop query, Sqoop import hyphen hyphen connect JDBC MySQL, then IP address of the database. So you can give IP address or alias name, and then which database related table you want to import. So retail underscore DB related, and then to connect RDBMS we have to give username. So hyphen hyphen username. So username root hyphen hyphen password Cloudera. Okay, then which table related data you want to import. -table DEPT. Then here fields terminated by. So each column separated by which symbol? Okay, pipe symbol. Okay. So end of the query, we have to specify whether split by or mappers. Then only your data will import, because this particular DEPT table doesn't contain primary key. Okay, if table doesn't contain primary key, then compulsory we have to use whether split by or mappers. Okay, so first we'll use split by. So hyphen split by. So based on which column you want to import data. Okay, so here I am specifying based on department number. Okay, so successfully retrieved two records. Okay, so we'll cross verify whether data imported to RDBMS to HDFS or not. Okay, so Hadoop FS hyphen cat user Cloudera DEPT slash part star. Okay, so successfully imported data. Okay, so using the first option we tried how to import data. Now we'll try second option, how to apply mappers. Okay, so any option we can use. So we'll try second option. So again I'm removing the department table related data from HDFS. Okay, so now again in our Sqoop query we'll apply second option. Okay, so hyphen m then space one, number of mappers one I'm specifying. Okay? So whether we have to use split by or else we have to use m1. Okay, so two records imported successfully. Now we'll cross verify data imported or not. Okay, so successfully imported data. So this is about how to import data from RDBMS to HDFS if table doesn't contain a primary key. So now even we can apply specific columns related data how to import, or you can apply based on where condition how to import a data also. Okay, so here same query, maybe I will apply condition hyphen where department number greater than 10. So only department number greater than 10 related records only you can import from RDBMS to HDFS. Okay, so here we'll cross verify. So department number greater than 10 means RDBMS side only one record is there more than department number 10 related. So here also it is showing one. So successfully imported data based on condition. Now how to import specific column related data. Okay, so I have department number and a department name, but I want to import only department number related data. Okay, then here we have to use hyphen columns. Okay, so two records imported, but we'll cross verify only department number related data imported or department name related also imported. Okay, so only department number related data imported. So how to export data from HDFS to RDBMS. Before going to export part, here we have one new concept. Okay, that is incremental append. Okay, so incremental append means in my employee table you can assume I have two records. Okay, so these two records I already imported to HDFS. Okay, but later you can assume after some time another two records I again inserted into RDBMS table. Okay, so these two records already there in my HDFS, and these two new records are available in MySQL. So that means instead of importing all the 4 records, we have to import only 2 records because already these 2 records already there in Hadoop. Okay, so every time to import a new records, that concept generally will call a incremental concept. Okay, so incremental means only latest records how to import from RDBMS to HDFS. Okay, so here we have 3 records. So these 3 records, it is available in HDFS. So now we'll insert one more new record. Okay, so here department number 40. Okay, and employee number 4. Okay, select all from employee. So these 3 records already there in HDFS, and this is a new record. So now only how to import this 4th record. So for that we have to write a Sqoop query. So here, so till here it is common. Okay, and the table name also we have to specify which table related. Okay, and from this table, okay, so hyphen check column. So based on which column you want to import. Okay, based on employee number column you want to import. Okay, and hyphen incremental append. So if we give this incremental append syntax, then only it will import the latest records. Okay, and then here hyphen last hyphen value. Then here, so last value till 3, employee number 3 we already imported. So now we want to import 4 onwards. In case if you have date column, so maybe till yesterday date you imported. Okay, that means you have to give here yesterday date. So this is the command which will import only latest records from RDBMS to Hadoop. So successfully imported. Here using cat command we can verify both record imported or not. Okay, so successfully import. So like this we can import the latest records from RDBMS to HDFS. So incremental append concept completed. Now how to export data from Hadoop to RDBMS. So now here I will truncate my data. Truncate employee. Okay. So select star from employee. There is no data in MySQL. Okay, employee table. So employee table 0 records. Okay. Now in a Hadoop I have these 4 records. So I will export this data into MySQL table. Okay. So for that we have to write a Sqoop query. Okay. So basically this till here Sqoop import. So instead of import now we are doing export, right? So here we have to give export and connectivity same only. Okay, and here hyphen table employee table hyphen export directory. So from HDFS, under which directory you have a data. Okay, so we know under which directory we have, we know, right? So under user Cloudera under employee. So here export. So now it will export the data from Hadoop to RDBMS. Okay, so here it is showing exported 4 records. So here we'll cross verify 4 records exported or not. Okay, so successfully exported to RDBMS and export HDFS to RDBMS. So this concept also completed. Now how to import data from RDBMS to Hive directly? Hive instead of HDFS, how to import to Hive? So we'll execute import query. Okay, so how to import data from RDBMS to Hive directly. So here hyphen table, and before this import, so we are applying import, right? Import, and this connectivity details same only. Hyphen create hyphen table hyphen space Hive. Okay, so hyphen table employee. Okay, and here under which database. Okay, so if we not under Hive we have many databases, right? So if we not specify database name, it will go default database. Okay, so Sqoop import and connectivity details, then hyphen Hive hyphen import means instead of HDFS it will import to Hive. This is the meaning of this syntax. Okay, hyphen create hyphen Hive hyphen table means first you create a table in Hive, then only you can import your data. Okay, table already there in Hive means you no need to specify this syntax, because existing table already table created. Only if you want to import data, then hyphen create hyphen Hive hyphen table syntax not required. Okay, now this is with the primary key. Okay, this table contains primary key, so primary key table related data we are importing to RDBMS to Hive. Okay, so retrieved 4 records it is showing, and where it is imported means a default database, and I employ table. Okay, so here show tables, so employee available, select star from employee. Okay, so only 4 records, right? 4 records successfully imported. If table doesn't contain primary key, then how to import data from RDBMS to raw table DEPT. Okay, so if table doesn't contain primary key, okay, so here our table name DEPT. Now we are importing DEPT table related data because DEPT table doesn't contain any primary key. Okay, so if table doesn't contain primary key, at the end we have to give split hyphen by, then based on which column you want to import, based on department number column, whether you can use hyphen split hyphen by, or you can use mappers m1. So data successfully imported. Okay, Hive, so select star from DEPT. Okay, so similar way you can use mappers also. Okay, so now how to export data from Hive to RDBMS. Okay, so here uncat employee. Okay, so there is no data in MySQL, so employee table 0 records. Okay, now Hive table related data I am exporting to MySQL. Okay, so for that we have to write a Sqoop export query. Okay, so table name we know, but only export directory we have to give. Okay, so my Hive data is there under this directory, user Hive slash warehouse, under warehouse employee directory. So only if it is HDFS path. If it is a Hive, your Hive data path. Okay, so table also reading data from some path, right? Okay, that path we have to give. So I exported 4 records. Okay, so here successfully exported. Now, so export concepts are completed. Okay, and import also this one completed. Okay, so import also completed. Okay, so only pending RDBMS to Hbase is pending. Okay, so incremental append concept we applied for HDFS. Okay, Now same incremental append concept how to apply for a Hive. Okay, so here see these 4 records already there in my Hive table. Okay, now I will insert one new record. Okay, a new record. So how to import only this new record to Hive? Okay, so select star from employee. So I want to import only this 5th record to Hive table. Okay, so for that we'll write a Sqoop query, and then here hyphen table employee. Okay, so here Hive hyphen import. So Hive syntaxes we have to add here. Okay, and then hyphen check column, that is same incremental append. Last value 4, right? Till employee number 4 already imported. Now only 5th related. Okay, so now Hive, right? So here select star from, see 5th record also it is showing. How to import the data from RDBMS to Hbase. So previous sessions we discussed, right, RDBMS to HDFS, RDBMS to Hive. Okay, so today first topic we will discuss about RDBMS to Hbase, and second concept Sqoop jobs creation. Okay, like how to create a job, and how to execute a job, and how to delete a job. So 3 subtopics here. Okay, and third topic eval function. Okay, so this is one built-in function is there in a Sqoop. So what is the purpose of this function, that we'll discuss. So first we'll see how to import data from RDBMS to Hbase. Okay, so with primary key table how to import, and without primary key table related data how to import. Okay, so here, so select star from employee. Okay, so I have 4 records in employee table. Now I want to import to Hbase. Okay, so this table contains a primary key. Okay, so here Hbase. So Hbase there is no table. Okay, so it is showing 0 rows. That means no tables we have to create. Okay, so now I will import this particular table related data to Hbase. Okay, using a Sqoop query. So here I will write a Sqoop query. So Sqoop required password Cloudera. Then which table related data you want to import? Employee table related data. Okay, so hyphen Hbase table. So in a Hbase, with which name you want to create table? So in a Hbase also I want a table name as employee only. Okay, and then here column family is mandatory in Hbase. Okay, so hyphen Hbase column family. So column family name here I am giving a CF1. You can give any name. Okay, and also based on which column you want to import your data. So here primary key employee number column. So Hbase row key. Okay, so row key based on which column? Employee number column. Okay, that column name we have to specify here. Okay, hyphen Hbase create table. So you can create a table because table not existed. Okay, while importing data from RDBMS to here, first you create employee table in Hbase. Okay, after that only you import data. Okay, and then hyphen fields terminated by. So data separated by pipe. Here hyphen column family. Hbase not required. Okay, okay, so retrieved 4 records. So now here Hbase. So list See here it is showing the employee table. So earlier there is no table, right? It is empty. Okay, now it is showing employee table. So if you want to check data, scan table name employee. Okay, so 4 records. Okay, successfully imported a data. Okay, so this is about with the primary key. Okay, so this table, employee table, we imported because this table contains primary key. Now if table doesn't contain primary key, then how to import data from RDBMS to Hbase? So we have department table. Department table doesn't contain any primary key. Okay, so how to import this particular table related data? Okay, so here we can use two concepts. One is split by based on which column, or else we can use mappers. Okay, mappers m1 or m2 like that. Okay, so first we'll see this one. Okay, split by we'll use. Okay, so here MySQL select a star from DEPT. Okay, so I have only two records, describe DEPT. Okay, okay, so here there is no primary key. Okay, so now I will write a Sqoop query here. Here which table related? DEPT table related. So here table name DEPT. Okay, and here also in HBase with the same name you can create. Okay, so DEPT. Okay, and a column family name whatever you want you can specify. And a department table based on which column? Here based on a department number column. Okay, so you create a DEPT table in HBase. Okay, so at the end if table doesn't contain primary key means we have to specify split by. So based on which column? Okay, so here department number column. So retrieved two records. So HBase here list. So here it is showing a DEPT table. Okay, so scan DEPT. The two records are available, so successfully imported. Okay, now disable DEPT. Okay, I'm dropping this table again. Okay, then drop DEPT. Okay, so here list. So now there is no DEPT table. Okay, so now again I will import data using mappers. So if table doesn't contain primary key means you can use a split by or else you can use a mappers. Okay, m1. So retrieved two records here. Okay, so list DEPT created and then scan DEPT. Okay, so this is about RDBMS to HBase concept. So first concept completed. Okay, now second concept. Okay, so how to create a job? Okay, so here job you can create. Inside job you specify n number of your Sqoop queries. Whenever you will execute that Sqoop query, all n number of queries one by one it will execute. Okay, so first we'll see how to create a Sqoop a job. That let me drop this um, employee table from Hbase. So disable employee. Okay, and then drop employee. So here list there is no employee table. Now how to create a job? So here you can specify your import query or your export query, whatever you want you can specify. Okay, even it is RDBMS to HDFS or RDBMS to Hive or RDBMS to Hbase. Okay, but here Sqoop, okay, job hyphen create and then your job name. I am giving here my job. So this is the syntax. Okay, so now job created or not? we have to check, right? Okay, so Sqoop job hyphen list. Okay, so here see, I created a job, my job. So here it is giving a list. Yes, my job it is created. So to check a list of jobs, you have to use this query: Sqoop space job space hyphen list. Okay, now this job contains this is the query. Okay, so if we execute this job, this query will execute, and this query related table it will create in Hbase, and it will import data. Okay, so now first step, create statement completed. How to execute job? This is a second point. Okay, so Sqoop job hyphen execute my job. Okay, so while executing Sqoop job, it will ask again password for security reasons. So we have to give again password Cloudera. So now job is executing. Okay, and the backend in Hbase it will create a table. So here it is created a table, and then your scan query, right? Scan employee. Still I think job is running, data not imported, only table created. So here scan employee, so 4 records. Okay, so second topic also completed, how to execute job. Now how to delete a Sqoop job. Okay, so here you have to specify Sqoop job hyphen delete, and then your job name. See, while creating job I specified only one query, but in real time you can create one by one n number of queries in same job. Okay, successfully deleted. So how to check whether it is deleted or not? Using a list. So here available jobs empty, it is showing, that means successfully deleted. Okay, so this is about Sqoop jobs creation and execution and deletion. Okay, now third concept, how to use eval function. So basically here if you see MySQL, every time I'm opening here one window. Okay, I'm checking here select query how many records is there or not. Okay, so instead of opening this MySQL prompt, instead of executing query here, using Sqoop query, directly you can execute these select queries. Using Sqoop query, you can connect MySQL or DBMS. Okay, so insert query or select query, whatever you want, you can execute using eval function. Okay, so now I will just close this window, MySQL window. So this is my Sqoop window. Okay, Sqoop queries. Okay, so here I will just remove all this. Okay, so till password I am keeping. Okay, and here Sqoop, so function name eval. Okay, my function name eval. So this is a database connectivity, username, password, those all are same. Here hyphen query, and within double quotes you can write any SQL query, not a Hive or not Hbase. Okay, only SQL query. So here select star from employee. That means it will connect to our DBMS. It will go to this database retail underscore DB. Under this database, this particular employee related data it will retrieve. See, successfully retrieved data. So any SQL query using a Sqoop query you can execute, but query you have to write inside this double quotes only. Even you can apply join condition in select query. Okay, and here for example you want to insert data into MySQL, so you can insert here, insert into table, which table related, employee table, values. Okay, so employee name 5, employee number 5. Okay, so employee name Ram. Okay, and then phone number, right? So here some number, and then salary, and then a department number 50. Okay, so one record updated here successfully, one record updated. Now you can check, okay, MySQL hyphen u root hyphen Cloudera, use retail underscore db, show tables, select r from employee. See, this only, right, we inserted, successfully inserted into MySQL. Okay, so this is about Sqoop. We'll discuss about Hue. Okay, so basically Hue means Hadoop user interface. Whatever queries we are executing in PuTTY, okay, so same queries we can execute even using a front end, okay, like your Hive queries or whatever, okay. But in real time, most of the people, they will use only PuTTY, okay, to execute their queries or scripts instead of Hue. Okay, so basically this Hadoop user interface looks like see, if you open any banking sites, okay, so those also web user interfaces, okay, like just you have to click buttons, okay, submit button or login button or transfer button, like that. So here also same way, just you have to enter your query, then you have to click submit buttons. Okay, so how to log in Hadoop user interface? Okay, so in real time, basically they will provide you URL, okay, to log in. So using that URL, you have to log in with your credentials. But here inside Cloudera, in our laptop, inside Cloudera, if you click Hue button, it will log in. So here it is showing URL, right, http quickstart.cloudera, but in real time, instead of this, they will provide you login URL and username and password. When we click this Hue, it will ask username and password. Okay, so here Cloudera is my username and password also Cloudera. Sign in. So successfully logged in here. First here we'll go to HDFS. Okay, so we have to click this left side menu, and then here files means HDFS. Okay, so when I click, automatically it is showing HDFS directory. Under this directory, these all are files and folders available. So same, see here it is showing automatically, okay, but if you use PuTTY, you have to execute command, then only it will show, right? Hadoop fs-ls user Cloudera. So which one is user friendly means Hue is user friendly. Okay, just there you have to click folders, automatically it will show. But here you have to execute commands, then only it will show you results. Again, now here in PuTTY, if you want to see any files from employee directory, again you have to execute your command, then only it will list out. But the same here, if you want to see, just you have to click this button, employee directory, automatically it will show. So only difference, this is just a front end, that is back end. You can execute queries back end, okay, or commands. Or if you are not comfortable with your PuTTY backend, then you can use a front end also. Okay, so here whatever directory you want, you go there, okay, and you create. Okay, so now again, so here I'm under user Cloudera directory. Okay, so I want to create my own directory. So here new directory option. So here I'm giving a new directory name, that is a testing. Okay, see now it is created successfully. But if you want to create directory using PuTTY means, you have to execute your command, mkdir command, hadoop fs mkdir, then directory path. But here it is user friendly, right? Just you have to click a new and directory. Okay, and now, so under this directory, if you want to create any file, so again go to new file here. So file name you can give any name. Okay, maybe here I'm giving a emp.txt. So successfully created a file. Okay, so if you want to delete this file, select and here move to trash. So deleted, but there you have to use input the rm command, right? Rmr command. Okay, if you want to upload any file from a local file system to HDFS, then you have to click upload button, then files. Okay, so select files. You can go to your directory, user Cloudera or home Cloudera, whatever you want you can go. So inside data, maybe I want to copy this employee.txt file from local file system to HDFS. Then you can just click open. Say successful. So this is about upload. So here you can whether even GIF files or other files also you can upload. Okay, if it is normal files, then you have to use first option. And here again, if you want to go to user directly you can click user. Okay, if you want to go to Cloudera directory, you have to click Cloudera. Okay, and these directories we created ourselves. Okay, and in case n number of directories is there here, then here also you can search like this user. Okay, Cloudera like that, or else employee. Okay, under user Cloudera employee directory is there, right? See, it is displayed. So if you have 1000 directory, you generally if you want to scroll down, it will take time, right? Instead of scroll down, here you can type that directory name. Okay, but it will list only under this directory, because we are there under user Cloudera directory. Under that directory, whatever files available, you can search here, folders or directories, both you can search. I have testing directory. Okay, so testing directory you select. Okay, so I just selected testing directory and then actions. Okay, so rename, if you want to rename the directory, then you can click rename. Okay, so here instead of testing directory, I am renaming to testing one. See, successfully renamed. Okay, directory renamed. And again I selected actions. Move means we know, right? One directory to another a directory. So here now this testing one directory I am moving under employee directory. So now here testing one directory not showing. If you go employee directory, it will show testing one directory. So successfully moved. Now again I selected testing directory, actions, copy. So copy means we know, right? Here it will keep same, and again one more copy it will place. Okay, so under user Cloudera testing directory. Okay, so if you go here Cloudera testing one directory. Okay, and if you want to give any permissions, then here change permissions. Okay, so here if you want to give full access, check you check all this. Okay, so successfully see here permissions changed. Earlier XR access, but now D means it is directory, read access, write access, X means execute a directory. So if you want to delete this entire directory, select move to trash. Yes. Okay, so only these options available in Hue for HDFS. Okay, now tables means a Hive. Okay, so here we have only one database, that is a default a database. Okay, so if you want to create a new database, here plus button. Okay, so name, database name. Okay, or digital database name. Description you can give anything. Okay, submit. So successfully created. Here if you click this, see earlier only default database, but now it is showing RR digital database. Okay, So generally in a Hive, if you want to create database name, you have to use query. Okay. So under RR digital, there is no tables. Okay. Now, if you want to create any tables, go here query. Okay. So here editor Hive. Okay. So here whatever queries you will execute in Hive, any queries, create statement or insert or join, same you can execute here. Okay. So create table employee. Okay. Number. So data types also automatically it will show. You have to just select. Okay. So ename string, phone number, begin, salary int, DEPT number int. Okay. Row format. So it will display automatically here. Delimited, fields terminated by. Okay. Fields terminated by. So pipe symbol. Okay. So once you enter your query here, this run button you have to click execute button. Okay. Now here I selected RR digital database. Okay. So it will successfully created under RR digital database employee table created. Okay. So if you execute select query, select star from employee, it will give empty results because you create a table but the data not loaded, right? See, 0 results. Okay. So your Hive queries, any query in this editor, here you can execute your queries. Okay. Same queries, putty, whatever queries you executed, same queries here you can execute. So results also it will show here itself. So here I will insert one data file. Okay. So load data local in path home Cloudera data employee.txt into table employee table. Okay. So select this, then execute. Success. Okay. Now select star from employee. See, results are successfully displayed. Okay. So in putty different way it will show, right? But here see order. We'll come to know which is which column related this data here. Table name dot column name. So this is first column employee number related. Here employee name, phone number, salary, department number. Okay. If you want save queries, you can save queries. Okay. But generally that is not required. Okay. So here query history means previously you executed what other queries you executed, those queries it will show here. Again, if you want to execute from this history, if you want to execute this query again, select star from employee, then just you click that. Okay. Then automatically it will come here and it will execute. Okay. See success. Okay. So from history you can retrieve old query. Here left side RR digital database. If you click this table name, here itself it will show column names and data types also. So you no need to execute separately again a describe command here. Okay, describe employee. Okay, so describe command giving this result, same results it is displayed here. So this is about your Hive queries. So you can execute any queries here. And here jobs. Okay, jobs means generally if you execute any jobs, here it will display OG related jobs. Okay, so maybe if you select a succeeded, that means successfully executed jobs it will show. Okay, few jobs maybe it is running right now. Then if you click this running, it will show running jobs. If you want to see failed jobs, it will show. Here Hbase, see generally Hbase Hue side people are not using because they have not given many options here in Hue. Okay, so only just enable, disable, drop like that they given. Okay, so here if you I selected from Hbase employee table. If you want to drop this, okay, click this, successfully dropped. So just they given this enable, disable, only this. Okay, so now this department table from Hbase already this is enabled mode, it is there. Okay, now I want to disable means select this table and click a disable option. So here we have to refresh, I think. Let me Hbase, yeah, see previously disabled enabled, now it is disable, it is already there in a disabled status, that's why enable button it is showing. So if you click enable now, it will enable. Okay, so successfully enabled. Now only disable it will show because already enabled mode it is there. If it is enabled mode, then it will show disable button. If it is disable mode, then it will highlight enable button under drop button. Okay, so only these three options they given Hbase, that's why people are not using. And Sqoop related also it is not working. Okay, Sqoop generally basically people will execute queries from putty only because here they have not given options. Okay, so in real time only Hive related, OG related, and HDFS also. In case if you want to log out, here a sign out button. Okay, and see right now we use the latest HEV 4 version. If you want to use old version, here switch to HEV 3 old version. Okay, see now old version. See old version HDFS option they given here. In the HEV 4 here, right, menu displayed here. See workflows. Workflows means your OG related or editors. Okay, data browsers, Hbase. Okay, and queries. If you want to execute your Hive editor, it will display here. HEV 3 version and 4 version bit difference is there. Okay, only here options are different, but queries everything same only. Okay, sign out means here. Okay, so this is about Hue.
Thanks for watching this session. Bye friends.